Hello and welcome to Pre-Algebra Practice Set number 24. And in this video, we're going to look at some additional practice problems for our lesson on divisibility rules. So we're going to start out by looking at divisibility by 2, 3, and 4. So we want to determine if each number is divisible by 2, 3, or 4. Now let me just briefly talk about the rules real quick. So if a number is divisible by 2, it's an even number, meaning its final digit is a 0, a 2, a 4, a 6, or an 8. If a number is divisible by 3, the sum of its digits, in other words, you will add the digits in the number, that number that it forms will be divisible by 3. A number will be divisible by 4. First off, it needs to be an even number, so it needs to be divisible by 2. And secondly, the final two digits of the number needs to form a number that's divisible by 4. So let's take a look at 162. And we're going to look at, again, 2, 3, and 4. So is it divisible by 2? Well, yes, the final digit of this number is a 2, so it's an even number, so this is a yes. Is it divisible by 3? Well, to find that out, I just sum the digits. So I'd say, what is 1 plus 6? That's 7. Then 7 plus 2 would be 9. 9 divided by 3 is 3 with no remainder, so this is a yes as well. This is also a yes. All right, what about 4? Well, again, if the number's already even, then I would look at the final two digits of the number and say, would 62 be divisible by 4? So I don't know that off the top of my head, so I could use a little quick long division. 4 goes into 6 once. 1 times 4 is 4. 6 minus 4 is 2. Bring down the 2. Does 4 go into 22? Well, yes, it does. It goes in 5 times. But there's going to be a remainder here. 5 times 4 is 20. Subtract, you get 2. So 62 is not divisible by 4, because 62 divided by 4 is 15 with a remainder of 2. So this is a no. This is a no. What about 188? And again, we're looking at 2, 3, and 4. So for 2, that one's easy. Look at the final digit of the number. That's an 8, so it's an even number. So the answer here is yes. What about 3? Again, we're going to sum the digits. So 1 plus 8 is 9. 9 plus 8 is 17. Now, some of you might not know if 17 is divisible by 3. So you can take that number 17 and you can add the digits again. What is 1 plus 7? Well, that's going to give me 8. And most of you know that 8 is not divisible by 3. 8 divided by 3 is 2 with a remainder of 2. So this is going to be a no. Then what about 4? Well, again, if it's even, then I would look at the final two digits of the number and say, is 88 divisible by 4? Is 88 divisible by 4? 4 goes into 8 twice. 2 times 4 is 8. Subtract, you get 0. Bring down the 8. 4 goes into 8 twice. 2 times 4 is 8. So yes, it is, right? 88 divided by 4 is exactly 22. There's no remainder. So this is a yes as well. All right, let's look at 4,743. So we have 2, 3, and 4. So if I look at the final digit of this number, it's a 3. That tells me that 4,743 is odd. So I can automatically say that this is no, and this is no. I don't need to do anything else for 2 or 4. If the number's not even, it's not going to be divisible by 2. It's not going to be divisible by 4. So the only thing left is 3. So we would add the digits here. 4 plus 7 is 11. 11 plus 4 is 15. 15 plus 3 is 18. 18 is divisible by 3. 18 divided by 3 is 6 with no remainder. So this would be a yes. All right, now we're going to look at 5, 6, and 8. So determine whether each number is divisible by 5, 6, or 8. So for 5, the rule is easy. If the final digit of the number is a 0 or a 5, the number is divisible by 5. So in this case, the final digit of the number is a 5. So this is a yes. Okay, for 6, we want to know, is the number divisible by both 2 and 3? So I don't even need to see if it's divisible by 3 because I know that it's not divisible by 2. If the number is odd, like it is in this case, it ends in a 5, then the number is not going to be divisible by 2, and therefore it can't be divisible by 6. The same thing is going to go for 8. You can't have a number that's odd be divisible by 8. a number that's divisible by 8 is going to have to be even. So this is going to be a no as well. Okay, what about 42,480? So again, we're looking at, let me just kind of change colors. We're looking at 5, 6, and 8. So again, for 5, does it end in a 0 or a 5? Well, yes, it does. It ends in a 0. So this is a yes. For 6, it needs to be divisible by both 2 and 3. The number ends in a 0, which means it's even, so it is divisible by 2. Is it divisible by 3? 4 plus 2 is 6. 6 plus 4 is 10. 10 plus 8 is 18. 18 divided by 3 is 6, no remainder. So 42,480 is divisible by 2 and also divisible by 3. So yes, it's going to be divisible by 6. Now, for divisibility by 8, it needs to be even, which in this case it is. And then we would check the last 3 digits of the number. So if the last 3 digits of the number form a number that's divisible by 8, the entire number is divisible by 8. So I would ask, is 480 divisible by 8? So we can go through and do a quick long division. 8 goes into 48 6 times. 6 times 8 is 48. Subtracting, you get 0. Bring down a 0. And you're basically saying, what is 0 divided by 8? That's 0. 0 times 8 is 0. Subtracting, you get 0. So 480 divided by 8 is exactly 60, right? There's no remainder. So this is going to be a yes as well. All right, now we look at 18,490. So again, we're dealing with 5, 6, and 8. So the number is divisible by 5 if it ends in a 0 or a 5. So we've got a 0 here, so that's going to be a yes. A number is divisible by 6 if it's divisible by 2, which in this case it ends in a 0. It's an even number, so that's a yes. And also 3. So for 3, we're going to sum the digits. 1 plus 8 is 9. 9 plus 4 is 13. 13 plus 9 is going to be 22. 22 is not divisible by 3. But if you didn't know that, what you can do is you can take the number you formed 22 and you just add the digits again. 2 plus 2, that's 4. You could just say, okay, well, is 4 divisible by 3? 4 divided by 3 will give you a remainder, right? It's 1 with a remainder of 1. So the answer is no. This number is not divisible by 3, and so it can't be divisible by 6. So this is a no. So lastly, we'd look at 8. So if the number's even, you look at the final 3 digits of the number. So in this case, it's 490. You could say, is that divisible by 8? Now, in the last problem, we dealt with 480, right? And we said 480 divided by 8 was 60. I want you to think about something for a second. Remember the trick for trailing zeros. If I did 6 times 8, that'd be 48. So if I did 60 times 8, that'd be 480. Okay, so if we know that 60 times 8 is 480, 61 times 8 would be 8 more than that, or 488. So I know that 490 is not going to be divisible by 8, right? Because 62 times 8 would be too big. It would pass this up. 61 times 8 is too small. So there will be a remainder if we divide 490 by 8. So we can go ahead and just stop there and say no. All right, now we want to determine whether each number is divisible by 9, 10, or 12. 9, 10, or 12. So 9, 10, 12. All right, so the rule for 9 is similar to the rule for 3. You sum the digits. If that result is divisible by 9, then your number is divisible by 9. So for 93,328, we make a sum here. 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 2 is 17. 17 plus 8 is 25. Now, most of you will know that 25 is not divisible by 9. But if you get that result and you're unsure, you can go through and just add the digits of the new number that you just got. So 2 plus 5 is 7. 7 is definitely not divisible by 9. So this is a big fat no. This is a no. What about 10? For a number to be divisible by 10, the final digit has to be a 0. Our final digit is an 8, so this is a no as well. What about 12? For a number to be divisible by 12, it needs to be divisible by 3, and it needs to be divisible by 4. Now, if I look at the final 2 digits of this number, 28 is divisible by 4. 28 divided by 4 is 7. So I need to check and see if it's divisible by 3. So again, 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 2 is 17. 17 plus 8 is 25. 25 is not divisible by 3. And again, if you want to, you can add 2 plus 5, the digits in the 25, to get 7 and say, okay, is 7 divisible by 3? No, it's not. So we would put a no here. It's not divisible by 12 because it's not divisible by 3. What about 38,979? Again, we're looking at 9, 10, and 12. So for 9, we sum the digits. 3 plus 8 is 11. 11 plus 9 is 20. 20 plus 7 is 27. 27 plus 9 is 36. 36 is divisible by 9. 36 divided by 9 is 4, no remainder. So this one is going to be a yes. What about 10? Number is divisible by 10 if the final digit is a 0. So this one's going to be a no. And then what about 12? If a number is divisible by 9, it's automatically divisible by 3. So we're covered there. But this number is an odd number. If you have an odd number, it's not going to be divisible by 4. So it fails the divisibility by 4, so no, it's not going to be divisible by 12. Again, for divisibility by 12, it has to be divisible by both 4 and 3. What about 18,360? Well, again, we're looking at 9, 10, and 12. So for 9, we sum the digits. 1 plus 8 is 9. 9 plus 3 is 12. 12 plus 6 is 18. 18 plus 0 is still 18. 18 divided by 9 is 2 with no remainder. Or you could say, okay, 18, add those digits. 1 plus 8 is 9. 9 divided by 9 is 1, no remainder. You can keep adding until you get to a number that you recognize whether or not it's divisible by 9 or not. But yes, it is going to be divisible by 9. What about 10? Number is divisible by 10 if the final digit is a 0. So this one's going to be a yes also. What about 12? A number is divisible by 12 if it's divisible by both 4 and 3. So we know it's divisible by 3. If a number is divisible by 9, it's automatically divisible by 3. Is it divisible by 4? Well, it's even, and the final two digits would make the number 60. 60 divided by 4 is 15, no remainder. So this is yes. So now we're going to look at 7 and 11. And basically this is one of the kind of harder situations that you come across because you have to go through a step-by-step procedure to see if you have divisibility by these two numbers. In fact, a lot of teachers just skip these two numbers over. So determine whether each number is divisible by 7 or 11. So I have 3,192. So divisibility by 7. Let's start with that. Now, the procedure goes as follows. You're going to cut off the final digit of the number. So in this case, it's a 2. I'm just going to chop that off, and I'm going to have the number 319 now. I'm going to take this number that I chopped off, and I'm going to double it. So 2 times 2 is 4. When I double a number, I multiply it by 2. 2 times 2 is 4, and then I subtract it away from this shortened number. So 319 minus 4 is 315. So if the number formed is a 0, or it's a number that's divisible by 7, we know that the original number is divisible by 7. Now, in this case, I have 315. I don't know if that's divisible by 7 or not, so I keep going. I know it's not a 0. So I just repeat the process again. So let me erase this, and we're just kind of starting with 315. So you would cut off the final digit, okay, and so you just have the number 31. So you have 31, you multiply the digit that you cut off by 2, 5 times 2 is 10, and you subtract it away. So 31 minus 10 is 21. Now, I know that 21 is divisible by 7. I know that from watching football, right? 3 touchdowns with extra points, 21 points. So 21 divided by 7 is 3. No remainder. So then I can stop here and say, yes, this number is divisible by 7. Yes. Now what about 11? The rule for 11 is a little peculiar also. So what I'm going to do is I'm going to number the digits. So for 11, I'm going to number the digits. Let me see here. Get a little room going. I got 3,192. So this is digit 1, this is 2, this is 3, this is 4. So what I'm going to do is sum the digits that are in the odd places. meaning the digits that's in position 1 and 3. So 3 plus 9. And then I'm going to subtract away the sum of the digits in the even places. So 1 plus 2. 1 plus 2. Now, if the result here is either a 0 or divisible by 11, you know your original number is divisible by 11. So 3 plus 9 is 12. Then we're subtracting away 1 plus 2, that's 3. So 12 minus 3 is 9. 9 is not divisible by 11. So this is a big fat no. No. Let's take a look at one more. We're looking at 7 and 11. So for 7, this might take a little time. So this is one of those ones that's just very tedious. Again, we're going to cut off the final digit of this number, 3,252,480. So 3,252,48. And I'm going to take this final digit that I cut off, multiply it by 2, but 0 times 2 is 0. And then I would subtract it away, but if I subtract away 0, I have the same number. So I don't know if this is divisible by 7, I just keep going. So I'm going to cut off this 8, and I'm going to have 32524. So 32,524. I'm going to double that number that I cut off. So 8 times 2 is 16, and I'm going to subtract it away. Let me scroll down here. 14 minus 6 is 8. 1 minus 1 is 0. Everything else can just come down. So I have no idea if this is divisible by 7 yet, so I keep going. Cut off this digit, and I'm going to have 3250. I'll double 8, that's going to give me 16, and subtract it away. So borrow here. 10 minus 6 is 4. 4 minus 1 is 3. Bring this down, bring this down. Continue. I'm going to cut this off. I'm going to have 323, and I'm going to double 4, that's 8, and I'm going to subtract it away. So borrow here. 13 minus 8 is 5. Bring down the 1, bring down the 3. Cut this off. So now I'm going to have 31. I'm going to double 5. That's going to give me 10. And I'm going to subtract it away. So I'm going to get 21. And again, I know that that's divisible by 7 because of watching football. I know that's 3 touchdowns. 7 times 3 is 21. So I can go all the way back up here and say that this is a big fat yes. What about 11? So I'm going to take my number, and I'm going to number it. I start out at the very left, and I'm going to say that that is 1. Then this is 2, then 3, then 4, then 5, then 6, then 7. So what I'm going to do is I'm going to sum the numbers that are in the odd places. So the numbers that are in the first position, the third position, the fifth position, the seventh position. So 3, which again is in the first position, plus 5, which again is in the third position, plus 4, which is in the fifth position, plus 0, which is in the seventh position. Then I am subtracting away the sum of the numbers in the even places. So in the second position, I have a 2. Then plus in the fourth position, I have a 2. Then plus in the sixth position, I have an 8. Now, if the result is a 0 or something divisible by 11, my original number is divisible by 11. So 3 plus 5 is 8. 8 plus 4 is 12. 12 plus 0 is still 12. Subtracting away, 2 plus 2 is 4. 4 plus 8 is 12. So 12 minus 12 is 0. So yes, if I get, again, a 0 or something divisible by 11, my original number is divisible by 11. Here I got a 0. So I'm going to put a big fat yes next to 11. Hello and welcome to Pre-Algebra Test Section 1 on divisibility rules. All right, so we want to determine if each number is divisible by 2, 3, 4, 5, or 6. So we're going to start out with 58,738. So let's write out the numbers we're trying to find if this number is divisible by. Again, we have 2, 3, 4, 5, or 6. Now, if you didn't watch the lesson, I would advise you to go back and watch it, at least so you can write down the rules that I gave you. If not, you can write them down here. A number is divisible by 2 if the final digit is a 0, a 2, a 4, a 6, or an 8, meaning it's an even number. Now, this number ends in an 8, so it is even, and so it is divisible by 2. So this is a yes. A number is divisible by 3 if the sum of its digits forms a number that's divisible by 3. So I would go through and sum the digits here. So 5 plus 8 is 13. 13 plus 7 is 20. 20 plus 3 is 23. And then 23 plus 8 is 31. Now 31 is not divisible by 3. But one of the things you can do if you add the digits and you get 31 and you say, well, I don't know if that's divisible by 3. You can add the digits again. So I can take 31 and do, okay, what's 3 plus 1? That's 4. And most of you will now know that 4 is definitely not divisible by 3. So this number is not divisible by 3. So this is a big fat no. All right, what about divisibility by 4? Well, the first thing is a number is divisible by 4 if it's divisible by 2. Okay, so it has to be an even number. And then also the final 2 digits of the number have to form a number that's divisible by 4. So if you look at 38, and we were to say 38 divided by 4 equals what? Would that result give us a remainder or not? Well, these numbers are small enough to where we could work backwards. What times 4 would equal 38? Well, I know that 9 times 4 is 36. That's too small. And 10 times 4 is 40. That's too big. So unfortunately, this would produce a remainder, 38 divided by 4. So because 38 is not divisible by 4, this number 58,738 is not divisible by 4. So this is going to be a no. This is a no. Next, we look at divisibility by 5. So a number is divisible by 5 if it ends in a 0 or a 5. This number ends in an 8, so the answer is going to be no. And then for 6, a number is divisible by 6 if it's divisible by both 2 and 3. Has to be divisible by both. So I can just look back here and say, yes, it's divisible by 2, but no, it's not divisible by 3. So because it's not divisible by 3, it's not going to be divisible by 6. All right, look at 24,665. So again, we're looking at 2, 3, 4, 5, and 6. So is this number divisible by 2? Well, the answer here is no, right? This number is odd. It ends in a 5. So again, a number has to be even to be divisible by 2, meaning it has to end in a 0, a 2, a 4, a 6, or an 8. This ends in 5, so it's an odd number, and this is going to be a no. Now, I can answer a lot of questions based on that no. I can answer 4 with a no, and I can answer 6 with a no. If a number's not even, it's not going to be divisible by 4. It has to be divisible by 2 to be divisible by 4. If a number is not divisible by 2, it can't be divisible by 6. For a number to be divisible by 6, it has to be divisible by both 2 and 3. So those are all no's. Let's check 3 and 5. So for 3, I sum the digits. So 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 5 is 23. Now that's not divisible by 3. And again, if you get to the conclusion of 23 and you go, well, I don't know if that's divisible by 3 or not, you can add the digits again. 2 plus 3 would give you 5. 5 is definitely not divisible by 3. Right? You can keep adding until you get the simple one-digit number. So this would be a no also. Now what about 5? Is this divisible by 5? Well, yes, it is. A number is divisible by 5 if the final digit is a 0 or a 5. So the final digit here is a 5. So this is going to be a yes. What about 79,200? So again, we're looking at 2, 3, 4, 5, and 6. All right, so we're starting out with 2. A number is divisible by 2 if it's even, and this number ends in a 0. So it is an even number, so this is going to be a yes. What about 3? Well, we'd sum the digits. 7 plus 9 is 16. 16 plus 2 is 18. So you could either stop there and say, okay, 18 divided by 3 is 6, no remainder, so it's a yes. Or you could take that 18 and you could add again. You could say 1 plus 8 is 9. 9 divided by 3 is 3, no remainder. So either way, this is a yes. What about 4? Well, you'd start out by asking, is it even, right? Is it divisible by 2? The answer is yes. And then you look at the final 2 digits of the number. In this case, we have a double 0, which is just 0. And we say, is 0 divisible by 4? Yes, it is. Don't say no. Yes, it is. 0 divided by 4 is 0 with no remainder. So it is divisible by 4. So this is a yes as well. What about 5? That's going to be a yes because the final digit of the number is a 0. And the final digit of the number, if it's a 0 or a 5, that number will be divisible by 5. Then lastly, is it divisible by 6? Well, we look at 2 and we look at 3. If a number is divisible by both 2 and 3, it is divisible by 6. So this is a yes as well. Hello and welcome to Pre-Algebra Test Section 2 on divisibility rules. All right, so we want to determine if each number is divisible by 2, 3, 4, 5, or 6. So let's start out with 21,820. So we have 2, 3, 4, 5, or 6. So we start out with 2. A number is divisible by 2 if it's even, so that means the final digit is a 0, a 2, a 4, a 6, or an 8. This final digit is a 0, so this is a yes, right? This number is even, so it is divisible by 2. For divisibility by 3, we sum the digits. So 2 plus 1 is 3, 3 plus 8 is 11, 11 plus 2 is 13. So is 13 divisible by 3? And if you don't know the answer to that and you don't want to go through and do long division, you could then take the 13, the result you got, and you could add the digits again. What's 1 plus 3? That's 4. And you could say, is 4 divisible by 3? 4 is not divisible by 3. 4 divided by 3 is 1 with a remainder of 1. So this one is a no. What about 4? Well, the first thing is it needs to be even, right? Which we know it is because it's divisible by 2. The second thing is we look at the final two digits of the number. If it forms a number that's divisible by 4, which in this case we'd have 20, 20 divided by 4 is 5, no remainder, then the entire number is divisible by 4. In this case, it's going to be a yes. Because again, this 20, the final two digits of the number, is divisible by 4. All right, for 5, we want to look at the final digit of the number. If it's a 0 or a 5, the number is divisible by 5. So here we have a 0. And so yes, this is going to be divisible by 5. For 6, we don't need to do any additional work. We've already done the work. For 6, we're looking at divisibility by both 2 and 3. Has to have both, can't just have one. So in this case, it's yes here and no here. So it's not going to be divisible by 6, right? It has to be divisible by both, and it fails for divisibility by 3. All right, let's take a look at 39,702. So we're looking at 2, 3, 4, 5, and 6. So is it divisible by 2? Yes, the final digit is a 2. This is an even number, so this is yes. Is it divisible by 3? Sum the digits. 3 plus 9 is 12. 12 plus 7 is 19. 19 plus 2 is 21. 21 is divisible by 3. 21 divided by 3 is 7. Or what you can do is take that 21, the results you got from summing the digits, and you could sum the digits again. 21 has a 2 and a 1, so 2 plus 1 is 3. Of course, 3 is divisible by 3. 3 divided by 3 is 1, no remainder. So this is a yes. What about 4? For 4, it has to be even, so that's a yes. And it has to have the final two digits of the number form a number that's divisible by 4. Now, if we look at it, we have 2. 2 is not large enough to split up into equal groups of 4 without going into fractions or decimals, right? Just talking about using whole numbers. So 2 divided by 4 would be 0 with a remainder of 2. So this would be a no. This is a no. Then what about 5? We're looking at the final digit of the number. If it's a 0 or a 5, the number is divisible by 5. In this case, we have a 2, right? So that's going to be a no as well. What about 6? Well, again, a number is divisible by 6 if it's divisible by both 2 and 3. So it is divisible by 2, and it is divisible by 3. So this is going to be a yes as well. Last one, we have 13,680. So again, is it divisible by 2, 3, 4, 5, and then 6? So divisibility by 2. The final digit is a 0, so this is a yes. What about 3? Well, you'd sum the digits. 1 plus 3 is 4, 4 plus 6 is 10, 10 plus 8 is 18, 18 plus 0 is still 18. And you could stop there and say, okay, well, 18 divided by 3 is 6, no remainder. Or you could sum the digits again. If you take 18 and you sum the digits, 1 plus 8 is 9. So 9 divided by 3 is 3, no remainder. Either way, it's a yes. Then what about 4? Well, it has to be even, and it is, right? It's divisible by 2. And it has to have the final 2 digits of that number form a number that's divisible by 4. I think most of us know that 80 divided by 4 is 20, right? No remainder. So this is also a yes. What about 5? For 5, the final digit must be a 0 or 5, so this is going to be a yes. And then for 6, we know it's going to be a yes because it has to be divisible by both 2 and 3, and in each case it is. So this number, 13,680, is divisible by 2, 3, 4, 5, and 6. Hello and welcome to Pre-Algebra Test Section 3 on divisibility rules. All right, so we want to determine if each number is divisible by 5, 6, 8, 9, or 10. So we're starting out with 18,608. So again, we're working with 5, 6, 8, 9, and then 10. So what's the rule for 5? Well, we look at the final digit of the number. If it's a 0 or a 5, that means the number is divisible by 5. Our final digit's an 8, so this is going to be a no. Now we move on to 6. A number is divisible by 6 if it is divisible by 2 and also divisible by 3. So I know it's divisible by 2 because the last digit is an 8, which means this is an even number. Is it divisible by 3? Well, I would sum the digits up. 1 plus 8 is 9, 9 plus 6 is 15, 15 plus 8 is 23. Now you can stop there and say, is 23 divisible by 3? Or you could add the digits in 23. 2 plus 3 is 5, and you could just say, is 5 divisible by 3? 5 is not divisible by 3. 5 divided by 3 is 1 with a remainder of 2. Because this number is not divisible by 3, it's not going to be divisible by 6. So this is a no. What about divisibility by 8? Well, for divisibility by 8, the number has to start off by being even. So that's a yes, right? The final digit's an 8. That's okay. Then we look at the final 3 digits of the number. If the final 3 digits of the number form a number that's divisible by 8, the number's divisible by 8. So I would have to go through and say, okay, 608 divided by 8 equals what? 8 goes into 60 7 times. 7 times 8 is 56. Subtract, you get 4. Bring down the 8. 8 goes into 48 6 times. 6 times 8 is 48. Subtract, you get 0. So 608 divided by 8 is 76 with no remainder. So this is going to be a yes. This is going to be a yes. What about 9? Well, I can tell you already that's going to be a no. We summed these digits already. We found that the sum was 23, and 23 is not divisible by 9. So this is going to be a no. Then lastly, we have 10. So a number is divisible by 10 if the final digit is a 0. Our final digit's an 8, so this is a no as well. What about 28,926? So again, we're working with, we have 5, 6, 8, 9, and 10. So a number is divisible by 5 if the final digit is a 0 or a 5. So this is going to be a no. A number is divisible by 6 if it's divisible by 2. In this case it is, right? The final digit is a 6, so it's an even number. And if it's also divisible by 3. So if I sum the digits here, 2 plus 8 is 10, 10 plus 9 is 19, 19 plus 2 is 21, 21 plus 6 is 27. So I can do 27 divided by 3, or I could sum the digits in 27. 2 plus 7 is 9. 9 divided by 3 is 3, no remainder. So either way, it is divisible by 3. And so because it's divisible by both 3 and 2, this is a yes. What about 8? We look at the final 3 digits of the number, and we see that it's 926. So is that divisible by 8? 8 goes into 9 once. 1 times 8 is 8. Subtract, bring down the 2. 8 goes into 12 once. 1 times 8 is 8. Subtract, bring down the 6. 8 goes into 46. We already know there's going to be a remainder here. If you think about what times 8 would give you 46, so 5 times 8 is 40. 6 times 8 is 48. That's too big. All right, so if I put a 5 here, 5 times 8 is 40. We subtract and we have a remainder of 6. So this is going to be a no. This number is not divisible by 8 because 926, the final 3 digits of the number, is not divisible by 8. So for 9, we've already summed the digits and found that it was 27. So you can say that 27 divided by 9 is 3, no remainder. Or you could keep summing the digits. So you could say, okay, I got 27, and I would sum the digits again. I get 2 plus 7, that's 9. And then try it. 9 divided by 9 is 1, no remainder. So either way, this is a yes. What about 10? For a number to be divisible by 10, the final digit should be a 0. In this case, it's a 6. So this is going to be a no. All right, last one, we have 280,800. So again, the numbers we're working with, we have 5, 6, 8, 9, and 10. So for 5, the final digit should be a 0 or 5. In this case, it's a 0, so this is a yes. For 6, the number should be divisible by both 2 and 3. So its final digit is a 0, meaning it's even, so it's divisible by 2. And the sum of the digits, you have 2 plus 8, that's 10. Plus 0 is still 10. Plus 8 is 18. Plus 0 is still 18. Now, 18 divided by 3 is 6, no remainder. Or you could take that sum that you got, 18, and you could sum the digits again. 1 plus 8 is 9. Then try it. 9 divided by 3 is 3, no remainder. So either way you do that, it's going to be a yes. What about 8? Well, again, it's got to be even, and the last 3 digits of the number, which is 800 in this case, has to be divisible by 8. Most of you will know that 800 divided by 8 is exactly 100, right? There's no remainder, so this is also a yes. What about 9? Well, we previously summed the digits here, and we found that we got 18. Again, 18 divided by 9 is 2, no remainder. Or sum the digits for 18. 1 plus 8 is 9. Then do it again. 9 divided by 9 is 1, no remainder. So this is also a yes. And then for 10, the final digit is a 0. So this is divisible by 10. So this is a yes as well. So 280,800 is divisible by 5, 6, 8, 9, and 10. Hello and welcome to Pre-Algebra Test Section 4 on divisibility rules. All right, so we want to determine if each number is divisible by 8, 9, 10, or 12. So let's take a look at 92,502. So again, we want to know if it's divisible by 8, 9, 10, or 12. So what about 8? Well, the number has to be even, which in this case it is. And then the final 3 digits of the number needs to form a number that's divisible by 8. So we look at the final 3 digits. So 502. Is that divisible by 8? 8 goes into 50 6 times. 6 times 8 is 48. Subtracting, you get 2. Bring down the 2. You could stop there if you want. 8 goes into 22 twice. You're going to have a remainder. 2 times 8 is 16. Subtract. 12 minus 6 is 6. So that's your remainder. So this answer is going to be no. What about 9? For 9, you sum the digits. So 9 plus 2 is 11. 11 plus 5 is 16. 16 plus 2 is 18. So you can say, okay, is 18 divisible by 9? Or that answer that you got where you sum the digits, you could sum the digits again. The same trick will work. So 1 plus 8 would be 9. You could also say, is 9 divisible by 9? Either way, the answer is yes. 18 divided by 9 is 2, no remainder. 9 divided by 9 is 1, no remainder. So this is a yes. For 10, we look to see if the number is ending with a 0. If it's not, then it's not divisible by 10. In this case, our final digit's a 2, so this is a no. Lastly, we look at 12. So for a number to be divisible by 12, it needs to be divisible by 4 and 3. So I know that it's divisible by 3 because it's divisible by 9. But for 4, it needs to be even, which it is, and then the final 2 digits of the number, which in this case it would just be the number 2, needs to form a number that is divisible by 4. 2 is not divisible by 4. 2 divided by 4 would be 0 with a remainder of 2. So this is going to be a no. All right, next we look at 47,736. So again, we were looking at 8, 9, 10, and 12. 8, 9, 10, and 12. So for 8, again, you're looking at, is it even, which in this case it is, and what about the final 3 digits of the number, the 736? Is that divisible by 8? 8 goes into 73 9 times. 9 times 8 is 72. Subtract them and get 1. Bring down the 6. 8 goes into 16 twice. 2 times 8 is 16. Subtract and you get 0. So your answer here is going to be yes, right? Because 736 divided by 8 is exactly 92, right? There's no remainder. So this is going to be a yes. What about 9? Again, for 9, we sum the digits. So 4 plus 7 is 11. 11 plus 7 is 18. 18 plus 3 is 21. 21 plus 6 is 27. So most of you know 27 divided by 9 is 3, no remainder. If you don't, you can continue. You can take 27 and sum the digits again. 2 plus 7 is 9. And then you know that 9 is divisible by 9, right? 9 divided by 9 is 1, no remainder. So this is a yes. What about 10? That's probably the easiest one here. Just look at the final digit. If that's not a 0, then the answer is no. What about 12? For 12, it needs to be divisible by 3, which in this case, because it's divisible by 9, it's automatically divisible by 3. And it needs to be divisible by 4. So look at the final 2 digits of the number. If a number is divisible by 4, the final 2 digits of the number, which in this case it would be 36, should be divisible by 4. 36 divided by 4 is 9, no remainder. So this is a yes. Also, we could have said that if a number is divisible by 8, it's automatically divisible by 4. Either way, yes, it's going to be divisible by 12. All right, let's take a look at 181,440. So again, we're working with the numbers 8, 9, 10, and 12. So what about 8? Again, we're looking at the final 3 digits of the number. Looking at 440. Is that divisible by 8? So 440, divide that by 8. 8 goes into 44 5 times. 5 times 8 is 40. Subtract and you get 4. Bring down the 0. 8 goes into 45 times. 5 times 8 is 40. Subtract and you get 0. So this is going to be a yes. This is going to be a yes. And again, because 440 divided by 8 is 55 with no remainder. All right, what about 9? Again, sum the digits. 1 plus 8 is 9. 9 plus 1 is 10. Then plus 4 is 14. Plus another 4 is 18. Plus 0 is still 18. We know that 18 divided by 9 is 2, no remainder. Again, you could continue. You could take 18 and then sum those digits. 1 plus 8 is 9. Then use the trick. 9 divided by 9 is 1, no remainder. Either way, this is yes. What about 10? Again, look at the final digit of the number. If that's a 0, then this is a yes. In this case, we do have a 0, right? So it is divisible by 10. And then what about 12? Well, all I need to do is look at the 8 and the 9. If it's divisible by 8, it's divisible by 4. If it's divisible by 9, it's divisible by 3. For 12, we need divisibility by 4 and 3. So this is going to be a yes. Hello and welcome to Pre-Algebra Test Section 5 on divisibility rules. All right, let's look at some where we test out divisibility by 7 or 11. So determine if each number is divisible by 7 or 11. So we have 104,720. So the test for 7 is a bit time consuming. You cut off the final digit of the number. So if I cut that off, I'd have 10472. So 10,472. I then take that final digit that I cut off, I double it. So I multiply it by 2. 0 times 2 is still 0. Now, I subtract that away from this new number that I have. If I subtract away 0, I have the same number. At the end of this process, if I don't have a number that's either 0 or something that I recognize as divisible by 7, I just repeat it. So I cut off the final digit. So cut that off, I'd have 1047. Then I'm going to double this. 2 times 2 is 4, and subtract it away. So this would be 1043. So it's not 0, and I don't know if it's divisible by 7 or not yet, so I'm going to continue. So I'm going to cut off the final digit of the number. I'd have 104. Double that number. 3 times 2 is 6, and subtract. I'm going to borrow here. This will become 10, then 9, then 14. So 14 minus 6 is 8. Bring down the 9, and I have 98. At this point, you could stop because 98 is divisible by 7. 98 divided by 7 is exactly 14. But if you didn't know that, you could continue. You could cut off the 8, so you'd have a 9, cut off the 8 and double it. So 8 times 2 is 16. So I'm saying, what is 9 minus 16? So we're involving some negative numbers here. So what is 9 minus 16? That's the same thing as 9 plus negative 16. So the larger absolute value wins. So this would be a negative. And then you do 16 minus 9, and that's 7. So ask yourself the question, is negative 7 divisible by 7? Well, the answer is yes, it is. Negative 7 divided by 7 is negative 1. There's no remainder. Let's put a 7 here and say yes. Now for 11, what we do is we number the digits. We number our digits. So we have 104,720. Start right here. Let me change colors. So start at the left. That's digit number 1. Then this is going to be 2, then 3, then 4, then 5, then 6. So you're going to take all your digits that are in an odd place, meaning the digits that's in position of 1, 3, and 5. You're going to add them together. So you'll have 1 plus 4 plus 2. And then I'm going to subtract away the sum of the digits that are in the even places. So in 2, 4, and 6. So I have a 0 plus a 7 plus another 0. So this is just 7. So when I perform this operation, I'm looking for either a 0 or a number that is divisible by 11. Either way, it will tell me it's divisible by 11. If I don't get that result, it's not. So 1 plus 4 is 5, 5 plus 2 is 7. And then minus, here I have 0 plus 7 plus 0, that's 7. So I do get a 0, so this number is divisible by 11. So this is also a yes. All right, now we're looking at 334,180. So again, to do divisibility by 7, cut off the last digit. So we'd have 33418. So 33,418. Double the digits you cut off and subtract it away. 0 times 2 is 0. Subtract it away, you get the same thing. Repeat the process. Take this away. So you get 3341. Double what you took off. So 8 times 2 is 16. Subtract it away. 11 minus 6 is 5. 3 minus 1 is 2. Bring down the 3 and the 3. So I get 3,325. So let me just erase this. 3,325. Keep going. I'm going to cut this off, and I'm going to double it. So 332 is what I have, 332. Double 5, you get 10. Subtract it away. 2 minus 0 is 2. 3 minus 1 is 2. Bring down the 3. So I get 322. And I'm going to continue. So cut this off. I'll just have 32. Double 2, you get 4. Subtract that away. So 32 minus 4 is 28. And I immediately recognize that 28 is divisible by 7. Right? From watching football, I know that if a team gets 4 touchdowns and 4 extra points, they have 28 points on the board. So 7 times 4 is 28, or 28 divided by 7 is 4. So this is going to be a big fat yes. All right, what about 11? Again, number the digits. So 11, we have 334180. So I'll number the digits. Starting at the leftmost number, it's a 1, then 2, then 3, then 4, then 5, then 6. So the odd positions, this one, and this one, you're going to sum those numbers. So 3 plus 4 plus 8. 3 plus 4 plus 8. Subtract away the sum of the even positions. So here, here, and here. So 3 plus 1 plus 0. Now, if the result is 0 or something divisible by 11, the number is divisible by 11. 3 plus 4 is 7. 7 plus 8 is 15. Subtracting away, 3 plus 1, that's 4. Plus 0 is still 4. So 15 minus 4 is 11. 11 is divisible by 11. 11 divided by 11 is 1, no remainder. So this is a big fat yes as well. Okay, let's take a look at one final problem. We have 1,049,070. So divisibility by 7. Again, cut off the final number. So you'd have 1,04907. So 104,907. Double the number you cut off. If you double 0, you have 0. Subtract it away. You subtract away 0, you have the same number. So do it again. Cut off the 7. So I'd have a 10490. So 10,490. Double 7. 7 times 2 is 14. Subtract it away. So I borrow here. 10 minus 4 is 6. 8 minus 1 is 7. Bring down the 4, the 0, and the 1. And I have 10,476. Continue. So 10,476. Cut off the final digit. So I have 1,047 now. Double that 6, you'll get 12. Subtract. 7 minus 2 is 5. 4 minus 1 is 3. Bring down the 0 and the 1. So I have 1,035. Cut off the 5. I have 103. Double it. 5 times 2 is 10. Subtract it away. 3 minus 0 is 3. 10 minus 1 is 9. So I have 93 now. So cut off the 3, and you'll just be left with 9. So I'll have a 9. Double 3, and you'll get 6. Subtract that away, and you get 3. 3 is definitely not divisible by 7. So we can stop here and say that the answer is no. All right, what about 11? So what I can do, again, number the digits in the number 1,049,070. So 1,049,070. So we're looking at odd and even. So start at the left. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. What you're doing is you're adding all the digits that are in an odd position. So you take 1, that's in the first position. You add it to 4, that's in the third position. You add it to 0, that's in the fifth position. And you add it to 0, that's in the seventh position. All right, these are all your odd numbered positions you can think of. Again, 1 is in the first position, 4 is in the third position, 0 is in the fifth position, 0 is in the seventh position. Now I'm going to subtract away the sum of the numbers that are in the even position. So I'm just looking at kind of the opposite of just what I did. So the number that's in the second position is 0. Then plus the number that's in the fourth position is 9. Then plus the number that's in the sixth position is 7. Now, if the result here is either 0 or divisible by 11, the number's divisible by 11. So 1 plus 4 is 5, plus 0 is still 5. Then minus, we have 0 plus 9 plus 7. That's 16. Now, 5 minus 16 is negative 11. Now, you might go, well, we'll have some negatives involved here. That doesn't matter. Negative 11 divided by 11 is negative 1. There's no remainder. So that's the definition of divisibility. Since negative 11 divided by 11 is negative 1 with no remainder, negative 11 is divisible by 11. So this is a yes. We can go back up here and put a yes. This number will be divisible by 11. Hello and welcome to Pre-Algebra Practice Set number 25. In this video, we're going to look at some additional practice problems for our lesson on factoring whole numbers. So we begin with a basic exercise. Determine if each number is prime, composite, or neither. So remember, we think about the whole numbers, starts with 0, increases in increments of 1, out indefinitely. Now, for the definition of a prime number, you're only thinking about the whole numbers larger than 1. So you exclude 0 and 1. And that's the same for the composite number as well. So when you look at the numbers in this group, any number that is only divisible by 1 or itself is prime. Any number that is divisible by something other than 1 or itself is composite. And then the numbers that would be neither would be 0 and 1. They're excluded from the definition of prime or composite, right? Because it's any whole number larger than 1. Okay, so let's start out with the number 7. So how do we tell if this number is prime, composite, or neither? Well, it's in that group of numbers, again, starting with 2 and increasing out in increments of 1 out indefinitely. So I know it's not neither. So it's either prime or composite. So one of the two. Now, one of the ways that your book probably tells you is to look at the numbers. So if it's 7, you would look at 1 less. So you'd look at 6, you'd look at 5, 4, 3, 2, and you wouldn't look at 1 because in the definition of a prime number, it's divisible by 1 in itself. That's why we didn't look at 7. It's not an even number, so it's not divisible by 2, 4, or 6. 7 is not divisible by 3, and it's not divisible by 5, so this is a prime number. Now, a quick way to do this when we start getting into larger numbers is to take the square root of the number. And again, I talked to you in the lesson about the fact that we hadn't covered square roots yet, but you could just punch up the square root of 7 on your calculator. When you do that, you're going to get about 2.64, right? Not exactly, but about. So what you do is just go to the next highest whole number. So that would be 3. So all you need to do is test the prime numbers up to and including that number, which is 3. So I would just test 2 and 3. I don't really need to test 2 because it's not an even number. I would just look and say, is 7 divisible by 3? No, it's not. 7 divided by 3 is 2 with a remainder of 1. So again, this is a prime number. What about 9? Well, I know 9 is not prime because it's divisible by 3, right? 9 divided by 3 is 3 with no remainder. So this is composite. What about 189? Well, I can use my trick here. I could take the square root of 189, and that would give me about 13.74. So I could go to the next highest whole number, which would be 14, and I could test all the prime numbers. So I could start with 2 and go 2, 3, 5, 7, 11, and then 13. 14 is a composite number. I wouldn't need to check that. So it's not divisible by 2 because it's not even, so I can cross that out right away. Is it divisible by 3? Well, 1 plus 8 is 9, 9 plus 9 is 18. 18 is divisible by 3, so yes, this number is composite. Next, we look at 1. 1 is going to fall into the category of neither. And the reason we put neither here is because in the definition of a prime number and in the definition of a composite number, it specifically states that we're looking at whole numbers larger than 1. So 0 and 1 are excluded. If you get this question on a test, you just put neither. What about 17? So the square root of 17 is about 4.12. So just go to the next highest whole number, that would be 5. So I would test all the prime numbers up to and including 5. So 2, 3, and 5. I don't need to check 2 because this number's not even. Is 17 divisible by 3? 1 plus 7 is 8. 8 is not divisible by 3. So 17 is not divisible by 3. And the final digit of the number is not a 0 or a 5. So it's not divisible by 5. 17 is a prime number. This is a prime number. All right, so now we want to use a factor tree to find the prime factorization of each number. So we're going to start out with 100. So to build a factor tree, I start by just writing the number, and I extend what are called 2 branches, basically just 2 lines coming underneath the number. And I think of any 2 factors for that number. Doesn't matter what they are. 100 I could think of as 25 times 4, or I could do 10 times 10, or I could do 2 times 50. It doesn't matter, you're going to end up with the same answer at the end. So let's do 4 times 25. Now the next thing we do is we check to see if either number is prime. 4 is not prime, it's divisible by 2. 25 is not prime, it's divisible by 5. So then what we do is we just repeat the process under each number. So 4 I'm going to write as 2 times 2. Now 2 is prime, so I'm going to just stop and circle those. Okay, now I'm going to stop. I'm going to look at 25. I'm going to extend the branches and just repeat the process. 25 is 5 times 5. Now 5 is a prime number, so I'm going to circle each one and I'm going to stop. Now once I've stopped everywhere, I have nothing else to continue. I'm not repeating anywhere. I've found the prime factorization for the number. So we have 100 is 2 times 2 times 5 times 5, or 2 squared times 5 squared. What about 230? Again, write your number, 230, and then extend your 2 lines below the number. Again, those are called branches. Now, if something ends in a 0, meaning it has a trailing 0, we can divide it by 10. If I divide by 10 and I have a trailing 0, just cut the 0 off. So I'd have 23 times 10. Now, is 10 a prime number? No, it's not. 10 is 5 times 2. Both 5 and 2 are prime, so I'm going to circle those. Is 23 a prime number? Well, it is, but you might not know that. So punch up square root of 23 on your calculator. You'll get about 4.79. Go ahead and just think about the next highest whole number. That's 5. And again, test all the prime numbers up to and including 5. I don't need to test 2 because it's not an even number. 3 I would test with 2 plus 3, that's 5. 5 is not divisible by 3. The number does not end in a 0 or 5, so it's not divisible by 5. So yes, this is a prime number. I can circle it and stop. So I have my prime factorization for 230. It is 5 times 2 times 23. What about 936? 936. So the number's even. It's definitely divisible by 2. 36, the last two digits of the number, divided by 4 gives me 9, no remainder. So it's divisible by 4. 9 plus 3 is 12. 12 plus 6 is 18. 18 divided by 3 is 6, no remainder. So I know it's divisible by 12. Let's start with that, right? Because if a number is divisible by 4 and 3, it's divisible by 12. So if I don't know what number times 12 gives me 936, I can find that with a long division. My result will give me my missing number over here, right? Because this times this gives me this. So 12 goes into 93 how many times? Well, 7 times. 7 times 12 gives me 84. We're going to subtract. 13 minus 4 is 9. Bring down the 6. 12 goes into 96 8 times. 8 times 12 is exactly 96. So the missing number is 78. 12 times 78 will give me 936. 12 is not prime. 78 is not prime. The way I know that is they're both even numbers. 12 I know off the top of my head is 4 times 3. 4 times 3. We know at this point 3 is prime, so you can go ahead and circle that. 4 is 2 times 2. 2 is prime, so you can circle those. What about 78? Well, I know at this point I can at least divide it by 2. 7 plus 8 is 15. 15 divided by 3 is 5, no remainder. So it's divisible by 2. It's divisible by 3. It's got to be divisible by 6. So what is 78 divided by 6? 6 goes into 7 once. 1 times 6 is 6. Subtracting, get 1. Bring down the 8. 6 goes into 18 3 times. 3 times 6 is 18. Subtracting, get 0. So I would get 6 times 13. I know that 6 is 3 times 2. 3 and 2 are each prime numbers. What about 13? Is that a prime number? Well, yes. But again, if you didn't know that, you could punch up square root of 13 on a calculator. You'd get about 3.6. Now, the next highest whole number would be 4. If you test all the prime numbers up to and including 4, 4 is not a prime number, so you don't have to worry about that. You don't have to worry about 2 because this is an odd number. You really just have to test 3. So 1 plus 3 is 4. 4 is not divisible by 3. So yes, this is a prime number. So for the prime factorization, we look at the circled numbers. So 936 is equal to, we have 1, 2, 3 factors of 2. So that's 2 cubed. Times 1, 2 factors of 3. So that's 3 squared. Then times 13. Okay, what about 1,700? 1,700. So we have some trailing zeros here. And what's interesting is that, again, when we multiply with trailing zeros, so let's say I did 17 times 10. I know I would have 170, right? Multiply 17 times 1, attach a trailing 0. If I was multiplying by 100, I would just attach 2 trailing zeros. So we can see here that 17 times 100 would be 1,700. Another way to think about this is if I'm dividing a number and it has trailing zeros, if I divide by 10, I cut off 1 trailing 0. If I divide by 100, I cut off 2 of them. So if I have 1,700, again, and I divide by 100, I get 17. So this is 17 times 100 to produce 1,700. Now, you might stop and say, I don't work with 17 that often. Is it a prime number? Well, take the square root of it. You're going to get about 4.12. So the next highest whole number would be 5. Now, if I think about what prime numbers I need to check, I can exclude 2 because this number is not even, so I don't need to check it. Think about 3. 1 plus 7 is 8. 8 is not divisible by 3. The number does not end in a 0 or 5, so it's not divisible by 5. So yeah, this is a prime number. We can circle this and stop. What about 100? 100 you could write as 10 times 10. Or again, you could have done 25 times 4 or 2 times 50. It doesn't matter. You'll get the same answer either way. Now 10 is 5 times 2. And we know that 5 and 2 are both prime. So we're going to circle all of them. So now we found our prime factorization. 1,700 is equal to, we have 2 factors of 2, or 2 squared. We have 2 factors of 5, or 5 squared, and then times 17. What about 535? 535. So it ends in a 5. Let's start there. What if I divide by 5? 535 divided by 5. 5 goes into 5 once. 1 times 5 is 5. Subtracting, get 0. Bring down the 3. 5 is not going to go into 3, so we put a 0. 0 times 5 is 0. Subtracting, get 3. Bring down the 5. 5 goes into 35 7 times. 7 times 5 is 35. Subtracting, get 0. So 107 times 5 gives me 535. Now, I know that 5 is a prime number. I have no idea about 107. So I'm going to use my square root trick. So if you take the square root of 107 on a calculator, you're going to get about 10.34. So go to the next highest whole number, that's 11. So we're thinking about all the prime numbers up to and including 11. So that's 2, 3, 5, 7, and 11. Looking at 107, I can exclude 2. I know that it's not divisible by 2 right away because it's not an even number. 1 plus 0 plus 7 is 8. 8's not divisible by 3. You can cross that out. The final digit of the number is not a 5. And it's also not a 0, so it's not divisible by 5. Now I need to check 7 and 11. And the rules are kind of elaborate for those. So either you can just straight divide it by 7 and see if it works. Divide it by 11, see if it works. Or you can use the trick. It doesn't matter. So let's just do the trick so we get some practice. So for 7, remember we cut off the final digit of the number and we get 10. We would double it. 7 times 2 is 14. And we'd subtract. So 10 minus 14 is negative 4. That's not divisible by 7. Cross that out. What about 11? So again, you number the digits. So this is 1, 2, and 3. So you'd sum the digits in the odd places. So 1 plus 7 is 8. You would subtract away the sum of the digits in the even places. So I just have a 0. And that gives me 8. So that's not divisible by 11, and it's not 0. So it's not going to be divisible by 11. So 107 is a prime number. So the prime factorization for 535 is 5 times 107. Okay, so I saved the best for last. We have 51,480. 51,480. So where do we start? If you get something big on a test like this, use your divisibility rules. Just think about anything you can think of. I know it's even, so it's divisible by 2. I know it ends in a 0, so it's divisible by 5, and it's divisible by 10. 5 plus 1 is 6. 6 plus 4 is 10. 10 plus 8 is 18. 18 plus 0 is still 18. So I know it's divisible by 3. The last two digits of the number form the number 80. That's divisible by 4. 80 divided by 4 is 20, no remainder. So it's divisible by 12. So I can start with 12 if I want. Let's start with 12. So 51,480 divided by 12 is going to give me what? So 12 goes into 51 4 times. 4 times 12 is 48. Subtracting, get 3. Bring down the 4. 12 goes into 34 twice. 2 times 12 is 24. Subtracting, get 10. Bring down this 8. 12 goes into 108 9 times. 9 times 12 is 108. Subtracting, get 0. Bring down the 0. 12 goes into 0 0 times. So 4,290 times 12. 4,290 times 12 gives me 51,480. Okay, so 12 I can write as 4 times 3. 3 is prime. I'm going to circle that and stop. 4 I'm going to write as 2 times 2. Circle the 2. Circle the other 2. What about this 4,290? It ends in a 0, so I know it's not prime. I can divide it by 10. I can write it as 429 times 10. Again, if you divide this by 10, just cut the 0 off. So you get 429 times 10. So 10 I know is 5 times 2. 5 and 2 are both prime. What about 429? Do we have any idea or any clue if this is a prime number or not? I know it's not even. If I kind of think about 4 plus 2, that's 6. 6 plus 9 is 15. 15 is divisible by 3. So I know it's not prime because it's divisible by 3. So let's try that. Let's do 429 divided by 3. 3 goes into 4 once. 1 times 3 is 3. Subtracting, get 1. Bring down the 2. 3 goes into 12 4 times. 4 times 3 is 12. Subtracting, get 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. Subtracting, get 0. So 143 times 3. 143 times 3. Now I know that 3 is prime. I'm going to circle that. So what about 143? So 143 is 11 times 13. Now we know already that 11 is a prime number, and you should know that 13 is. But again, if you don't, use the square root trick. You will find that 13 and 11 are both prime numbers, and so we're done. The prime factorization, and let me scroll up here real quick, for 51,480, we have 1, 2, 3 factors of 2. So 2 to the third power, otherwise known as 2 cubed. We have 1, 2 factors of 3. So times 3 squared. We have 1 factor of 5, so times 5. We have 1 factor of 11, 1 factor of 13. So 2 cubed times 3 squared times 5 times 11 times 13. Hello and welcome to Pre-Algebra Test Section 1 on factoring whole numbers. All right, so we just want to determine if each number is prime, composite, or neither. So before we begin, what is the definition of a prime number? A prime number is a whole number that is larger than 1 that is only divisible by itself or 1. A composite number is a whole number that is larger than 1 that is divisible by something other than 1 or itself. So when I look at 17, is it going to be prime or is it going to be composite? What we can do is we can check the divisibility of 17 by each number, starting with 2, right? We'd exclude 1, and going all the way up to 16, right? We wouldn't include 17 because that's the number itself. But there's a shortcut, right? We don't need to go through all this work. What we can do is take the square root of 17. Once we have that number, we look at the next highest whole number. So the square root of 17, if you punch that up on your calculator, is about 4.12. So the next highest whole number would be 5. So all I need to do is check the divisibility by each prime number up to and including 5. So that would be 2, 3, and 5. Now I don't need to look at 2 because 17 is not even. It's an odd number, so it's not going to be divisible by 2. 3, I can check that. 1 plus 7 is 8. 8 is not divisible by 3. 5, I can check that. The number does not end in a 0 or a 5, so it's not divisible by 5. So I've checked all I need to check. This is going to be a prime number. What about 1? 1 falls in the category of neither. You might say, well, why is that the case? When we looked at the definition of a prime number and of a composite number, we saw that in each case we said a whole number larger than 1. Right? A prime number is a whole number larger than 1 that is divisible by itself or 1 only. A composite number is a whole number larger than 1 that is divisible by something other than itself and 1. In each case, we said whole number larger than 1. So when we have 1 or we have 0, we just put neither, right? Because it's not prime and it's also not composite. What about 150? Well, because I look at this number and I know that it's even, I know that it's going to be a composite number. Because all even numbers that are larger than 2 are automatically composite numbers. They're divisible by 2. What about 12? Again, this is composite because it's even. What about 13? Well, if you punch up square root of 13 on a calculator, you get about 3.6. So the next highest whole number would be a 4. Now 4 is not a prime number, so all I really need to check would be 2 and 3. So it's not divisible by 2 because it's an odd number. I can check 3. 1 plus 3 is 4. 4 is not divisible by 3. So this is a prime number. What about 23? Well, punch up the square root of 23 on a calculator. You're going to get about 4.79. The next highest whole number is 5. So I'm going to look at 2, 3, and 5. And again, I don't need to check 2 because this is an odd number. So if I look at 3, 2 plus 3 is 5. 5 is not divisible by 3. If I look at 5, the number does not end in a 0 or a 5. So really, this is a prime number. This is a prime number. What about 110? Well, this is an even number, right? It ends in a 0. So this is going to be composite. Hello and welcome to Pre-Algebra Test Section 2 on factoring whole numbers. All right, so we want to write each as a product of prime factors, and we're going to be using a factor tree to do that. So we start out with 135. So to use a factor tree, you just write the number, and you extend two what we call branches underneath, and you list any two factors for the number. Now, I don't know any factors for 135 off the top of my head, But using my divisibility rules, I see that the final digit is a 5. So I know 135 is divisible by 5. So let me divide it by 5 and see what my missing factor would be. 5 goes into 13 twice. 2 times 5 is 10. Subtracting, get 3. Bring down the 5. 5 goes in 35 7 times. 7 times 5 is 35. Subtracting, get 0. So 27 times 5 would give me 135. So let's start with that. Now, anytime I have a prime factor, meaning a factor that is a prime number, I just circle it and I stop. Anytime I have a factor that's not prime, I just repeat the original process. I put 2 branches underneath and then I list 2 factors for the number. So for 27, I could list 9 times 3. 9 times 3. Now, 3 is a prime number, so I'll circle that and stop. And 9 is not, so I'm going to continue. So put 2 more branches, and it's 3 times 3. So 3 is prime, so we're going to circle both of these, and we're done. We have 3 times 3 times 3 times 5. So 135 is equal to 1, 2, 3 factors of 3, or 3 cubed times 5. Okay, we're going to look at 1,800. So 1,800. So the cool thing about having 2 trailing zeros tells me that this number is divisible by 100. Right? If I have 1 trailing zero, it's divisible by 10. If it has 2, it's divisible by 100. So essentially, to divide this number by 100, I just cut off 2 zeros. So it would be 18 times 100. That would give me 1,800. Right? If I multiplied, 18 times 1 is 18. Attach 2 trailing zeros, I'd get 1,800. Now, 18, I know I can do 6 times 3. 6 times 3. And 3 is prime. 6 is 2 times 3. Both 2 and 3 are prime, so I'm going to circle those. And then for 100, let's do 10 times 10. 10 is 5 times 2. So let's circle the 5, the 2, the 5, and then the 2. Those are all prime. So now we're done. And we can list our prime factorization for 1,800 as we have 1, 2, 3 factors of 2, so 2 cubed, times we have 1, 2 factors of 3, so 3 squared, times we have 1, 2 factors of 5, so 5 squared. So 2 cubed times 3 squared times 5 squared gives you 1,800 or 1,800. Hello and welcome to Pre-Algebra Test Section 3 on factoring whole numbers. All right, we want to write each as a product of prime factors. Another way you could say that is we want to find the prime factorization for each number, and we're going to be using a factor tree to do that. All right, so we begin with 680. So to make a factor tree, you just list the number, and then you put 2 branches, is what they're called, underneath the number. So the branches are so that you can list 2 factors, and this can be any 2 factors, for the original number. Now I see that this number is divisible by 10. So if I divide 680 by 10, I would get 68. So 68 times 10 gives me 680. Again, if you take a number that has a trailing 0, you divide it by 10, just cut the 0 off. That's how you get your answer. So for 10, it's 5 times 2. Now because 5 and 2 are both prime, we circle them. We circle them. That tells me to stop, okay, because I've found the prime factors there. But over here for 68, I can keep going. 68 is not a prime number. Now, I know that 68 is divisible by 2, but it might also be divisible by 4. Let's check that out. 4 goes into 6 once. 1 times 4 is 4. Subtracting, get 2. Bring down the 8. 4 goes into 28 7 times. 7 times 4 is 28. Subtracting, get 0. So 17 times 4 is 68. 17 times 4 is 68. Now, I know that 4 is not prime, but is 17 prime? Well, at this point, you should probably know that 17 is prime, but if not, you can check it. Punch up the square root of 17 on your calculator. You'll get about 4.12. Go to the next highest whole number. That would be 5. And check all your prime numbers up to and including 5. So is 17 divisible by 2? No way, right? It's an odd number. Is 17 divisible by 3? 1 plus 7 is 8. 8 is not divisible by 3, so no. Is it divisible by 5? Well, the last digit of 17 is a 7. To be divisible by 5, it needs to be a 0 or a 5. So it fails. So this is a prime number. Now for 4, we know that's 2 times 2. And 2 is a prime number, so we're going to circle each. Now we're done, right? We don't have anything else to continue on. So we just list the prime factorization of 680. We have 1, 2, 3 factors of 2. So that's 2 cubed times 5 times 17. All right, what about 12,600? So 12,600. So I know this is divisible by 100 because it has two trailing zeros. And to divide a number with two trailing zeros by 100, just cut those two trailing zeros off. You'd have 126 times 100. I know that 100, I could write that as 10 times 10. And then 10 is 5 times 2. 5 is prime, 2 is prime, so we're going to circle each. And we're done over here. Now we're going to focus on 126. Now I know that that's an even number, so I know it's at least divisible by 2. Let's see if we can do better. So what is 126 divided by 6? 6 goes into 12 twice. 2 times 6 is 12. Subtract and get 0. Bring down the 6. 6 goes into 6 once. 1 times 6 is 6. Subtract and get 0. So this would be 21 times 6. Now I know 6 is 3 times 2. 3 and 2 are both prime. Circle those. And 21 is 7 times 3. 7 and 3 are both prime. So now I have my prime factorization. So 12,600 is equal to, I have 1, 2, 3 factors of 2, so 2 cubed, times, I have 1, 2 factors of 3, so 3 squared, times, I have 1, 2 factors of 5, so 5 squared, and then times 7. Hello and welcome to Pre-Algebra Test Section 4 on factoring whole numbers. All right, so we just want to write each as a product of prime factors, meaning we want to find the prime factorization for each number. And what we're going to do is we're going to use a factor tree to do that. Okay, we're going to begin with 468. So to make a factor tree, you just start by extending to what we call branches, and then you list two factors for the number. It could be any two factors. You put one under each branch. I know it's an even number, so I know it's divisible by 2. So I could start with that if I wanted to, or I could try to divide by something higher. So 68 is divisible by 4. 68 divided by 4 is 17. So I could do that. But I would probably go with 12. If you look at the number, 4 plus 6 is 10. 10 plus 8 is 18. 18 divided by 3 is 6, no remainder. So if a number is divisible by both 4 and 3, it's divisible by 12. So what is 468 divided by 12? Well, I have no idea. So let's do the long division. 12 goes into 46 3 times. 3 times 12 is 36. Subtract, you get 10. Bring down the 8. 12 goes into 108 9 times. 9 times 12 is 108. Subtract and get 0. So 12 times 39 is 468. Now, neither number is prime, so what I'm going to do is I'm going to continue. I'm basically just going to repeat what I did. So 12 I could write as 4 times 3. And I check to see if either number is prime. Now, 3 is prime, so what I do when I have a prime number is I circle it. And I stop. I don't need to repeat anything there. I'm done. 4 is not prime, so I continue. So 4 I'm going to write as 2 times 2. And 2 is prime, so I circle each one, and I'm done. Now I focus on 39. The reason I know 39 isn't prime, 3 plus 9 is 12. 12 divided by 3 is 4, no remainder. So I know it's divisible by 3. 39 divided by 3, in case you don't know, is 13. Now 3 is prime. I know that. The question is 13 prime? A lot of you might not have worked with 13 before. It is prime. But again, if you want to check it, punch up the square root of 13 on your calculator. You'll get about 3.6. Okay, approximately 3.6. So go to the next highest whole number. That would be 4. So all you need to do is check all the prime numbers up to and including 4. Now 4 is not a prime number, so you don't need to check that one, but it would be up to and including 4. I don't need to check 2 because that's obviously not going to work. This is an odd number. So I would just check 3. 13 is not divisible by 3. 1 plus 3 is 4. 4 is not divisible by 3. So 13 is not divisible by 3. So this is in fact a prime number. So now that we don't have anywhere to continue with, we're done. Your prime factorization for 468 is the product of the circled numbers. So 2 times 2, which is 2 squared, times 3 times 3, which is 3 squared, times 13. All right, let's take a look at one more. I have 3,420. So again, write the number and extend 2 branches. And this one's easy because it ends in 0. So I know it's divisible by 10. And if I divide a number with a trailing 0 by 10, I just cut off the 0. So it would be 342 times 10. Now 10 is not prime and neither is 342, so we continue. 10 is 5 times 2. 5 and 2 are both prime, so we're going to circle them and stop. 342 is even. So I know it's at least divisible by 2. I also know that it's divisible by 3. 3 plus 4 is 7. 7 plus 2 is 9. 9 divided by 3 is 3, no remainder. So it's definitely divisible by 6. So let's go with that. 342 divided by 6. 6 goes into 34 5 times. 5 times 6 is 30. Subtract and get 4. Bring down the 2. 6 goes into 42 7 times. 7 times 6 is 42. Subtract and get 0. So 6 times 57 would give me 342. Now, I know that 6 is 3 times 2. And 3 and 2 are each prime, so I can circle those and stop. I don't work with 57 very often, so I don't know if it's prime or not. So check if it's divisible by any of the prime numbers, starting with 2, going up through 8, and 8's not a prime number. So you would have what? You'd have 2, 3, 5, and 7. So it's not divisible by 2. 5 plus 7 is 12. 12 divided by 3 is 4, no remainder. So yeah, it's not going to be a prime number. So what is 57 divided by 3? 3 goes into 5 once. 1 times 3 is 3. Subtract and get 2. Bring down the 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtract and get 0. So 57 is 19 times 3. So 3 is prime. We can circle that and stop. But what about 19? Well, it is a prime number, but in case you didn't know that, so check all your prime numbers up to and including 5. So is 19 divisible by 2? No, because it's not even. It's not divisible by 3. 1 plus 9 is 10. 10 is not divisible by 3. And it's not divisible by 5 because it doesn't end in a 0 or a 5. So 19 is a prime number. So now we're done. We found the prime factorization for 3,420. And it's just the product of the circled numbers. So I'd have 2 factors of 2, or 2 squared. I'd have 2 factors of 3, or 3 squared. I'd have 5, and I'd have 19. So 2 squared times 3 squared times 5 times 19 gives me 3,420. Hello and welcome to Pre-Algebra Test Section 5 on factoring whole numbers. All right, so we want to write each as a product of prime factors. And what that means is we're trying to find the prime factorization of each number involved. And the method we're going to use is we're going to use a factor tree. So we're starting out with 10,296. So just write the number, 10,296. And with a factor tree, you start out by extending 2 what we call branches underneath the number. And then you're going to list any 2 factors that you want. So look at the number and think about your divisibility rules. I know that it's an even number, so it's divisible by 2. If I sum the digits, 1 plus 0 plus 2 plus 9 plus 6 is 18. 18 divided by 3 is 6 with no remainder. So if something's divisible by 2 and 3, it's definitely divisible by 6. But also if something's divisible by 3 and 4, it's divisible by 12. Now the final 2 digits of this number forms the number 96. 96 divided by 4 is 24. Since this number is divisible by both 3 and 4, it's divisible by 12. So let's just start with that. Now I don't know what the missing factor is over here. The way I can get it is with long division. So 10,296 divided by 12. Whatever I get here would be my missing factor. 12 goes into 102 8 times. 8 times 12 is 96. Subtract. We're going to borrow there and borrow again. 12 minus 6 is 6. 9 minus 9 is 0. And that would be 0, so we just have 6 there. Now bring down this 9. 12 goes into 69 how many times? Well, 5 times. 5 times 12 is 60. Subtract and you get 9. Then we're going to bring down this 6 here. So how many times will 12 go into 96? Well, exactly 8. 8 times 12 is 96. Subtract and get 0. So 858 times 12, 858 times 12 is what gives me 10,296. Now, neither number is prime, so we keep going. 12 I can write as 4 times 3. Now 3 is a prime number, so I circle it and I stop. That's what I do when I get a prime number. I just circle it and stop. 4 is not prime, so I continue. 4 is 2 times 2. 2 is prime, so I circle each and stop. Now I need to deal with 858. So I know it's an even number, so it's at least divisible by 2. 8 plus 5 is 13. 13 plus 8 is 21. So this number is divisible by 3 because 21 divided by 3 is 7. So if a number is divisible by both 2 and 3, it's divisible by 6. So let's go with that. So 6, and then finding the missing factor, I'll just do a long division. 6 goes into 8 once. 1 times 6 is 6. Subtract and get 2. Bring down the 5. 6 goes into 25 4 times. 4 times 6 is 24. Subtract and get 1. Bring down the 8. 6 goes into 18 3 times. 3 times 6 is 18. Subtracting gets 0. So 6 times 143. Okay, so 6 I know is 2 times 3. And each is prime, so I can circle and stop. But what about 143? Is that a prime number? We don't really work with that too often. Again, the trick I taught you in the lesson is punch up square root of 143 on your calculator. You're going to get about 11.9. Go to the next highest whole number, so go to 12. And I want you to test 143 divided by each prime number going up to and including the number that you come up with. In this case, it's 12. 12 is not a prime number, so you wouldn't have to worry about it. But you would basically test 2, 3, 5, 7, and 11. So 143 is not going to be divisible by 2. It's an odd number. 1 plus 4 is 5. 5 plus 3 is 8. Not divisible by 3. The last digit is 3, so it's not divisible by 5. For divisibility by 7, remember, you take and cut off the last digit, which is a 3. You double it and you subtract. So 14 minus 6 is 8. 8's not divisible by 7, so you can cross that one out. What about 11? Well, for 11, again, you number the digits. So you say this is the first digit, the second digit, and the third digit. You're summing the digits in the odd position, so that would be 1 plus 3. And that's just a coincidence that they fall like that, but it's the number 1 and the number 3 that are in the first and the third position. So 1 plus 3 is 4. And then you subtract away the sum of the numbers in the even positions. So I just have one number in an even position, that's 4. So I subtract that away, and I get 0. Now, because this is a 0, I know that this number is divisible by 11. Right? If I get a 0 or a number that's divisible by 11, the number is divisible by 11. So 143 will have 11 as a factor. So 143 divided by 11. 11 goes into 14 once. 1 times 11 is 11. Subtracting, get 3. Bring down the 3. 11 goes into 33 3 times. 3 times 11 is 33. Subtracting, get 0. So 11 times 13 gives me 143. Now, we do know at this point, or we should know, that 11 and 13 are each prime numbers. So we can circle those and stop. If you didn't, again, you can use that little square root trick. So I am done here. I have my prime factorization. So 10,296 is equal to, it's just the product of all the circled numbers. So I have 2 times 2 times 2. So 3 factors of 2. So 2 cubed. Times 3 times 3, that's 3 squared. Times 11 times 13. So 10,296 is 2 cubed times 3 squared times 11 times 13. All right, for the last problem, I have 2,205. So 2,205. Again, extend 2 branches underneath that number and use your divisibility rules. This number ends in 5, so I know it's divisible by 5. So 2,205 divided by 5. 5 goes into 22 4 times. 4 times 5 is 20. Subtracting, get 2. Bring down the 0. 5 goes into 24 times. 4 times 5 is 20. Subtracting, get 0. Bring down the 5. 5 goes into 5 once. 1 times 5 is 5. Subtracting, get 0. All right, so 441 times 5 gives me 2,205. Now, I know that 5 is a prime number, so I can circle that and stop. But what about 441? So if you punch up the square root of 441 on your calculator, you get 21. So when something like that happens, it tells you that the number's not prime, right? It's because it's divisible by 21. It's divisible by something other than itself or 1. So I can just write that this is 21 times 21. Now 21 is 7 times 3. 7 times 3. And 7 and 3 are both prime, so I can just circle all of these, and I'm done. So 2,205 is equal to, again, the product of the circled numbers. So I'd have 5 times, I have 2 factors of 3, so 5 times 3 squared, times, and I have 2 factors of 7, so 7 squared. So 2,205, again, is equal to 5 times 3 squared times 7 squared. Hello and welcome to Pre-Algebra Practice Set number 26. And in this video, we're going to look at some additional practice problems for our lesson on Introduction to Fractions. All right, so we're going to start out with this exercise where we identify the numerator and denominator in each. So we start out with 1 over 8, or 1/8. So remember, the numerator is the top part of the fraction. So it's the top number. It's the numerator. Right, so 1 is the numerator here. Then the bottom number is the denominator. So 8 is our denominator. All right, what about 3/5? So the top number of the 3 is the numerator. And I'm just going to write a capital N to represent numerator. And the bottom number 5 is the denominator. So I'm just going to put a capital D to represent denominator. For 9/14, the 9, the number on top, is the numerator. The 14, the number on the bottom, is the denominator. For 12/17, 12, the number on the top, is the numerator. 17, the number on the bottom, is the denominator. For 6/11, 6, the number on the top, is the numerator. 11, the number on the bottom, is the denominator. For 4/9, the 4, the number on top, is the numerator. And the 9, the number on the bottom, is the denominator. All right, so that was very, very simple. Let's move on to the next part. We want to write each division problem using a fraction, then perform the division. So we begin with 27 divided by 9. So basically, when you write this as a fraction, you just think about it as the numerator divided by the denominator. So it's this part, the leftmost number of the division problem is the numerator. You have your fraction bar, and then the rightmost part of the division problem is your denominator. Right, it's 27 divided by 9. Same goes when you have the fractions. 27/9 or 27 divided by 9. Again, this fraction bar is representing division. So what is 27 divided by 9? Well, this is 3. Now we have 35 divided by 7. Again, this number on the left, the 35, that's going to be your numerator, because we're going to have 35 divided by, and then we have this 7. So 35 divided by 7, you write as 35/7, and if we divide 35 by 7, we get 5. All right, for the last one, we have 55 divided by 11. Again, 55, this left number, that's going to be your numerator. And then divided by, we have 11, that's going to be your denominator. So 55 divided by 11 is 5. All right, now we want to write a fraction that represents the shaded part and non-shaded part of each picture. All right, so we're going to start out by looking at this circle here. So the circle has 8 equal parts. So let's just number them. We have 1, 2, 3, 4, 5, 6, 7, 8. And remember, our goal is to make fractions that represent the shaded part and the non-shaded part. So for the shaded part, what's our fraction going to be? Well, in each case, for the shaded part and the non-shaded part, the denominator is going to be 8, right? The denominator is going to be 8. How do I know that? The denominator tells you how many equal parts you've split this whole amount into. You consider this circle as just one whole amount. And we split it up into 8 equal parts or 8 equal pieces. So the denominator in each case is going to be 8. Now, how do we get the numerator for each? Well, for the shaded part, I would just count up how many parts are shaded out of the 8. I have 1, 2, 3, 4, 5. There are 5 parts that are shaded, so the numerator is going to be a 5. So the shaded part is 5/8, or 5 out of a total of 8 that are shaded. What about the non-shaded part? Well, you could use some simple subtraction and say, well, if 5 parts are shaded out of the 8, that means that 8 minus 5, or 3 parts, are not shaded. Or you can go through and count them. You can say, okay, I have 1, 2, 3 parts that are not shaded. So this would be the fraction 3/8, or 3/8, right? 3 parts out of a total of 8 are not shaded. Here we have a rectangle. So this is split up into 1, 2, 3, 4, 5, 6 equal parts. So what's our shaded going to be? Shaded and non-shaded. Well, in each case, the denominator is going to be 6, right? Because we have a total of 6 equal parts. 6 equal parts. So in each case, the denominator is 6. So for shaded, I have one part, right? One part that's shaded. So it's going to be 1/6. That's the portion that is shaded of this rectangle. For the non-shaded, I have 1, 2, 3, 4, 5 parts that are not shaded out of a total of 6. So 1/6 of the rectangle is shaded, right? Or one piece out of 6 total pieces. And 5/6 of the rectangle is not shaded, right? Or 5 pieces, again, out of a total of 6. All right, for the last exercise, we want to identify each as a proper fraction, improper fraction, or mixed number. So we begin with 3/52. So is this proper, improper, or a mixed number? Well, we know it's not a mixed number because there's no whole number off to the left. So we just have narrowed this down to either a proper fraction or improper. Proper fractions have a numerator that is less than the denominator. So if we think about 3, it's less than 52, so this is a proper fraction. What about 27 over 40? The numerator here, 27, is less than the denominator, 40, so this is proper. What about 1 and 1/4? Well, we have a whole number off here to the left, so we know this is a mixed number. This is a mixed number. And a mixed number always has a whole number and a proper fraction. So 1/4, the 1 is smaller than the 4, that's a proper fraction. 1 and 1/4 is a mixed number. What about 11/15? The 11 is smaller than the 15, numerator smaller than the denominator. This is a proper fraction. What about 19 over 13? The numerator is now bigger than the denominator, so this is an improper fraction. Here we have 13 over 5. Numerator is bigger than the denominator, so this is improper. What about 25 over 7? Numerator is bigger than the denominator, so this is improper. And we'll kind of wrap it up with 9 and 7/10. We have a whole number off to the left here with a proper fraction. This is a mixed number. Hello and welcome to Pre-Algebra Test Section 1 on Introduction to Fractions. So we want to identify the numerator and denominator in each. So we start out with the fraction 3/7. So remember, the numerator is the top part and the denominator is the bottom part. So the 3 is on top, that's the numerator. And the 7's on the bottom, that's the denominator. Next we look at 4/15. The 4's on top, so that's the numerator. And I'm just going to write an N there to represent numerator. And the 15's on the bottom, that's the denominator. I'm just going to put a D there to represent denominator. Next we have 12 over 11. So the 12, the number on top, is the numerator. The 11, the number on the bottom, is the denominator. Then we look at 9/8. 9, the number on top, is the numerator. 8, the number on the bottom, is the denominator. What about 2/3? 2, the number on top, is the numerator. 3, the number on the bottom, is the denominator. What about 24/5? 24, the number on top, is the numerator. 5, the number on the bottom, is the denominator. What about 4/3? 4, the number on top, is the numerator. 3, the number on the bottom, is the denominator. What about 3/4? 3, the number on top, is the numerator. 4, the number on the bottom, is the denominator. Hello and welcome to Pre-Algebra Test Section 2 on the Introduction to Fractions. Okay, so we want to write each division problem using a fraction, then perform the division. So we start out with 81 divided by 9. So in a division problem, this left number here would be the numerator. So this is 81. Then instead of this symbol here, you're going to have a fraction bar. Again, the fraction bar represents division. And then you're going to have the right number of a division problem as your denominator. So 81 divided by 9 is the same as 81 divided by 9 like this, or 81 over 9, right? Again, this fraction bar represents division. So it's the numerator, again 81, divided by the denominator, which is 9. So now we just think about what is 81 divided by 9, and that's just 9. So for 72 divided by 8, we take this left number, that's going to be our numerator. We have our fraction bar, and then we have this right number, the 8, we put that as the denominator. So we have 72 over 8, and this is the same thing as saying 72 divided by 8. So 72 divided by 8 is 9. Now we have 54 divided by 6. So this left number, 54, is the numerator. Then we have our fraction bar, and then we have 6, that's going to be our denominator. So 54 divided by 6 is 9. Then we have 300 divided by 10. So again, the 300, the leftmost number, that's your numerator. And then we have our fraction bar, that represents the division. And then we have 10, that's going to be our denominator. So 300 divided by 10. If you have a number with trailing zeros, like 300, and you divide by 10, basically all you need to do is cancel one of the zeros. So this would be 30. And you can think about why that works with multiplication. if I had 30 times 10, really I have trailing zeros here. Think about just starting with 30 times 1. I know we normally do 3 times 1, but just think about 30 times 1, that's 30, and then attach one trailing zero. So if I reverse that and I said 300 divided by 10, I'm really just canceling one of the zeros away. All right, for the last problem, we have 180 divided by 60. So the left number, again, is going to be your numerator. Then we have our fraction bar that represents division. And then we have 60. That's going to be our denominator. And then we just do the division. 180 divided by 60 is 3. Hello and welcome to Pre-Algebra Test Section 3 on the Introduction to Fractions. So we want to write the fraction that describes the shaded part and non-shaded part of each illustration. So when we look at this circle, we see that it's split up into 4 equal parts. So we have 1, 2, 3, 4 equal parts. Our goal is to write a fraction to describe the shaded part, and a fraction to describe the non-shaded part. So in each case, the denominator will be the same, right? The denominator represents the total number of equal parts you have split your whole amount into. In this case, we have 1, 2, 3, 4 total pieces involved, or total parts involved. So let's put a 4 as the denominator for each. And then to get the numerator in each case, it's just what you're discussing. So if I'm discussing the shaded part, I look to see how many pieces I have that are shaded. Well, I only have 1, so that's my numerator. So 1 out of 4 pieces is shaded. So that's the fraction 1/4, right? 1/4 of this circle is shaded. Then for the non-shaded part, I have 1, 2, 3 of those. So 3 out of a total of 4, right? Or the fraction 3/4. So the shaded part is 1/4. The non-shaded part is 3/4. All right, next we have a rectangle that's split up into 1, 2, 3, 4, 5, 6, 7, and then 8 equal parts. So again, we're looking for the non-shaded and the shaded. So the shaded and the non-shaded. So in each case, the denominator will be 8, right? We took this rectangle and split it up into 8 equal parts. So the denominator in each case is an 8. And what's the numerator? Well, for the shaded, we have 1, 2, 3, 4, 5, 6, 7 parts that are shaded. So the numerator is a 7. Right? So we have 7/8 of this rectangle that's shaded. Then for the non-shaded, we only have 1. Right? We have 1 part out of a total of 8 parts. So 1 is my numerator. And again, 8 is the denominator. So the non-shaded portion of this rectangle is 1/8. Hello and welcome to Pre-Algebra Test Section 4 on the Introduction to Fractions. So we want to write the fraction that describes the shaded part and non-shaded part of each illustration. All right, so here we have a rectangle. And the rectangle is split up into 1, 2, 3 equal parts. So the shaded part, and the non-shaded part will have the same denominator, right? Because the denominator represents how many equal parts we've split that whole amount into. So in each case, the denominator is 3. So what about the numerator? In the case of the shaded part, we have 1, 2, 3 parts that are shaded. So 3 parts out of a total of 3 parts are shaded. And remember, this represents 1, right? 3 divided by 3 is 1. And that makes sense because the whole thing is shaded. What about the non-shaded part? Well, I have 0 parts that are not shaded. So really, this would be the fraction 0/3, which we know that 0 divided by a non-zero number is 0, so this is 0. Right? I'm saying that no parts of the 3 are non-shaded, which makes sense. If we look at this, nothing is not shaded. So realistically, I could not use fractions here and say that the entire thing is shaded and nothing is not shaded. What about this triangle here? Well, we have 2 sections. So we have this section and this section. So split up into 2 equal sections. So what's the shaded? And what's the non-shaded? Well, we know the denominator in each case is a 2. And the numerator in each case is going to be a 1, right? Because it's split into 2, So that means each section is 1/2, right? I have one part out of 2 that's shaded, and I have one part out of 2 that's non-shaded. So in each case, we have the fraction 1/2. Hello and welcome to Pre-Algebra Test Section 5 on the Introduction to Fractions. All right, so we want to identify each as a proper fraction, improper fraction, or mixed number. We will begin with 17/18. So the basic rule is that if the numerator is smaller than the denominator, you're looking at a proper fraction. If the numerator is the same as or larger than the denominator, you're looking at an improper fraction. And then a mixed number is very easy to spot, right? You'll have a whole number part and then a proper fraction part. Those are easy to see. So this here with 17/18, 17 is smaller than 18, so this is a proper fraction. With 12/31, 12 is smaller than 31, so this again is a proper fraction. With 55/6, 55 is larger than 6, so this is an improper fraction. With 4/9 or 4/9, 4 is smaller than 9, so this is a proper fraction. With 8/3 or 8/3, 8 is larger than 3, so this is an improper fraction. With 1 and 1/17, you see you have this whole number out to the left and then a proper fraction. This is a mixed number. Here we have 6 and 5/7. Again, you have a whole number and then a proper fraction. This is a mixed number. What about 18/18? A lot of students get confused at this. If your numerator is the same as your denominator, that's actually an improper fraction. A lot of students think it has to be greater than. So they'll say, okay, well, 19/18 is improper, but they think 18/18 is proper. That's not true. 18/18 is still considered an improper fraction because the numerator is the same as the denominator. So if it's the same as or larger, it's improper. If it's less than, it's proper. Hello and welcome to Pre-Algebra Practice Set number 27. In this video, we're going to look at some additional practice problems for our lesson on mixed numbers and improper fractions. So we want to change each improper fraction to a mixed number or whole number. So for the first one, we're going to have 79/4. So when we have an improper fraction and we want to convert it to a mixed number, the first thing we do is we divide the numerator by the denominator. So we would divide 79 by 4. So 4 goes into 7 just once. 1 times 4 is 4. Subtracting, get 3. Bring down the 9. 4 goes into 39 9 times. 9 times 4 is 36. If we subtract here, we get 3. So remember, this 3 down here is known as our remainder. So we have 19 with a remainder of 3. So to write our mixed number, the first thing we do is we take our quotient part from the division. In this case, that's 19. We write that as the whole number for the mixed number. The next thing we do is we form the fraction part of the mixed number. The numerator for the fraction part is the remainder from your division. In this case, the remainder from our division is 3. So our numerator for the fraction part of the mixed number will be a 3. And then the denominator for the fraction part of the mixed number is just the same denominator from the improper fraction. So 79/4 is equal to 19 and 3/4. Let's try another one. Let's say we have 31/7. So again, we're going to divide the numerator by the denominator. So we're going to have 31, and we're going to divide that by 7. So 7 will go on to 31 4 times. 4 times 7 is 28. If we subtract here, let's borrow. This will become 2. This will become 11. 11 minus 8 is 3. And then 2 minus 2 is 0, so we just have 3. Remember, this is your remainder. So this is 4 with a remainder of 3. So now that we've done our division, we can go ahead and write our mixed number. So again, the quotient part, which in this case is 4, that's going to be my whole number part for the mixed number. So the whole number part for the mixed number is a 4. Then my remainder, which in this case is a 3, that's going to be the numerator for the fraction part of the mixed number. And then the denominator for the fraction part of the mixed number is just the 7, right? It's just the same denominator as from the improper fraction. So 31/7 is equal to 4 3/7. All right, for the next one, we have 5/5. And just recall that the official definition for an improper fraction says that you have an improper fraction if the numerator, which in this case it's a 5, is the same as or greater than your denominator. Here, this 5 is the same as the 5 in the denominator, so we have an improper fraction. But when you get something like this on a test, it's really, really easy to get an answer, because any non-zero number over itself, or any non-zero number divided by itself, is just 1. So 5/5 or 5 over 5 or 5 divided by 5 is 1. What about 12/11? Well, again, let's set up our long division. So 11 goes into 12 once. 1 times 11 is 11. We would subtract here and get 1. So this is 1 with a remainder of 1. And so to set up our mixed number, we'd have 1. The quotient part of the division serves as our whole number part for the mixed number. Then 1, which is our remainder in this case, is going to be the numerator for the fraction part. And then the denominator for the fraction part is 11. Right? It's the same denominator as we have for the improper fraction. So 12/11 is equal to 1 and 1/11. All right, let's go over one final problem, and then we're going to look at some practice problems for converting a mixed number into an improper fraction. So we have 97/13. So divide the numerator, 97, by the denominator, 13. Now 13 goes into 97 how many times? We don't work with 13 and 97 very often, so this is where we kind of have to guesstimate a little bit. I know that 13 times 10 is 130. And that's obviously too big, but it's an easy starting point because I'm multiplying by 10. All I need to do is take the number and put a 0 at the end. Now, if I think about, okay, times 9 would still be too big, times 8 would still be too big. Let's try 13 times 7. I think that would be perfect. So 13 times 7. 7 times 3 is 21. 7 times 1 is 7, plus 2 is 9. That gets me to 91. That looks like it's absolutely perfect because if I add 13 to 91, I'd get 104. That's too big. So let's put a 7 here. Again, 7 times 13 is 91. If we subtract, we'll get 6. So let's drag that up here and put remainder of 6. And my mixed number here, remember the whole number part is going to be the quotient from your division. So that's a 7. Then the remainder, which in this case is a 6, is going to be the numerator for the fraction part. And then your denominator for the fraction part is the same as the denominator from the improper fraction. So this would be over 13. So 97/13 is equal to 7 6/13. Okay, so now let's get some practice going from a mixed number to an improper fraction. So we want to change each mixed number to an improper fraction. We're starting out with 27 1/3. So the procedure for this, you just start out by taking your denominator from the fraction part and multiplying it by the whole number part. So essentially I'm going to say, what is 3 times 27? When I'm done with that operation, I add to this the numerator from the fraction part. So I'm going to add a 1 to that. And then this is over. My denominator is going to be the same as the denominator from the fraction part of the mixed number. So this is over 3. So what is 3 times 27? So a lot of you will need to do a vertical multiplication for that. So let's check that out. 3 times 7 is 21. 3 times 2 is 6, plus 2 is 8. So that is 81. Now if I add 81 and 1, I get 82. So this is going to be 82 over 3, or 82/3. So we can say that 27 1/3 is equal to 82/3. What about 12 1/8? Well, again, what we're going to do is we're going to multiply this 8, the denominator from the fraction part, by 12, the whole number part. So we have 8 times 12. And then when we're done with that, we're going to add the numerator from the fraction part. So I'm going to add a 1. This is all over the denominator from the fraction part. So it's all over 8. So what is 8 times 12? Well, a lot of you do know your times tables up to 12 times 12. You know that 8 times 12 is 96. If we add 1 to that, we get 97. And then this is over 8. So 12 1/8 is equal to 97/8. All right, what about 5 18/19? So again, I'm going to take my denominator from the fraction part, which in this case is 19, and I'm going to multiply it by the whole number part. So I'm multiplying by 5. When I'm done with this operation, I'm going to add to it the numerator from the fraction part. So plus 18, and this is all over the denominator from the fraction part, so over 19. So what is 19 times 5? Well, if I know that 20 times 5 is 100, if I know that 20 times 5 equals 100, right, using my trick for trailing zeros, 2 times 5 is 10, attach a 0 to the end, you get 100. What would 19 times 5 be? Well, it's just 5 less, right? It's 5 less, so it would be 95. So then I'd have 95 plus 18. 95 plus 18. 5 plus 8 is 13. 1 plus 9 is 10, plus 1 is 11. So I'd have 113 there in my numerator. And this is over 19. So 5 and 18 nineteenths is equal to 113 nineteenths. Next, we're going to look at 3 and 49 fiftieths. So I'm going to take 50, the denominator from the fraction part, and multiply it by 3, the whole number part. So 50 times 3. Then when we're done, we're going to add 49, right? The numerator from the fraction part. And this is over the denominator from the fraction part, which is 50. So 50 times 3 is easy to do. We have a trailing 0 on 50. So 5 times 3 is 15. Put a 0 at the end, it's 150. So this is 150 plus 49 over 50. So what is 150 plus 49? So 150 plus 49. 0 plus 9 is 9. 5 plus 4 is 9. Bring down the 1. I get 199. So 199, and this is over 50. So 3 and 49 fiftieths is equal to 199 fiftieths. Okay, we have one final problem to do. So we have 17 and 13 fifteenths. So again, we're going to start out the same way. We take our denominator from the fraction part of the mixed number, which in this case is 15. We're going to multiply it by the whole number part, which is 17. When we're done with this operation, we add the numerator from the fraction part of the mixed number, so plus 13. And then our denominator is the same denominator from the fraction part of the mixed number, so that's 15. So what's 15 times 17? Let's do a vertical multiplication to get that. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. And then 1 times 15 is 15. Bring this 5 down. 0 plus 5 is 5. 1 plus 1 is 2. So that's 255. Then we're adding 13. So that would be 268. So we'd have 268 over 15. So 17 and 13 fifteenths is equal to 268 fifteenths. Hello and welcome to Pre-Algebra Test Section 1 on mixed numbers and improper fractions. All right, so we just want to convert each improper fraction into a mixed number. We're going to start out with 9 fifths. So the procedure to do this is extremely simple. We just take the numerator and divide it by the denominator to begin. So we would take 9, again our numerator, and we divide it by 5, which is our denominator. So 5 goes into 9 only once. 1 times 5 is 5. Subtracting, we would get 4. So this division results in 1 with a remainder of 4. Now we kind of use this to build our mixed number. So we have 9 fifths here. This is going to be equal to, the whole number part of the mixed number is the quotient from your division. So that's going to be a 1. Now, the numerator for the fraction part is your remainder. So that's going to be a 4. So I'm going to put a 4 here. And then the denominator for the fraction part of the mixed number is the same as the denominator from the improper fraction. So it's just going to be a 5. So 9 fifths is equal to 1 and 4 fifths. What about the fraction 3 halves? Well, again, we take our numerator and we divide by our denominator. So 2 goes into 3 once. 1 times 2 is 2. Subtracting, we get 1. So this division results in 1 with a remainder of 1. So the whole number part is your quotient from the division. So that's going to be 1. And then the remainder, which is also a 1, is your numerator for the fraction part of the mixed number. And then again, the denominator for the fraction part of the mixed number is the same as the denominator from the improper fraction. So that's going to be a 2. So 3 halves is equal to 1 and 1 half. Let's take a look at 11 ninths now. So we take our numerator, which is 11. We divide that by our denominator, which is 9. 9 goes into 11 once. 1 times 9 is 9. Subtract and get 2. So this is 1 with a remainder of 2. So again, the whole number part is the quotient from your division. So that's going to be a 1. Then the numerator for your fraction part of the mixed number comes from the remainder. So the remainder is 2. So that's going to be the numerator for the fraction part of the mixed number. And then again, the 9, which is your denominator in the improper fraction, is going to be your denominator in the fraction part of the mixed number. So 11 ninths is equal to 1 and 2 ninths. Hello and welcome to Pre-Algebra Test Section 2 on mixed numbers and improper fractions. Alright, so we want to convert each improper fraction into a mixed number. We're going to begin with 22 fifths. So again, a way to do this is you take your numerator and you divide it by the denominator. So I would take the numerator of 22 and divide this by my denominator, which is 5. 5 goes into 22 4 times. 4 times 5 is 20. Subtract and get 2. So we say that the result is 4 with a remainder of 2. Now, to set up your mixed number, you just need the information here. Your whole number part is going to be the quotient from your division. So that's going to be a 4. Your numerator in the fraction of the mixed number comes from your remainder, and that's going to be a 2. And then your denominator for the fraction in your mixed number comes from the denominator in the improper fraction. So we just kind of copy that, so that stays as a 5. So 22 fifths is equal to 4 and 2 fifths. What about 17 thirds? Again, take your numerator, which is 17, and divide that guy by the denominator, which is 3. 3 goes into 17 5 times. 5 times 3 is 15. Subtract and get 2. So this is 5 with a remainder of 2. So to set up our mixed number, 5 will be the whole number part, right? That's your quotient from the division. 2 will be the numerator for the fraction part, right? That comes from the remainder. And then 3 will be the denominator for the fraction part, because again, we use the denominator from the improper fraction. So 17 thirds is equal to 5 and 2 thirds. What about 23 ninths? Well, again, take 23 and divide that guy by 9. 9 goes into 23 twice. 2 times 9 is 18. Subtract here. Borrow from the 2. 13 minus 8 is 5. So we get 2 with a remainder of 5. So now we can set up our mixed number. So the whole number part will be a 2, right? That's your quotient from the division. The numerator for the fraction part will be a 5, right? That comes from your remainder. And then the denominator part for the fraction in the mixed number is going to be a 9, right? Again, we just copy that from the denominator of the improper fraction. So 23 ninths is equal to 2 and 5 ninths. Hello and welcome to Pre-Algebra Test Section 3 on mixed numbers and improper fractions. Okay, so we just want to convert each improper fraction into a mixed number. And we're going to start out with 51 halves. So if we have an improper fraction and we want to convert it into a mixed number, the first thing we do is we divide the numerator by the denominator. So what is 51 divided by 2? 2 goes into 5 twice. 2 times 2 is 4. Subtract and get 1. Now I'm going to bring down this 1. 2 goes into 11 5 times. 5 times 2 is 10. Subtract and get 1. So this division would give us 25 with a remainder of 1. Now we're going to use this information to build our mixed number. So the whole number part of the mixed number comes from the quotient, which in this case is 25. The numerator for the fraction part of the mixed number comes from the remainder. So in this case, your remainder is 1. So that's going to be my numerator for the fraction part. And then the denominator for the fraction part of the mixed number is the same as the denominator from your improper fraction. So that's just going to be a 2. So 51 halves is the same thing as 25 and 1 half. What about 78 19ths? Again, just set up a long division. So we'd have 78, my numerator, divided by 19, my denominator. So how many times will 19 go into 78? Well, again, when we do long division, and we don't have numbers that we're very familiar with, we kind of have to make some educated guesses. I'm going to think that 19 times 4 is going to do the trick for me. I know that 20 times 4 is 80. 19 times 4 should be 4 less than that, which means it's 76. So 19 will go into 78 4 times. 4 times 19, as I just said, is 76. Subtracting, you get 2. So this is 4 with a remainder of 2. So let's build our mixed number now. So the whole number part is the 4, right? That's the quotient from the division. The numerator for the fraction part is a 2, right? That comes from the remainder. And then the 19, which in the improper fraction is your denominator, is going to be the denominator for the fraction part of the mixed number. So 78/19 is equal to 4 and 2/19. Okay, so let's take a look at 115/11. So we have 115, and we're going to divide that by 11. So 11 is not going to go into 1, but it can go into 11. 11 goes into 11 once. 1 times 11 is 11. Subtracting gets 0. Bring down the 5 there. 11 goes into 5 0 times. 0 times 11 is 0. Subtracting get 5. So we would get 10 with a remainder of 5. So let's build our mixed number. So we know that the whole number part is going to be 10, right? That's the quotient from the division. The numerator for the fraction part is a 5, right? We get that from the remainder. And then the denominator for the fraction part, we steal that from the denominator of the improper fraction, so that's going to be an 11. So 115/11 is equal to 10 and 5/11. Hello and welcome to Pre-Algebra Test Section 4 on mixed numbers and improper fractions. So we want to convert each mixed number into an improper fraction. Okay, so we're going to begin with 18 1/3. And what we're going to do is we're going to take the denominator from the fraction part of the mixed number, which in this case is a 3, and we're going to multiply that guy by the whole number part of the mixed number, which is 18. Now once we've done that operation, we're going to add our numerator, so plus 1, and this is all over the denominator from the fraction part of the mixed number, so it's all going to be over 3. So what is 3 times 18? 3 times 18, or 18 times 3. 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. So that's 54. If I add 1 to that, I get 55. So this is 55 over 3. And that's it. It's just that simple. Let's take a look at 12 1/2. Again, I'm going to take the denominator from the fraction part of the mixed number, which is 2. And I'm going to multiply it by 12, the whole number part of the mixed number. When this is done, we add to it 1, which is the numerator from the fraction part of the mixed number. And then this is all going to be over a 2, right? That's the denominator from the fraction part of the mixed number. So 2 times 12, or 12 times 2 is 24. If you add 1 to that, you get 25, and this is over 2. So what we get is 12 1/2 is equal to 25 halves. All right, let's take a look at 14 3/5. Again, take the denominator from the fraction part of the mixed number, which is 5 in this case, multiply by the whole number part. So 5 times 14. And then we're going to add to that the numerator from the fraction part of the mixed number, so plus 3. And then put this over a 5, right, which is the denominator from the fraction part of the mixed number. So what's 5 times 14? So 14 times 5, 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7. So that's 70. If I add 3 to that, I just get 73. And this is over 5. So 14 3/5 is equal to 73/5. Hello and welcome to Pre-Algebra Test Section 5 on mixed numbers and improper fractions. Okay, so we just want to convert each mixed number into an improper fraction. So we're going to start out with 7 11/13. So it's pretty easy to convert a mixed number to an improper fraction. All we really need to do is take the denominator from the fraction part of the mixed number, which in this case is 13, and multiply it by the whole number part. So we'd have 13 times 7. Now, once we've performed this operation, we're going to add 11, which is the numerator from the fraction part of the mixed number. Now, the denominator for this improper fraction that we're making comes from the denominator of the fraction part of the mixed number. So the denominator is just going to be 13. So let's crank this out. what is 13 times 7? 7 times 3 is 21. 7 times 1 is 7, plus 2 is 9. So this is 91, and I would add 11 to that. So 91 plus 11. 1 plus 1 is 2. 9 plus 1 is 10. So the numerator is going to be 102, and the denominator is going to be 13. So 7 and 11 thirteenths is equal to 102 thirteenths. What about 21 and 8 ninths? Well, again, just take your denominator from the fraction part of the mixed number, which in this case is 9, and multiply it by the whole number part. So times 21. When we're done with this, we're going to add 8, which again is the numerator for the fraction part of the mixed number, and put this over 9, which is your denominator from the fraction part of the mixed number. So what is 21 times 9? 9 times 1 is 9. 9 times 2 is 18. So this is 189. Then we're adding 8. 9 plus 8 is 17. 1 plus 8 is 9. Bring down the 1. So this is 197 over a denominator of 9. So 21 and 8 ninths is equal to 197 ninths. All right, lastly, we're going to look at 7 and 7 ninths. So again, we take our denominator from the fraction part of the mixed number, which in this case is a 9, multiply by the whole number part, which is a 7. When we're done, we add the numerator from the fraction part of the mixed number. So we're going to add 7 to that. And remember, our denominator is the same as the denominator from the fraction part of the mixed number. So we all know that 9 times 7 is 63, and 63 plus 7 is 70. So this would be 70 over 9, or we could say that 7 and 7 ninths is equal to 70 ninths. Hello and welcome to Pre-Algebra Practice Set number 28. In this video, we're going to look at some additional practice problems for our lesson on finding the greatest common divisor. So we want to find the greatest common divisor for each group of numbers. We're going to start out with finding the greatest common divisor for 12 and 27. So before we kind of get started here, I want to just remind you that finding the greatest common divisor and finding the greatest common factor is the same thing. So if I asked you for the greatest common divisor of 12 and 27, I could have also said what is the greatest common factor of 12 and 27, and it would be the exact same thing. So we begin by finding the prime factorization for each number. So for 12, I could do 4 times 3, or I could do 6 times 2. Let's do that. 6 times 2. I'm going to circle 2 because it's prime, and then 6 is 3 times 2. And 3 and 2 are both prime, so I'm going to circle both of those. Then for 27, we begin with 9 times 3. 3 is prime, so we're going to circle that. Then 9 is 3 times 3. 3 is prime, so we're going to circle both of those. All right, so let's write the prime factorization for each number below. So 12 is 2 times 2 times 3. 27 is 3 times 3 times 3. So the next thing we're going to do is build a list. And that list is going to contain all the prime factors that are common to each prime factorization. So for example, when I look at the prime factorization of 12, I see a 2, a 2, and a 3. So looking at 27, I don't see any 2s, and I see 3 3s. Now, I just have 1 3 in the prime factorization of 12, so I can match that with 1 3 from the prime factorization of 27. So in my list, I will just have one number, and that's just one single 3. Again, so that you're not confused, I'm not putting any 2s in my list because there's no 2s in the prime factorization of 27. It's got to be common to everything. I only put one single 3 in my list because 12 has 1 3 in the prime factorization. I can't do anything with these other 2 3s in the prime factorization of 27 because they're not common to both, right? It's got to be common to both. So my list contains one single number. So in this case, it's going to be the answer. So the greatest common divisor of 12 and 27 is going to be 3. Now, in most cases, you have more than one number in your list. When that happens, you just multiply the numbers in your list together, and that would give you your greatest common divisor. In this case, we just have one number, so that is the greatest common divisor. And again, it's 3 in this case. Okay, let's look at finding the greatest common divisor for 945 and 840. So 945. And again, when you try to factor a number like this, use your divisibility rules. We don't work with 945 that often, but we can see it ends in a 5, so we know that it's at minimum divisible by 5. 5 goes into 9 once. 1 times 5 is 5. Subtract, you get 4. Bring down the 4. 5 goes into 44 8 times. 8 times 5 is 40. Subtract, you get 4. Bring down the 5. 5 goes into 45 9 times. 9 times 5 is 45. Subtract, and you would get 0. So 189 times 5 would give me 945. I know that 5 is a prime number, so I can circle and stop. What about 189? Just eyeballing it, 1 plus 8 is 9, 9 plus 9 is 18, so this number is divisible by 9. So it's divisible by 9, so we do 189 divided by 9. 9 goes in 18 twice, 2 times 9 is 18. Subtracting, get 0, bring down the 9. 9 goes into 9 once, 1 times 9 is 9. Subtracting, get 0. So 21 times 9 is 189. Now neither number is prime. 9 is 3 times 3. 3 is prime, so we can circle both of these. And then 21 is 7 times 3. 7 and 3 are both prime, so we can circle those. So what I'm going to do is I'm going to take this prime factorization, I'm going to write it on the next page. So 945 is 3 times 3 times 3, or 3 cubed times 5 times 7. 945 is 3 times 3 times 3 times 5 times 7. All right, now let's find the prime factorization for 840. Now this number ends in a 0, so I know that it's divisible by 10. So if I divide a number with a trailing 0 by 10, I just cut the 0 off. So 840 would be 84 times 10. Now 10 and 84, neither of those are prime. 10 is 5 times 2. 5 and 2 are both prime. 84, I know that ends in a 4, so it's an even number. It's at least divisible by 2. So in order to figure out if 84 is divisible by 4, I'd have to actually do the division. So 84 divided by 4. 4 goes in 8 twice. 2 times 4 is 8. Subtracting, get 0. Bring down the 4. 4 goes into 4 once. 1 times 4 is 4. Subtracting, get 0. So 84 is 21 times 4. Neither number is prime, so we continue. 4 is 2 times 2. 2 is prime, so we're going to circle both. 21 is 7 times 3. 7 and 3 are both prime, so we're going to circle both of those. So 840, we're going to write the prime factorization for this on the next page. So we have 2 times 2 times 2, or 2 cubed, times 3 times 5 times 7. So 840, 2 times 2 times 2, times 3 times 5 times 7. And when you start getting a lot of numbers here, it kind of helps to make a little table. So let's do that. So if I have 945 and I have 840, let's make a little table. So look for your smallest prime factor in any of these. In 840, it's 2, and I have 3 factors of that. So 2 times 2 times 2. And up here, I don't have any factors of 2, so I would just put spaces there. Now, the next smallest prime factor would be 3. So in 945, there's 3 of them. So I'd put 3 times 3 times 3. Here, there's just 1. So I'm going to put times 3 and then spaces there. And then the next largest prime factor is 5. So then times 5, down here to be times 5, and then times 7 times 7. So when you make a little table like this, you're just making it easy to see what's common to both, right? I can immediately tell that 2 is not common to both. I can tell that there's 1 3 that's going to be common to both, 1 5, and 1 7. These 3's here are not going to be common to both because there's nothing to match it with down here. So kind of a simple way to do it when you have some large numbers with a prime factorization that's a decent size. So the GCD, or the greatest common divisor, for 945 and 840, again, you would form a list, and the list has what's in common there. So it would be 3, 5, and 7, and you would just multiply these numbers together. So 3 times 5 times 7. 3 times 5 is 15. 15 times 7. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. So this would be 105. So the greatest common divisor, or again, the greatest common factor of 945 and 840 is 105. All right, what about the greatest common divisor for 399 and 200? So 399. So 399, nothing jumps out at me right away. When I see numbers that end with a 9, I always try to see if they're divisible by 9. So 3 plus 9 is 12. 12 plus 9 is 21. 21 is not divisible by 9, but it is divisible by 3. So I know that 3 times something will give me 399. 3 goes into 3 once. 1 times 3 is 3. Subtracting gets 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. Subtracting gets 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. Subtracting gets 0. So 3 times 133 would give me 399. Now 3 is a prime number, so I can circle that and stop. 133, is that a prime number? Well, I don't really know. So what I can do is use my square root trick. Punch up square root of 133 in your calculator. You'll get about 11.5. So just go to the next highest whole number. So that would be 12. So I'm going to test all the prime numbers from 2 up through 12. So I'm going to test for 2, 3, 5, 7, and 11. So I know it's not divisible by 2, it's not even. 1 plus 3 is 4, 4 plus 3 is 7, not divisible by 3. Doesn't end in a 5 or 0, not divisible by 5. For 7, cut off the final digit of the number, so I'd have 13. Double that, 3 times 2 is 6, subtract it away. 13 minus 6 is 7. It is going to be divisible by 7. So let's divide this guy by 7. 7 goes into 13 once. 1 times 7 is 7. Subtracting gets 6. Bring down the 3. 7 goes into 63 9 times. 9 times 7 is 63. Subtracting gets 0. So 133 is 7 times 19. So we'll circle 7 and circle 19 because those are both prime numbers. And our prime factorization is going to be 3 times 7 times 19. So for 399, it's 3 times 7 times 19. All right, what about 200? 200 is easy because it has 2 trailing zeros. So 100 times 2 is 200. So let's start with that. 100 times 2. 2 is prime, so we can circle that. 100 I could do, let's say 25 times 4. 4 is 2 times 2. 2 is prime, so I can circle both of those. 25 is 5 times 5. 5 is prime, so I can circle both of those. So 2 cubed times 5 squared. So 200 is 2 times 2 times 2 times 5 times 5. Now we can go through and make a little chart like we did in the last one, but really it's not necessary because if you just kind of eyeball this, you see that there's nothing in common. This has a prime factor of 3, there's no 3 here. This has a prime factor of 7, there's no 7 here. This has a prime factor of 19, there's no 19 here. So really I've checked through everything. There's nothing else I can do. The greatest common divisor here, the greatest common divisor of 399 and 200 is going to be 1. So when there's no factors in common, the greatest common divisor is 1, because remember, I can take any number and divide it by 1 and get itself. So 1 is a divisor for everything. So when there's nothing in common, 1 is going to be the greatest common divisor or the greatest common factor. All right, what about one with 3 numbers involved? So we have 15, 75, and 60. So this one's pretty easy. So we have 15, that's 5 times 3. Circle 5, circle 3. 75, I could think of as 5 times 15. Circle 5. 15 is 5 times 3. 5 and 3 are both prime. And then 60 is 5 times 12. 5 is prime, circle that. 12 is 4 times 3. 3 is prime, circle that. 4 is 2 times 2. 2 is prime, we're going to circle both of those. So pretty easy to get the prime factorization for these 3 numbers. And now we just go through and say, okay, 15 is 5 times 3. 75 is 5 times 5 times 3. And then 60 is 5 times 3 times 2 times 2. So 5 times 3 times 2 times 2. So when we look at these numbers to build our list, okay, our list, we see that everything has a 5 in the prime factorization. Everything has a 3 in the prime factorization, and that's it. We really can't do anything else. So the list would have a 5 and a 3. So the greatest common divisor here for 15, 75, and 60 would be 5 times 3, which is 15. All right, for the last one, we have the greatest common divisor of 2,600, 650, and 1,300. So 2,600, we will begin by factoring this guy. It has 2 trailing zeros, so I know I can do 26 times 100. 26 is 13 times 2. 13 and 2 are each prime numbers. 100, I can do 25 times 4. 4 is 2 times 2. 25 is 5 times 5. And 5 and 2 are each prime numbers, so we're going to circle these guys. So the prime factorization for 2600, we're going to have 1, 2, 3 factors of 2, or 2 cubed, times 2 factors of 5, or 5 squared, times 13. So 2,600, let's write this guy as 2 times 2 times 2, times 5 times 5, times 13. Okay, what about 650? Well, it has 1 trailing 0, so I know it's divisible by 10. So let's do 65 times 10. 10 is 5 times 2. 5 and 2 are prime, so we can circle those. Now for 65, just use some mental math here. So most of you are going to know that 60 divided by 5 gives you 12, right? Meaning that 12 times 5 gives you 60. So knowing that, what would 13 times 5 be? Well, it would be 65. Right? It would be 5 more than what you got here. So then 65 is 13 times 5. So now I know that 13 is prime, and I know that 5 is prime, so we can circle both of those. So 650 is going to be 2 times 5 squared times 13. What about 1300? 2 trailing zeros at the end, so I know it's divisible by 100. So I can do 13 times 100. 13 is prime, so I can circle that guy. 100 is 25 times 4, or let's go ahead and do 10 times 10. 10 is 5 times 2. And 5 and 2 are prime numbers, so we can circle all of these, and we're done. So the prime factorization here is 2 squared times 5 squared times 13. So for 1300, it's 2 times 2 times 5 times 5 times 13. All right, so when you have a lot of numbers involved here, sometimes it'll help you to make a little table. Now you don't have to do this. You can kind of just do it with your pen and paper like you normally do, but a table will sometimes be helpful for you. So 2600, 650, and 1300. And basically what you want to do is just try to line the common factors on top of each other. So for example, with 2600, the smallest factor is a 2. So I'm going to start out by putting 2 times 2 times 2. Now I go down to the next number and I look for 2's. So I just have one factor, and then I'm just going to arrow out the rest of this because I'm not going to have 3 factors of 2. I'm not going to have 2 factors of 2. I'm only going to have 1 factor of 2 that's common to both of these numbers. Now even if I have more than 1 factor of 2 in 1300 as I do, I've already boxed it out telling me that it's not going to be common to everything. And you don't really even need a box. You could just put a line or something. It doesn't really matter. It's just showing that it's not common to everything. So for 1300, I have 2 factors of 2. And then I'm going to put a little line there. And you can kind of cut that off. Now I know that I'm going to have 1, 2 that's going to be common to everything, right? 1, 2, and only 1, 2. Now, moving to the next smallest factor, that's going to be a 5. So in 2600, I have 2 of those guys. In 650, I have 2 of those guys. And in 1300, I have 2 of those guys. Then I have 13. I have 1 factor in every number. So really, all these are common to everything. So when I build my list is going to contain what's common to everything. And it's what's highlighted here. It's got 1, 2. It's got 2 5s. And it's got 1 13 in it. And to find the greatest common divisor for 2600, 650, and 1300, really what I'm doing is I'm just multiplying the numbers on the list together. So 2 times 5 times 5 times 13. 2 times 5 is 10. 10 times 5 is 50. So then I have 50 times 13. So 3 times 0 is 0. 3 times 5 is 15. 1 times 50 is 50. Bring down the 0. 5 plus 0 is 5. 1 plus 5 is 6. So we're going to end up with 650 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on finding the greatest common divisor. So we just want to find the greatest common divisor for each group of numbers. We're going to start out with finding the greatest common divisor for 26 and 65. So the first step is always just to factor the numbers. So for 26, it's just 13 times 2. 13 times 2. Each number here is prime, so we can circle and stop. For 65, I did this in another video, so I already know that it's 13 times 5. But again, a little mental trick to help you with that. If you know that 12 times 5 is 60, well then 13 times 5 would be 5 more than that, so 65. So we're going to circle 13 and 5 because those are both prime. So now that we've found the prime factorization for each number, let's just write it down here. So we have 26 is equal to 13 times 2. 65 is equal to 13 times 5. Now generally we'll make a list, and that list will contain all the numbers that are common to all the prime factorizations. Here we just have one single number, 13, that's common to both prime factorizations. So our list would just contain one number, and that number would be 13. Normally, when you have more than one number, to find the greatest common divisor, you find the product of all those numbers on your list. But since we just have one number here, so your greatest common divisor for 26 and 65 will just be this number 13, because that's the only number that's common to both prime factorizations. Okay, we're going to take a look at one more. We're going to find the greatest common divisor for 175. So we're going to factor each. So 100 I can do 10 times 10. 10 is 5 times 2. So we're going to circle 5 and 2 because those are prime. 75 I can think of as what? 5 times 15. 5 is prime. 15 is 5 times 3. 5 is prime, 3 is prime. So let's write this down here. We have 100 is equal to 2 times 2 times 5 times 5. We have 75 is equal to 3 times 5 times 5. So when we make our little list, again, we're looking for what's common to both prime factorizations. 2 is not common to both. 3 is not common to both. Just 5 is. Each prime factorization has 2 5s in it, so our list would contain 2 5s. So the greatest common divisor for the numbers 100 and then 75 would be 5 times 5, which is 25. Again, when you have more than one number on your list, you just find the product of all the numbers on the list. In this case, we have 2 5s. 5 times 5 gives us 25, so that's our answer. Hello and welcome to Pre-Algebra Test Section 2 on finding the greatest common divisor. So we want to just find the greatest common divisor for each group of numbers. We're starting out with the greatest common divisor of 87 and 406. So these are two numbers that we really don't work with that often. But basically, we want to just begin by finding the prime factorization for each number. So for 87, it's an odd number, so I know it's not divisible by 2. I can look and see that 8 plus 7 is 15. It's going to be divisible by 3. So let's start with that. What is 87 divided by 3? 3 goes into 8 twice. 2 times 3 is 6. Subtracting, you get 2. Bring down the 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtracting gets 0. So 87 is 3 times 29. Now 3 is a prime number. A lot of you probably don't know at this point that 29 is a prime number, but it is. Again, use your square root trick that I taught you a few lessons ago. Square root of 29 on a calculator will give you about 5.38. If you go to the next highest whole number, that would be 6. 6 is not a prime number, so you don't even need to worry about it. Really, you would just need to test to see if 29 is divisible by 2, 3, and 5 to see if it's a prime number. It's not even, so it's not divisible by 2. 2 plus 9 is 11, not divisible by 3. Last digit is not a 0 or 5, so it's not divisible by 5. So it is a prime number. So 87, let me just write this down here. 87 is 3 times 29. What about 406? 406. Well, this one's even, so I know it's at least divisible by 2. It's not divisible by 4 because the final two digits form the number 6. 6 is not divisible by 4. 4 plus 6 is 10. It's not divisible by 3. So let's just try 406 divided by 2 and see what we get. 2 goes into 4 twice. 2 times 2 is 4. Subtracting gets 0. You'd bring down a 0. 2 goes into 0 0 times. 0 times 2 is 0. Subtract and you get 0. Bring down the 6. 2 goes into 6 3 times. 3 times 2 is 6. Subtract and you get 0. So 203 times 2. 203 times 2. Now I know 2 is a prime number, so I can circle that and stop. What about 203? So I don't know if this is prime or not, so I'd have to use my square root trick. So punch up square root of 203 on a calculator, you get about 14.24. So I'm going to test all the prime numbers from 2 up to and including 15, right? The next highest whole number. So that would give me 2, 3, 5, 7, 11, and 13 that I need to test. Right? 14 is not prime and neither is 15. So it's not divisible by 2 because it's not an even number. It's not divisible by 3. We just checked that. 2 plus 3 is 5. 5 is not divisible by 3. Not divisible by 5. It doesn't end in a 0 or 5. What about 7? So 203. Cut off the 3 and double it. 3 times 2 is 6. So if I cut off the 3 and double it, I get a 6. Subtract that away, I get 14. 14 is divisible by 7, so that means this number is divisible by 7. So what is 203 divided by 7? 7 goes into 20 twice. 2 times 7 is 14. Subtracting gets 6. Bring down the 3. 7 goes into 63 9 times. 9 times 7 is 63. Subtracting gets 0. So 29 times 7 is 203. Now 29 is prime, and so is 7. So the prime factorization for 406 is going to be 2 times 7 times 29. Now generally what we do in the next step is we make a list that contains all the numbers that are common to all the prime factorizations. Here we just have 2 prime factorizations to look at, and we only have one single number that's common to both, and that's that number 29. So generally speaking, we'll have more than one number, and to find our greatest common divisor, we'll find the product of the numbers on the list. But in this case, since we just have one number, it's just that number. So the greatest common divisor for 87 and then 406 is going to be 29, right? Just the number that's in common to both. Let's take a look at another one. What about the greatest common divisor for 1085 and 117? So for 1085, it ends in a 5, so I can start there. So 1085 divided by 5. 5 goes into 10 twice. 2 times 5 is 10. Subtracting, you get 0. Bring down the 8. 5 goes into 8 once. 1 times 5 is 5. Subtracting, you get 3. Bring down the 5. 5 goes into 35 7 times. 7 times 5 is 35. Subtracting, gets 0. So 217 times 5. 5 is prime, so we can circle that and stop. What about 217? Well, nothing jumps out at me, so take the square root of the number. You get about 14.73. So I need to test 2, 3, 5, 7, 11, and 13. Right? 14 and 15 are not prime numbers, so I don't need to worry about those. So right away I can cross out 2. It's not an even number. 2 plus 1 is 3. 3 plus 7 is 10, not divisible by 3. Not a 0 or a 5 for the final digit, so it's not divisible by 5. Let's think about 7. So 217, I would cut off the 7, and I would double it. So I'd take 21, that'd be my new number. 7 doubled is 14. 21 minus 14 is 7. 7 is divisible by 7. So 217 will be divisible by 7. 7 goes into 21 3 times. 3 times 7 is 21. Subtracting gets 0. Bring down the 7. 7 goes into 7 once. 1 times 7 is 7. Subtracting gets 0. So this is 31 times 7. 7 is prime, and so is 31. So 1085, we have 5 times 7 times 31. 1085, 5 times 7 times 31. Okay, let's check out 117. So what I normally do before I start thinking about is the number prime or not, I just go through the first few numbers to see if it's divisible. And I check 2. It's not an even number, so that's out right away. Then I think about 3. 1 plus 1 is 2. 2 plus 7 is 9. 9 divided by 3 is 3, no remainder. So I know it's divisible by 3. So 117 divided by 3. 3 goes into 11 3 times. 3 times 3 is 9. Subtracting, get 2. Bring down the 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtracting, get 0. So 3 times 39 produces 117. Now 3 is prime, but 39 is not. 39 is 3 times 13. 3 is prime, and so is 13. So 117 is 3 times 3 times 13. 117 is 3 times 3 times 13. So on my list, remember, I'm trying to put things in that are common to both prime factorizations. Well, what happens is when we look through the prime factorizations, nothing's in common. This has a 5, this doesn't. This has a 7, this doesn't. This has a 31, this doesn't. This has a 3, this doesn't. This has a second 3, this doesn't. This has a 13, this doesn't. So nothing is in common. So my list is pretty much just blank. Right? I'm going to put a sad face. That's my list. So what happens is for your greatest common divisor for these two numbers, 1085 and 117, it's just going to be 1. Remember that 1 is going to be a factor or a divisor for any number, right? If I take a number and I divide it by 1, I just get the number back. So when this happens and you have no numbers that are common to both prime factorizations, your greatest common divisor is 1. Hello and welcome to Pre-Algebra Test Section 3 on finding the greatest common divisor. So we're going to find the greatest common divisor for each group of numbers. We just have one problem here, and we're going to work on the greatest common divisor of 805, 322, and 4025. So the first thing you're going to do is find the prime factorization for each number. So we'll start with 805. Now it ends with a 5, so I know it's divisible by 5. So 805 divided by 5. 5 goes in 8 once. 1 times 5 is 5. Subtract, you get 3. And bring down the 0. 5 goes into 36 times. 6 times 5 is 30. Subtract and get 0. Bring down the 5. 5 goes into 5 once. 1 times 5 is 5. Subtract and get 0. So 161 times 5 would give me 805. Now I know that 5 is a prime number. I don't know about 161. I don't work with it that often. Usually I'll look at the first few numbers. It's not divisible by 2. 1 plus 6 is 7. 7 plus 1 is 8. Not divisible by 3. 61 is not divisible by 4. It's not divisible by 5. So at that point I pull out my calculator and I see, what's the square root of 161? Well, it's about 12.68. So I would test all the prime numbers up through and including 13. So that means I'm looking at 2, 3, 5, 7, 11, and 13. Now I already crossed these out. I need to look at 7. So for 7, I remove the last digit of the number. So take the 1 off, double it. 1 times 2 is 2. Subtract it away. I get 14. 14 is divisible by 7. So 161 is going to be divisible by 7. So it's not a prime number. 7 will go into 16 twice. 2 times 7 is 14. Subtract and get 2. Bring down the 1. 7 goes into 21 3 times. 3 times 7 is 21. Subtract and get 0. So 7 times 23 is 161. So we know that 7 is prime and 23 is prime. So now we're done. The prime factorization of 805 is 5 times 7 times 23. So 805 is 5 times 7 times 23. Okay, the next number is 322. So that's an even number, so I know it's at least divisible by 2. So let's start by dividing 322 by 2. 2 goes into 3 once. 1 times 2 is 2. Subtract and get 1. Let's bring down this 2 here. 2 goes into 12 6 times. 6 times 2 is 12. Subtract and get 0. Bring down the 2. 2 goes into 2 once. 1 times 2 is 2. Subtract and get 0. So 2 times 161 is 322. Now, we just looked at 161 and we found that it was 23 times 7. So now everything is prime here. 2 is prime, 23 is prime, and 7 is prime. So for 322, we have 2 times 7 times 23. All right, lastly, we have 4,025. So the number ends in a 5. So I know it's divisible by 5. So 4,025 divided by 5. 5 goes into 40 8 times. 8 times 5 is 40. Subtract, you get 0. Bring down the 2. 5 is not going to go into 2, so I put a 0. 0 times 5 is 0. Subtract and get 2. Bring down the 5. 5 goes into 25 5 times. 5 times 5 is 25. Subtract and get 0. So 805 times 5 gives me 4,025. So 5 is prime. 805 is not. It ends in a 5, so it's divisible by 5. So 805 divided by 5. 5 goes into 8 once. 1 times 5 is 5. Subtract and get 3. Bring down the 0. 5 goes into 36 times. 6 times 5 is 30. Subtract and get 0. Bring down the 5. 5 goes into 5 once. 1 times 5 is 5. Subtract and get 0. So here we get our number again, 161. So we know 5 is prime. And 161, we know already that that is 23 times 7. So for 4,025, we're going to have the prime factorization as 5 times 5 times 7 times 23. So now that we have all the prime factorizations, we just want to look and see what's common to everything. So I have a 5 here, but no 5 here, so 5 can't be in the list. It's got to be common to everything. I have a 7 here, a 7 here, and a 7 here. So 7's going to go on the list. I have a 23, a 23, and a 23, so that's going in the list. And I have this 2 over here, but it's not in any other prime factorization, so that's not going in. So the only thing that's going in the list is 7 and then 23. That's it. So for my greatest common divisor, all I do is I form the product of the numbers in the list. Meaning I'm just going to multiply 7 times 23, and we already know that's 161, and that's going to be my greatest common divisor, right? It's just the product of the numbers that are common to all the prime factorizations. Hello and welcome to Pre-Algebra Test Section 4 on finding the greatest common divisor. Okay, so we just want to find the greatest common divisor for each group of numbers, and we're looking at one problem here. We want to find the greatest common divisor for 1,620, 300, 1,500, and 3,900. So the first thing I'm going to do is find the prime factorization for each number involved. So I'm going to start out with 1,620. And it has a trailing 0, so I know it's divisible by 10. So I can do 162 times 10. 10 is 5 times 2. 5 and 2 are each prime numbers. So I'm going to circle these and stop. 162 is even, so it's at least divisible by 2. What is 162 divided by 2? 2 goes into 16 8 times. 8 times 2 is 16. Subtract, that will give you 0. Bring down the 2. 2 goes into 2 once. 1 times 2 is 2. Subtract and get 0. So 2 times 81. So 2 is prime. 81 is 9 times 9. And 9 is 3 times 3. 3 is prime, so we're going to circle those guys. So my prime factorization is 2 times 2, or 2 squared, times 3 times 3, times 3 times 3, or 3 to the 4th power, times 5. All right, let's take a look at 300. So it ends with 2 trailing zeros. So I know I could do 3 times 100. 3 is prime. Then for 100, I could do 10 times 10. 10 is 5 times 2. 5 and 2 are prime numbers, so we can circle those. And so we have our prime factorization. We have 2 times 2, or 2 squared, times 3, times 5, or 5 squared. So 300. So 2 times 2 times 3. And I'm going to try to write it to where it lines up. So I'm going to skip some spaces over here and put times 5 times 5. Okay, let's look at 1,500 now. So it's got two trailing zeros, so I can do 15 times 100. 15 is 5 times 3. 5 and 3 are prime numbers. 100, I can do 10 times 10. I know 10 is 5 times 2. 5 and 2 are prime numbers. So the prime factorization here is 2 times 2, or 2 squared, times 3, times 5 times 5 times 5, or 5 cubed. So 1,500 is equal to, I've got two factors of 2, times one factor of 3, times, and then I've got three factors of 5. And I'll remove this multiplication symbol here just to keep this consistent. And again, I'm just leaving this space blank so we can see what we have in common. All right, last one we're going to do is 3,900. So two trailing zeros, I know I can do 39 times 100. 100 is 10 times 10. 10 is 5 times 2. 5 and 2 are prime. 39 is 3 times 13. 13 and 3 are both prime. So the prime factorization here is 2 squared times 3 times 5 squared times 13. So 1,300, again, 2 squared, or 2 times 2, times 3 times 5 times 5, and then I have times 13. So the next thing we're looking for is to make a list of what's common to all the prime factorizations. So I have one 2 that's common to everything, then a second 2 that's common to everything. So I'm going to put two 2's in there. I have one 3 that's common to everything, but look here, I have a 3, another 3, and another 3 that's in the prime factorization of 1,620 that's not matched anywhere else. So because it's not common to everything, it doesn't go in there. Even if it was common to 3 of them, but not the 4th, it doesn't go in there. It's got to be common to everything. Let me go ahead and put this 3. The next number that would go in would be this 5 here. That's common to everything. So this 5 goes in. And notice how a second 5 is common to everything except for 1,620. So that means it doesn't go in, right? It's not common to everything. And then we look down here, we have a third factor of 5 and 1,500, and we have this factor of 13 and 1,300. Again, if it's not common to everything, it doesn't go in. So we have 2, another 2, a 3, and then a 5. These are the numbers that were common to all the prime factorizations, so that's what goes in our list. So then for my greatest common divisor, for 1,620, 300, 1,500, and then 1,300, all I'm going to do is find the product of the numbers on the list. So 2 times 2 times 3 times 5. 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. Hello and welcome to Pre-Algebra Test Section 5 on finding the greatest common divisor. So we want to find the greatest common divisor for each group of numbers, and we're just going to look at one problem here. So we want to find the greatest common divisor for 2,400, 3,150, and 6,300. So our first step is to find the prime factorization for each number. So we'll start out with 2,400. It ends with two trailing zeros, so it's divisible by 100. So 24 times 100. 24 is 8 times 3. Could do that. 3 is prime. 8 is 4 times 2. 2 is prime. 4 is 2 times 2. 2 is prime. And we're going to circle both of those. Now let's look at 100. 100, let's do 25 times 4. 4, let's do 2 times 2. And 2 is prime, so we're going to circle those. 25 is 5 times 5. 5 is prime, so we're going to circle those. So 2,400 is going to be 2 times 2 times 2 times 2 times 2, or 2 to the 5th power, times 3 times 5 times 5, or 5 squared. So 2,400 is equal to 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5 factors of 2 times 3 times 5 times 5. All right, next we're looking at 3,150. So that ends with a 0. So that means it's divisible by 10. So I can do 315 times 10. 10 is 5 times 2. 5 and 2 are prime numbers. What about 315? I don't see that number too often. Is it prime? No, I know that it isn't because it ends in a 5. So I can do 315 divided by 5. 5 goes into 31 6 times. 6 times 5 is 30. Subtract and get 1. Bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtract and get 0. So 63 times 5 gives me 315. Now I know that 5 is prime, so I can circle that and stop. What about 63? Well, I know that's 9 times 7. 9 times 7, 7 is prime. 9 is 3 times 3. 3 is prime, we're going to circle both of those. So the prime factorization here is going to be 2 times 3 times 3, or 3 squared, times 5 times 5, or 5 squared, times 7. And then usually I try to write the common factors on top, but this one's going to be pretty easy. I'm just going to write 2 times 3 times 3 times 5 times 5 times 7. Okay, the last one we're going to look at is 6,300. It ends with 2 trailing zeros, so we can do 63 times 100. 100 we can do 10 times 10. 10 is 5 times 2. Okay, we're going to circle the 5 and the 2. The 5 and the 2, those are prime. 63 we know is 9 times 7. 7 is prime. 9 is 3 times 3. Circle the 3's. And we have our prime factorization. So we have 2 times 2, or 2 squared, times 3 times 3, or 3 squared, times 5 times 5, or 5 squared, times 7. So once we've found all the prime factorizations, we make a list. And in this list, we look for all the numbers that are common to every prime factorization. So if it's not common to every prime factorization, it does not go in the list. So when I look here, let's start with 2. So I've got 2, 2, and 2. So I've got 1, 2 that can go on my list. What about a second 2? Well, no. Although there's 1, 2, 3, 4 more 2's in this prime factorization, there's no more 2's in this one, so I can't put it in the list, right? There's 1 more 2 in this one, but it doesn't matter. It's got to be common to everything, and what's common to everything is 1, 2. When I start looking here, and I can kind of just temporarily line out these 2's just to get them out of my way. The next thing I think about is 3. Now I have a 3 here, here, and here. So 1, 3 will be common to everything. So I'll put a 3 in the list. But again, I have more 3's in other factorizations, but I only have 1 here, so only 1 goes in the list. So I can kind of line these out. I'm not going to think about them anymore. And then what about 5? Well, I have 1, 2 factors of 5 here, 1, 2 factors of 5 here, and 1, 2 factors of 5 here. So in each prime factorization, there are 2 5's, so I can put 2 5's in my list. And this prime factorization doesn't have a 7, although these 2 do. So that doesn't go on the list, and our list is complete. So our list has a 2, a 3, and then 2 5's. What do we do with the list? Well, we multiply the numbers together to get our greatest common divisor. So the greatest common divisor for 2,400, 3,150, and 6,300 is equal to, again, multiply these numbers together. 2 times 3 times 5 times 5. 2 times 3 is 6. 6 times 5 is 30. 30 times 5 is 150. Hello and welcome to Pre-Algebra Practice Set number 29. In this video, we're going to look at some additional practice problems for our lesson on simplifying fractions. So for the problems in this video, we want to reduce each fraction to its lowest terms. And again, if I ask you to simplify a fraction, or if I ask you to reduce a fraction to its lowest terms, I'm asking for the exact same thing. So for our first problem, we have 23 over 46. And this is kind of a problem that students will struggle with. Here's why. When we start this problem out, we factor the numerator and denominator completely. So 23 doesn't factor, it's a prime number. 46 is 23 times 2. Our next step is to cancel common factors between the numerator and denominator. So we cancel this 23 with this 23. Now at this point, a lot of students get confused and they'll say, okay, I don't have anything up here, so I'll put a 0. And then in my denominator, I have a 2. 0 over 2 is 0. That's the wrong answer. And here's why. 23 over 23 is equal to 1. 23 over 23 is equal to 1. And really, I could write this as 1 over 1. So I can replace this 23 up in the top with a 1. I can replace this 23 in the bottom, and then I can put times 2 like this. And then it's crystal clear that what I have is 1 over 2, or 1/2. Another thing I can do, if I have something that completely cancels like this, I can just start out by saying 23 times 1. Remember, 23 times 1 is just 23. So mathematically, this is the same thing as 23 over there. Now when I cancel 23 with 23, it's crystal clear that I have 1/2, right? A 1 in the numerator over a 2 in the denominator. And then kind of an alternative way to think about this is, if I just divide the numerator and denominator by the greatest common divisor, right? The greatest common divisor, which we learned about in our last lesson. So the greatest common divisor for 23 and 46 is 23. If I divide 23 by 23, I get 1, right? It would not be 0. If I divide 46 by 23, I'd get 2. So those are different ways to kind of see that you would end up with 1/2. In the future, if your numerator cancels completely, it's going to be 1. If your denominator cancels completely, it's going to be 1. So if I flip this and had 46 over 23, now I'd have 23 times 2 in the numerator and 23 in the denominator. So 23 here would cancel with 23 here. And the denominator has canceled completely, so I know just to write a 1. And then the numerator is a 2, 2 over 1. I can leave it like that or just write it as 2. This is essentially the same problem as 46 divided by 23, and 46 divided by 23 is 2. What about 2 over 13? Well, this is another unique situation. 2 is a prime number, 13 is a prime number, so we don't really have anything we can cancel between numerator and denominator. The only common factor we have here is 1, right? I could write 2 times 1 over 13 times 1. You know, if you wanted to, you could cancel the common factor of 1, but you still have 2 over 13. Right, so when you have a situation like this, where essentially the greatest common divisor, or remember the same thing as the greatest common factor, right, these are the same. When the greatest common divisor or the greatest common factor is 1, you're not going to be able to simplify the fraction, right? So the result is just going to stay the same. It's just going to be 2/13. What about 81 over 324? Well, 81... I know I can do 9 times 9, and 9 is 3 times 3. So 4 factors of 3. Then 324, we're going to divide this by 4. All right, and the reason I'm going to divide this by 4 to start is I see that 24, the final 2 digits of that number, would be divisible by 4, right? 24 divided by 4 is 6, no remainder. So I know that 324 is divisible by 4. 4 goes into 32 8 times. 8 times 4 is 32. Subtract and get 0, bring down the 4. 4 goes into 4 once. 1 times 4 is 4. Subtract and get 0. So I don't need to make a factor tree here because I know what the prime factorization of 81 is. I just did it. It's 4 factors of 3. And then 4 is just 2 times 2. But essentially, 324 is what? It's just 81 times 4. So 81 over 81 is just 1. So I'm canceling 4 factors of 3, or 81, from the numerator with 4 factors of 3, or 81, from the denominator. And all I'm going to be left with is 2 times 2 in the denominator, or 4. And in the numerator, remember, if everything is canceled, I'm going to write a 1. I'm not going to write a 0. Right? So this is going to be 1/4. And again, just think about the greatest common divisor. The greatest common divisor, or the greatest common factor, of 81 and 324 is going to be 81. So if I divide 81 by 81, I get 1. If I divide 324 by 81, I get 4. What about negative 96 over 40? So again, I have a negative here, so I'm just going to write negative 1 times the prime factorization of 96. So for 96, I could do 32 times 3. 3 is prime. 32, I can do 4 times 8. 4 is 2 times 2. And 8 is 4 times 2. 2 is prime. And 4 is 2 times 2. And at this point, a lot of you will know that 32 is 5 factors of 2. If you don't need to make a factor tree, just skip it. right? Anything that saves you time. Just make sure that you know it and you don't get the wrong answer. The last thing you want to do is have a wrong answer on a test because you made a simple mistake. So we have 1, 2, 3, 4, 5 factors of 2, 1 factor of 3. Okay, this is over. All right, what about 40? The number 40. Well, I know it's 4 times 10. 10 is 5 times 2. 4 is 2 times 2. So we'd have 2 times 2 times 2 times 5. So 3 factors of 2 times 5. So now I'm looking to cancel common factors between the numerator and the denominator. So I'm going to end up canceling 3 factors of 2 in the numerator with 3 factors of 2 in the denominator. Essentially, I'm canceling a common factor of 8 between both. So what's left in the numerator? 2 times 2 is 4, 4 times 3 is 12, then times negative 1 is negative 12, and then over 5. So we end up with negative 12 fifths. And again, to kind of speed this up, if you know your greatest common factor or your greatest common divisor for the two numbers, if you know that that's 8, you can divide each number, right, the numerator and the denominator, by 8 and get to this result quicker. What about 34 over negative 136? So 34 I know is 17 times 2. What about negative 136? Well, I'm going to put negative 1 times, and then what's 136? 36 is divisible by 4, so I know 136 is. 4 goes into 13 3 times. 3 times 4 is 12. Subtract and get 1, bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. Subtract and get 0. So 4 times 34. 4 times 34. So do we need to make a factor tree? Well, 34 we just did. It's 17 times 2. And we know 4 is 2 times 2. So no, I don't need a factor tree. Now I can cancel this 17 with this 17, and this 2 with this 2. And again, if I've canceled my numerator completely, I'm going to put a 1. Right? I'm not going to put a 0. Please don't make that mistake. In the denominator, I have negative 1 times 2 times 2. 2 times 2 is 4. 4 times negative 1 is negative 4. Now, when we have a numerator that's positive and a denominator that's negative, we just write it as negative 1/4 like that. It doesn't really matter. You can keep it this way, but it's all going to be the same. If I have a negative in the denominator, or if I had a negative in the numerator, but not in the denominator, negative divided by positive or positive divided by negative is negative. So in the end, it's just negative 1/4. What about 32 over 72? So 32 I know is 5 factors of 2, right? We just did that earlier. So 1, 2, 3, 4, 5 factors of 2. 72 I know is 8 times 9. 8 is 3 factors of 2. 9 is 2 factors of 3. So now I can cancel 3 factors of 2 in the numerator with 3 factors of 2 in the denominator. Essentially, I'm removing a factor of 8 between the numerator and denominator. And so I have 2 times 2 or 4 in the numerator over 3 times 3 or 9 in the denominator. So we get 4/9 as our answer. And again, if you recognize that the greatest common divisor or the greatest common factor for 32 and 72 is 8, you can just divide them and get that quicker, right? So 32 divided by 8 would be 4, and I would write that down. 72 divided by 8 is 9, and I would write that down. And I would have my simplified fraction in a much quicker manner than going through and factoring and then canceling and whatnot. What about 24 over negative 9? So let's use a little shortcut here. I know that the greatest common divisor of 24 and 9, forget about the negative part, is going to be 3. So the greatest common divisor of 24 and 9 is 3. So 24 divided by 3 is 8. Negative 9 divided by 3 is negative 3. So you'd end up with 8 over negative 3, or you could write this as negative 8 over 3, or you could write this as negative 8/3. Again, when you have a positive divided by a negative, or a negative divided by a positive, the number's just negative. Now again, if we had done this the slower way, factor 24, it's 8 times 3. So 2 times 2 times 2 times 3. Negative 9, we'd write negative 1 times 3 times 3. And then we'd go through and cancel this factor of 3 with this factor of 3. And we ended up with 2 times 2 times 2 or 8 over negative 1 times 3 or negative 3. Again, you get the same answer either way. All right, what about 10 over 28? So 10 over 28. I know that 10 is 5 times 2. So knowing that 28 is not divisible by 5, the greatest common divisor is going to be 2. So I could stop at this point and say that, okay, I'm going to divide 10 by 2 and get 5. I'm going to divide 28 by 2 and get 14. That's kind of a quicker way to do it, right? The greatest common divisor between 10 and 28 is going to be 2. Again, divide 10 by the greatest common divisor of 2, get 5. Divide 28 by the greatest common divisor, which is 2, and get 14. Or, again, the slower way, factor 10, that's 5 times 2. Factor 28, that's going to be 4 times 7. So 2 times 2 times 7. Cancel the 2 between the numerator and denominator. And you end up with 5 over 2 times 7, or 14. So however you do it, 5/14 is going to be your answer. Okay, for the last problem, we have negative 156 over 78. So I'm going to write negative 1 times, and then what's the prime factorization for 156? So 156, well, 56 is divisible by 4, so I know 156 is. 4 goes into 15 3 times. 3 times 4 is 12. Subtracting, get 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. Subtracting, get 0. So 39 times 4. 4 is 2 times 2. 2 is prime. 39 is 13 times 3. 13 and 3 are both prime numbers. So I'm going to write negative 1 times 13 times 3 times 2 times 2. Now what about 78? What about 78? I know it's divisible by 2, so let's start there. 2 goes into 7 3 times. 3 times 2 is 6. Subtracting, get 1. Bring down the 8. 2 goes into 18 9 times. 9 times 2 is 18. Subtracting, get 0. So 39 times 2. So we know that 39 is 13 times 3. 13 times 3, and then times 2. So now we're going to cancel this 13 with this 13, this 3 with this 3, and this 2 with this 2. So the denominator canceled completely, so we're going to write it as a 1. And then for the numerator, we have negative 1 times 2. That's negative 2. So negative 2 over 1, anything over 1 is just itself. So we just write the answer as negative 2. And again, if you would have realized that the greatest common divisor between 156 and 78 was 78, you could have saved yourself a little bit of time. You just said, okay, what is negative 156 divided by 78? Okay, that's negative 2. Then what is 78 divided by 78? Well, that's 1. So I'd have negative 2 over 1, or just negative 2 as my answer. Hello and welcome to Pre-Algebra Test Section 1 on simplifying fractions. So we just want to reduce each fraction to its lowest terms. And we're going to start out with 39 over 45. So what we're going to do is factor the numerator and denominator completely, and then cancel common factors between the numerator and denominator. So 39, I know, is 13 times 3. For 45, I know it's 15 times 3. And 15 I know is 5 times 3. So basically I would have 5 times 3 times 3. All right, 5 times 3 is 15. 15 times 3 is 45. Now that I've factored my numerator and denominator completely, I'm going to cancel common factors between the numerator and denominator. And we're only going to be able to cancel one factor of 3 between the numerator and denominator. So our numerator will be 13. Right, that's all that's left. And our denominator will be 5 times 3, or 15. So 39 over 45 is the same as, or is equal to, 13 over 15, or 13/15. What about 32 over 144? So 32, we should know at this point is 5 factors of 2. So 2 times 2 times 2 times 2 times 2. What about 144? Well, I know it's 12 times 12, and I know 12 is 4 times 3. Think about 4 times 3 times 4 times 3. So 4 is 2 times 2. So 2 times 2 times 3 times 2 times 2 times 3. So what can we cancel here? This factor 2 with this factor 2. This factor 2 with this factor 2. This factor 2 with this factor 2. This factor 2 with this factor of 2. So in the numerator, I just have a 2 left. In the denominator, we have 3 times 3, or 9. So we end up with 2/9 as our answer. So the next one's pretty easy. we have 105 over negative 105. So recall that anytime you have a non-zero number over itself, it's just 1. Here we have a non-zero number, 105, over the negative of itself. So 105 over negative 105, when you have a non-zero number over the negative of itself, the result is negative 1. And to see this, let's just write this as 105 over negative 1 times 105, and then cancel 105 with 105. Remember, if you cancel out your numerator completely, you put a 1 there. So this will become 1 over negative 1, and 1 divided by negative 1 is negative 1. Hello and welcome to Pre-Algebra Test Section 2 on simplifying fractions. All right, so we just want to reduce each fraction to its lowest terms. And we're going to look at 77 over 126 to start. So the first thing we're going to do is factor the numerator and denominator completely. So 77 I know is 7 times 11. What about 126? Well, I know that's divisible by 2 because it's an even number. So let's just start with that. 2 goes into 12 6 times. 6 times 2 is 12. Subtract and get 0. Bring down the 6. 2 goes into 6 3 times. 3 times 2 is 6. Subtract and get 0. So 63 times 2. 63 times 2. So I know 63 is 7 times 9. So 7 times 9 is 3 times 3. And then times 2. Now let's look for common factors between the numerator and denominator that we can cancel. We can cancel this 7 with this 7 and nothing else. So my numerator will be 11. My denominator will be 3 times 3 or 9 times 2, which is 18. So we end up with 11/18 as our answer. All right, let's look at negative 361 over 152. So when we have a negative number involved, we'll write negative 1 times and then the prime factorization for the number. So 361. I don't know if that number is prime or not. So if I punch up square root of 361 in a calculator, I actually get 19. So that tells me it's not prime because it's 19 times 19. So 19 is a prime number, so I put negative 1 times 19 times 19. Now for 152, I know that it's even, so it's at least divisible by 2. I know that 52 is divisible by 4, so I know 152 is divisible by 4. So let's start out with dividing 152 by 4 and see what we get. 4 goes into 15 3 times. 3 times 4 is 12. Subtract and we get 3. Bring down the 2. 4 goes into 32 8 times. 8 times 4 is 32. Subtract and get 0. So 38 times 4. 38 times 4. 152 is 38 times 4. 4 is 2 times 2. Those are both prime. We're going to circle them. Now 38 is 19 times 2. 19 is prime and so is 2. So our prime factorization would be 2 times 2 times 2 times 19. Now, I can cancel this factor of 19 with this factor of 19. And I'm going to be left with negative 1 times 19 or negative 19 over 2 times 2 times 2 or 8. So I get negative 19/8. All right, what about 80 over 130? So 80 over 130. Well, 80 I know is 8 times 10. And 8 is 2 times 2 times 2. And then 10 is 5 times 2. So I'm going to put times 2 times 5. What about 130? Well, I know it's 13 times 10. Right? So 13 times 5 times 2. So essentially the greatest common divisor between 80 and 130 is 10. So again, if I realize that to start, I can just say, okay, 80 divided by 10 is 8. 130 divided by 10 is 13. And I would have my answer that quick. But again, doing it this way, we cancel 1 factor 2 in the numerator with 1 factor 2 in the denominator, 1 factor 5 in the numerator with 1 factor 5 in the denominator, and we have our answer. 2 times 2 times 2 are 8 over 13. And again, we get 8/13. Hello and welcome to Pre-Algebra Test Section 3 on simplifying fractions. So we just want to reduce each fraction to its lowest terms. And we're going to start out with 119 over 49. So the first thing we always want to do is factor the numerator and denominator completely. I know that 49 is 7 times 7. 119 I don't work with that often. So it might be a prime number, it might not be. If I take the square root of 119, I get about 10.90. So the next highest whole number would be 11. So let's check for divisibility by all the prime numbers up to and including 11. So I'm going to check 2, 3, 5, 7, and then 11. So it's not even, so it's not divisible by 2. 1 plus 1 is 2, 2 plus 9 is 11, not divisible by 3. Final digit's not a 0 or 5, so not divisible by 5. Let's check 7. So I would cut the 9 off, and I would double it. 9 times 2 is 18. So essentially I would have 11 minus 18. Now that's going to give me negative 7. Now negative 7 is divisible by 7, right? Negative 7 divided by 7 is negative 1, no remainder. So that tells me this number is divisible by 7. So 119 divided by 7. 7 goes into 11 once. 1 times 7 is 7. Subtracting, get 4. Bring down the 9. 7 goes into 49 7 times. 7 times 7 is 49. Subtracting, get 0. So 17, which is a prime number, times 7 gives me 119. Now what we want to do is cancel the common factors between the numerator and denominator. So I can cancel this 7 with this 7. And what's left is a 17 in the numerator over a 7 in the denominator, or 17 sevenths. All right, what about 9 over negative 57? So again, factor the numerator and denominator completely. 9 I know is 3 times 3. Negative 57, when we have a negative number, just write negative 1 and then factor 57. Now 57 is going to be 19 times 3. 19 times 3. And we can cancel now a common factor of 3 between numerator and denominator. And we end up with a 3 in the numerator over a negative 1 times 19, or negative 19 in the denominator. When you have a negative number in the denominator, you can switch it up and write a negative in the numerator and a positive in the denominator. So I could also write negative 3 over 19, or I could just write the negative out in front and put 3 over 19. These are all the same. Positive divided by negative is negative. Negative divided by positive is negative. And just putting a negative out here, it's all the same. So you get negative 3 over 19, or negative 3/19 as your answer. All right, for the last one, we have 45 over negative 100. So I know 45 is 5 times 9, and 9 is 3 times 3. For negative 100, I'm going to put negative 1 times 100. I can do 10 times 10, and I know 10 is 5 times 2. So basically 5 times 5 times 2 times 2. And I can cancel a factor of 5 in the numerator with a factor of 5 in the denominator, and that's all I can do. So I'm going to end up with 3 times 3, or 9 in my numerator, over negative 1 times 5 times 2 times 2 in the denominator. 5 times 2 is 10, 10 times 2 is 20, then times negative 1 is negative 20. And again, I can write this as negative 9 over 20, or I could also write this as negative 9/20. All of these are the same. Again, positive divided by negative is negative. Negative divided by positive is negative, or negative out in front. You're all just signaling that the number is negative. So negative 9/20 is our answer. Hello and welcome to Pre-Algebra Test Section 4 on simplifying fractions. So we want to just reduce each fraction to its lowest terms. So we're going to begin with 154 over 209. And the first thing we want to do is factor the numerator and denominator completely. So for 154, I don't know the prime factorization of that number off the top of my head. I'm just going to use a little factor tree to help myself out. I know it's divisible by 2. So what is 154 divided by 2? 2 goes into 15 7 times. 7 times 2 is 14. Subtracting, get 1. Bring down the 4. 2 goes into 14 7 times. 7 times 2 is 14. Subtracting, get 0. So 2 times 77. Now 2 is prime, so I'm going to circle that. And 77 I know is 7 times 11. So I'm going to circle 7 and circle 11. So my prime factorization for 154 is 2 times 7 times 11. What about 209? I don't work with that number very often. One thing I'm going to tell you is when you get a problem like this on your homework or on a test, look at this number. We know it's not even, so it's not divisible by 2. If it's going to be able to be simplified, it has to be divisible by a 7 or an 11. So just check those two numbers. So is 209 divisible by 7? Cut off the final digit of the number. So you'd have a 20, cut off the 9, and double it. If I double 9, I get 18. If I subtract that away, I get 2. So it's not going to be divisible by 7. Is it divisible by 11? So again, you number the digits. So you have 2, 0, 9. This is 1, this is 2, and this is 3. So form the sum of the digits in the odd positions. So we have 2, which is in the first position, plus 9, which is in the third position, so that's 11. We're subtracting away the sum of the digits from the even positions. I just have a 0 that's in an even position, and that position is in the second position of the number. So I'm subtracting away a 0. 11 minus 0 is 11. So because this is an 11, and 11 is divisible by 11, we know that 209 is divisible by 11. So let's do that. So 209 divided by 11. 11 goes into 20 once. 1 times 11 is 11. Subtracting, get 9. Bring down the 9. 11 goes into 99 9 times. 9 times 11 is 99. Subtracting, get 0. So we'd have 11 times 19. Both numbers are prime. So now we see we can cancel a factor of 11 in the numerator with a factor of 11 in the denominator. And we end up with 2 times 7, or 14, over 19. So 14/19 is your simplified version of this fraction, 154 over 209. So what about 13 over 19? So occasionally we're going to get problems that we can't simplify. So 13 is a prime number, and so is 19. So there's really nothing I can do because the greatest common factor, or the greatest common divisor of 13 and 19 is 1. So that tells me that there's nothing I can really do to simplify this fraction. What about 80 over 32? 80 over 32. Well, I can factor 80. I know that it's 16 times 5, and 16 is 4 factors of 2. And 32 I know is 5 factors of 2. But once you get good at this, you're going to know that the greatest common divisor of 80 and 32 is 16. And if you realize that, I could just divide 80 by 16 and get 5, and divide 32 by 16 and get 2, and realize I'm going to have 5 halves. So when we look at it this way, we're just going through and canceling things. We're saying, okay, this 2 cancels with this 2, this 2 cancels with this 2, this 2 cancels with this 2, and this 2 cancels with this 2. But essentially I have canceled a factor of 16 from the numerator with a factor of 16 from the denominator, which is the same as if I just said, what is 80 divided by 16? Right? It's going to be 5, which is what's left there. What is 32 divided by 16? Well, it's going to be 2, what's left there. So either way you do it, you end up with 5 halves as your answer. Hello and welcome to Pre-Algebra Test Section 5 on simplifying fractions. All right, so we just want to reduce each fraction to its lowest terms. So we're going to begin with negative 220 over 176. So the first thing we want to do is factor the numerator and denominator completely. And I have negative 220, so I'm just going to write negative 1 times the prime factorization of 220. Now I see that 220 ends in a 0, so I know it's 22 times 10. 22 is 11 times 2, and 10 is 5 times 2. What about 176? Well, I know that 76 is divisible by 4, so I know that 176 would be divisible by 4. So let's start out by doing that. 4 goes into 17 4 times. 4 times 4 is 16. Subtract them, we get 1. Bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. Subtract and get 0. So 44 times 4. 44 times 4. So 4 is 2 times 2. 44 is 11 times 4. 4 is 2 times 2 again. So now I'm looking for common factors between numerator and denominator that I can cancel. I can cancel this 11 with this 11. I can cancel this 2 with this 2. And I can cancel this 2 with this 2. So what I have left is negative 1 times 5, or negative 5 in the numerator. In the denominator, I have 2 times 2, or 4. So this ends up being negative 5/4 for my answer. What about 84 over 96? Well, what is 84? I know that it's divisible by 4, so let's start with that. 4 goes in 8 twice. 2 times 4 is 8. Subtract that, get 0. Bring down the 4. 4 goes into 4 once. 1 times 4 is 4. Subtract and get 0. So 21 times 4. 4 is 2 times 2. And 21 is 7 times 3. What about 96? Well, I know that's also divisible by 4, so let's start with that. 4 goes into 9 twice. 2 times 4 is 8. Subtract and get 1. Bring down the 6. 4 goes into 16 4 times. 4 times 4 is 16. Subtract and get 0. So 24 times 4. So 4 is 2 times 2. 24 is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. So now let's look to see what we can cancel between the numerator and denominator. So I can cancel this 2 with this 2, this 2 with this 2, and this 3 with this 3. So we'll end up with 7 in the numerator over 2 times 2 times 2, or 8 in the denominator. So we get 7/8 as our answer. Okay, final problem. We have negative 28 over 119. So again, if I have a negative involved, I'm just going to write negative 1 times the prime factorization of that number. 28 is pretty easy. It's 7 times 4, and 4 is 2 times 2. So times 7 times 2 times 2. But what about 119? This is a number that we don't work with very often. So if you get this problem on your homework or your test, check to see if the 119 is divisible by 7. If it's not, you can't simplify this fraction. We know it's not divisible by 2. It's not an even number. So what is 119 divided by 7? 7 goes into 11 once. 1 times 7 is 7. Subtraction, you get 4. Bring down the 9. 7 goes into 49 7 times. 7 times 7 is 49. Subtracting, get 0. So 17 times 7. And again, if 119 wasn't divisible by 7, you would stop. The fraction would not be able to be simplified. So in this case, it is, because we have 17 times 7. So we're going to cancel this 7 with this 7, and then we're done. So we end up with negative 1 times 2 times 2, or negative 4 for the numerator, over 17 for the denominator. So we get negative 4/17 as our answer. Hello and welcome to Pre-Algebra Practice Set number 30. In this video, we're going to look at some additional practice problems for our lesson on multiplying fractions. All right, so we want to find each product. We're starting out with 5/6 times 8. So when we multiply a fraction by a whole number or by an integer, we can make it kind of mentally easier for us by just writing that whole number or that integer over the number 1. 8 over 1 is still 8. Whenever you divide a number by 1, it always remains unchanged. So now we can go through and multiply. And before we do that, we want to see if we can cross-cancel anything. So I know that between 5 and 1, there's nothing I can cancel. Between 8 and 6, both have a common factor of 2. So in other words, I can think about 8 as 4 times 2, and I can think about 6 as 3 times 2, and I can cancel this 2 with this 2, and what I'm left with is 5 times 4, or 20, for my numerator, over 3 times 1, right? 3 times 1, or 3, for my denominator. So the result is going to be 20/3, or you could say 20 over 3. What about 1/9 times 10/17? Again, I'm going to start out by looking to cross-cancel. Can I cancel anything between 9 and 10? No, I cannot. 9 is 3 times 3. 10 is 5 times 2. Can I cancel anything between 1 and 17? No, I cannot. So all I need to do in this case is just multiply the numerator by the numerator. So 1 times 10 is 10. And place that over the denominator times the denominator. What is 9 times 17? So 17 times 9. 9 times 7 is 63. 9 times 1 is 9, plus 6 is 15. So we would get 10 over 153 as our answer. What about 10 times negative 3/2? Well, again, if you have a whole number hanging out there, you can write it over 1 to make it mentally easier to multiply these fractions. Now, is there anything I can cross-cancel here? Well, yeah, if I look, I can see that 10 and 2 are going to have some factors in common. So 10 is 5 times 2, so I could do this and say, okay, this is 5 times 2, and I could cancel this 2 with this 2. Or kind of a quicker way to do this, just think about, okay, I know that 10 divided by 2 would be 5. So I can just cross this out and put a 5, cross this out and put a 1, right? Divide each of those by the number 2. Again, 10 divided by 2 is 5, 2 divided by 2 is 1. That's really all you need to do. Now, there's nothing else I can cancel here, so I just do my multiplication. 5, which is what's left in the numerator, times negative 3 is negative 15. I have a 1 here and a 1 here after my result of canceling. So 1 times 1 is 1. So I get negative 15 over 1, or just negative 15. All right, what about negative 9/8 times 7/18? So what we want to look to do is see if we can cross-cancel anything first. So I know I can't cancel anything between 8 and 7. 8 is 3 factors of 2. 7 is a prime number. But between negative 9 and 18, I can do some canceling. Forget about the negative for now. Just think about this as negative 1 times 9. I know that 18 divided by 9 is 2. So 18 divided by 9 is 2. 9 divided by 9 is 1. So essentially I would just have negative 1 here times 7. So that's negative 7. And down here I'd have 8 times 2. And that's 16. So my result would be negative 7/16. What about negative 15 times 17/20? So I can write negative 15 as negative 15 over 1, and then see what I can cross cancel. I can't do anything between 1 and 17, but I can cancel between negative 15 and 20. Again, just forget about that negative for a minute. Just say negative 1 times 15. I know that 15 is 5 times 3, and I know 20 is 5 times 4. So here's where we're really going to speed some stuff up. If I divide 20 by 5, I get 4. If I divide 15 by 5, I get 3. So now I have negative 1 times 3, that's negative 3, times 17. So what is negative 3 times 17? We know that's negative, and then 17 times 3. 3 times 7 is 21. 3 times 1 is 3, plus 2 is 5. So that's negative 51 for my numerator. My denominator, I have 1 times 4, so that's just 4. So we get negative 51 fourths as our answer. All right, let's take a look at 19/6 times 3/38 times 2/5. So immediately I'm looking to see what I can cross cancel. And I can see that 6 divided by 3 would be 2. So essentially, again, 6 divided by 3 is 2. 3 divided by 3 is 1. Then I know that 38 divided by 19 would be 2. So 38 divided by 19 is 2. 19 divided by 19 is 1. Then I can cancel this 2 with this 2. And my numerator now will just be a 1. Right? I have 1 times 1 times 1. And that's 1. For my denominator, I have 2 times 1 times 5, or 10. So this ends up being 1/10 as my answer. All right, let's take a look at 7/10 times 5/2 times negative 4 times 3/49. So again, if it makes you feel more comfortable, you can write this negative 4 over 1. And we can just look to see what we can cross cancel. So at this point, I can see that I can cancel this 10 with this 5, right? 10 divided by 5 is 2. So the result here, this 10 would be canceled and become a 2. This 5 would be canceled and become a 1, right? Again, 10 divided by 5 is 2. 5 divided by 5 is 1. Again, if it makes you feel more comfortable, you can write these out and say, okay, this is 5 times 2. Cancel this 5 with this 5, put a 1 here, and that's a 2. But I just think it's a little faster if you realize that 10 divided by 5 is 2. So this is going to go away, and this is going to become a 2. All right, the next thing we look at is, I know that 49 divided by 7 is 7. So this would become 7. Right? If I divide 49 by 7, I get 7. And this would be 1. If I divide 7 by 7, I get 1. Now continuing, I have this negative 4 here. And what I'm going to do is I'm going to write this as negative 1 times 4. Cross that out. And I can see that I have a 2 and another 2. 2 times 2 is 4. So I can cancel this 2 and this 2 with this 4. Right? 2 times 2 again is 4. It's the same thing as if I had a 4 hanging out there and I just canceled it with that 4. So both of these are just going to be a 1. So I have 1 times 1 times 1 times 7 in the denominator. That's just going to be 7. In the numerator, I'm going to have 1 times negative 1 times 3. So that's just going to be negative 3. And up with negative 3 over 7. Or again, you can write this as negative 3/7 like this. Or you can even write 3 over negative 7. Whatever you want to do. Again, positive divided by negative or negative divided by positive is a negative. All right, let's take a look at 1 over 42 times 7/9 times negative 3 times 2/5 times negative 2/7. So I can write this negative 3 as negative 3 over 1. And then we can look to see what we can cross cancel here. So I know 42 divided by 7 is 6. So 42 divided by 7 is 6. 7 divided by 7 is 1. Again, just canceling a common factor of 7. I know that 9 divided by 3 is 3. I know this is negative 3, but I'm just going to forget about this for a second and say 9 divided by 3 is 3. 3 divided by 3 is 1. So this is just going to be negative 1 as a result up there. Then what do I have left? I have this 2 and I have this negative 2. Now 6 divided by 2 is 3. So I can cancel this out, put a 1, and cancel this out and put a 3. Right? Again, 6 divided by 2 would be 3. 2 divided by 2 would be 1. So that's all I can cancel. In my numerator, so we'd have 1 times 1 times negative 1 times 1. That's negative 1. Times negative 2. That's going to be positive 2. Over. We have 3 times 3 or 9. Times 1, which is still 9. Times 5, which is 45. Times 7. 7 times 5 is 35. 7 times 4 is 28. Plus 3 is 31. So that's 315. So our answer here is going to be 2 over 315. So let's take a look at a word problem to kind of wrap up our practice set. So Brandy works on a team that must write 1/4 of the 28 pages in a report. how many pages does the team need to write? Well, basically all we need to do is multiply 1/4 times 28. All right, so what is 28 times 1/4? And again, if it makes you feel more comfortable, write it as 28 over 1. I can cross cancel between the 28 and the 4. 28 divided by 4 is 7. So cancel this, it'll become a 7. Cancel this, it'll become a 1. And basically you get 7 times 1, which is 7, over 1 times 1, which is 1. So the answer here is just 7. So to kind of formally answer this, when you get a word problem, you want to kind of answer it in words, you would say that her team is responsible for 7 pages of the report. Hello and welcome to Pre-Algebra Test Section 1 on multiplying fractions. So we just want to find each product. And we start out with 47 over 20 times 8 over 21. So when we multiply fractions, we want to start out by just looking to see if we can cross cancel anything. So when I look at 47, that's a prime number, so I can't really cancel it with 21, right? 21 is 7 times 3. 7 times 3. When I look at 20, I can think about that as 4 times 5, and think about 8 as 4 times 2. And what I can do is I can cancel a common factor of 4 between 8 and 20. So what I'd be left with is a numerator that's 47 times 2, or 94, over a denominator that's going to be 5 times 7 times 3. So 5 times 7 is 35. 35 times 3 is 105. So our answer here is going to be 94 over 105. For the next one, we look at 35 over 34 times negative 27 over 37. So what can we cross cancel here? Well, if I look at 34, it's 17 times 2. If I look at 35, it's 5 times 7. If I look at negative 27, you can think about this as negative 1 times 3 times 3 times 3. And 37 is a prime number. So if I look between 34 and negative 27, no factors that are in common. If I look between 35 and 37, obviously there's nothing in common because 37 is a prime number. So we just go ahead and do the multiplication. So we know the result's going to be negative here in the numerator. And we would do 35 times 27. 7 times 5 is 35. 7 times 3 is 21, plus 3 is 24. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. So this is a 5, and we bring this down. 4 plus 0 is 4. 2 plus 7 is 9. So we get negative 945 for our numerator. For the denominator, we multiply 34 by 37. 7 times 4 is 28. 7 times 3 is 21, plus 2 is 23. 3 times 4 is 12. 3 times 3 is 9, plus 1 is 10. So bring down the 8. 3 plus 2 is 5. 2 plus 0 is 2. Bring down the 1. We get 1,258 there. So the answer would be negative 945 over 1,258. Okay, for the last one, we have 16 over 25 times 15 over 46. So there are some things we can cross cancel here. I know that 25 is 5 times 5, and I know 15 is 5 times 3. So if you think about the greatest common divisor, or the greatest common factor, for 25 and 15, it's 5. So just divide each number by 5. 25 divided by 5 is 5. 15 divided by 5 is 3. Another way you could have done that is just think about you're removing a factor of 5. So if 25 is 5 times 5, if I cancel one of the 5s, I'm left with 5. 15 is 5 times 3, so if I cancel a 5, I'm left with a 3. Now, what about 16 and 46? I know that 16 is 4 factors of 2, and 46 is 23 times 2. So the greatest common divisor between these two numbers is going to be 2. So just divide each number by 2. 46 divided by 2 would be 23. 16 divided by 2 would be 8. And that's all we can do. Now we multiply numerator by numerator. 8 times 3 is 24. And we put the result over denominator times denominator. 5 times 23. 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11. So we get 24 over 115 as our answer. Hello and welcome to Pre-Algebra Test Section 2 on multiplying fractions. All right, so we just want to find each product. We're going to start out with 50 over 21 times negative 49 over 25. So the first thing we're doing when we're multiplying fractions is we're looking to cross cancel. Remember, we want to report our answer as a simplified fraction or as a fraction that's reduced to its lowest terms. So if I look between 50 and 25, I know that 50 divided by 25 is 2. So divide 50 by 25, you get 2. Divide 25 by 25, you get 1. So I'm just canceling a common factor of 25, or 2 factors of 5, between those two numbers. Now if I look at 21 and negative 49, I know that each number there is divisible by 7. So if I divide 21 by 7, I would get 3. If I divide negative 49 by 7, I would get negative 7. And now I'm done. There's nothing else I can cancel, so I just multiply numerator by numerator. 2 times negative 7 is negative 14. And I multiply denominator times denominator. 3 times 1 is 3. So I end up with negative 14 thirds, or just negative 14 over 3. What about 35 thirteenths times 39 over 56? Well, again, we're looking to cross cancel before we begin. If I look at 35, it's 5 times 7, and 56 is 8 times 7. Right? I know it's 2 times 2 times 2 times 7, but since this isn't divisible by 2, why bother breaking that 8 down further? Right? You want to do some things that kind of speed up your process. Now I can see I can cancel a common factor of 7 between 35 and 56. So just think about dividing 35 by 7, you would get 5. Right? You'd get 5, right? This would go away. Think about dividing 56 by 7, you would get 8, right? That would go away. What about between 39 and 13? Well, 39 divided by 13 is 3. So this would be a 3, and this would be a 1. Now I would have a 5 over here times a 3 over here, that's 15. And then a 1 over here times an 8 over here, that's 8. So we end up with 15 eighths as our answer. All right, let's take a look at 12 seventeenths times 1 18th times 34 over 35. Now when we look to cross cancel, the only thing that I can see right away is that 17 and 34 can be canceled. The result would be a 2 up here, right? Because 34 divided by 17 is 2. Since this is gone, now I just need to think about 18. That is going to be 6 times 3. 6 times 3, and 6 is 3 times 2. So 3 times 3 times 2. 12 I know I can write as 3 times 4, or 3 times 2 times 2. Now I can do some canceling between these two. I can basically cancel a factor of 6. Cancel a factor of 6, or 3 times 2. So I'm left with a 2 here and a 3 here. Now this is a 1, and this is 35, so that's 5 times 7. I really can't do anything with that 35, so I'm not even going to factor it. So now I'm just going to look to multiply. 2 times 1 times 2 is 4. Over, this is a 1, this is a 3. 1 times 3 is 3. Then times 35 would be 105. So our answer here is going to be 4 over 105. Hello and welcome to Pre-Algebra Test Section 3 on multiplying fractions. So we just want to find each product. And we're going to start out with negative 9 times 1/8 times 4 thirds times 12 thirteenths. So again, if you have an integer or a whole number and you're multiplying by fractions, just go ahead and write it over the number 1. Remember, negative 9 divided by 1 is still negative 9. You have not changed the value of the number. You're just making it mentally easier to deal with these fractions. Now before we multiply, we want to go through and see what we can cross cancel. So when I start out, I can immediately see that I can remove a common factor of 4 between the 8 in the denominator here and the 4 in the numerator here. So 8 divided by 4 would be 2, 4 divided by 4 would be 1. Now next I can see that I can remove a common factor of 3 between this 12 and this 3. 12 divided by 3 would be 4, 3 divided by 3 would be 1. And then looking, I see that I have a 4 here and a 2 here. So 4 divided by 2 would be 2. So I can further cancel this guy, further cancel this to make this a 2. This would cancel and become a 1. So now my denominators are a 1, a 1, a 1, and a 13. And then up here I have for numerators a negative 9, a 1, a 1, and a 2. So I can't cancel anything else. So now I just multiply all the numerators together. Negative 9 times 1 is negative 9. Then times 2 is negative 18. Put that over the product of the denominators. So we have 1 times 1 times 1 times 13, or just 13. So we're going to get negative 18 over 13 as our answer. All right, for the last problem, we have -1/4 times 5/9 times 8/15 times -6/25. So just looking to see what we can cross cancel, I see again that I have 4 and 8. I know that 8 divided by 4 is 2, so that one's an easy one. 8 divided by 4 is 2. That's what I'm going to have up here if I remove a factor of 4. 4 divided by 4 is 1. If I remove a factor of 4, just think about this as 4 times 1. Remove that factor of 4, you just have a 1 left. All right, next I'm going to look at, I have 5 and I have 25. 25 divided by 5 is 5. So 5 divided by 5 is 1. 25 divided by 5 is 5. And what else do we have here? I have a 15 and I have a -6. So I could write 15 as 5 times 3. And I could write -6 as -1 times 2 times 3. And I can go ahead and cancel this 3 with this 3. And I'll just be left with a 5 here and then a -1 times 2 up there. Anything else we can cancel? This is 9. This is 3 times 3. No more 3's up here. This is a 5. No more 5's up here. And then this is a 5. No more 5's up here. So nothing else we can really cancel. So the numerator will have -1 times 1 times 2. That's going to give me -2 times -1, which is going to be +2, then times 2, which is going to be 4. For the denominator, I've got 1 times 3 times 3. So that's 9 times 5. That's 45 times 5. 5 times 5 is 25. 5 times 4 is 20, plus 2 is 22. So we're going to get 225 as our result there. And our answer is 4/225. Hello and welcome to Pre-Algebra Test Section 4 on multiplying fractions. Okay, so we just want to find each product. For the first problem, we have 23/37 times 49/46 times -111/7 times 3/14. So again, before we go through and multiply numerators and put the result over the product of the denominators, we want to look to see what we can cross cancel. Remember, when we report our answer, it needs to be simplified. So if I look, immediately I see that I have 23 in the numerator here and 46 in the denominator here. So 46 divided by 23 is 2. So if I divide each one by 23, this will become 2, this will become 1. Right? I'm just canceling a common factor of 23 between numerator and denominator. Next, I see that 49 divided by 7 would give me 7. Right? If I remove a factor of 7 between the numerator here, the denominator here, this would be 7, right? 49 divided by 7 is 7, and this would be 1. 7 divided by 7 is 1. Now I also see that I have a 14 here and a 7 here. So I can further cancel this. 7 divided by 7 is 1. 14 divided by 7 is 2. All right, so what do we have left in the numerator? We have a 1, a 1, a -111, and a 3. In the denominator, I have a 37, which is prime, a 2, a 1, and a 2. Can't do anything with this 3, but if I look at -111, I might be able to cancel with 37 if it's divisible by 37. I know it's divisible by 3 because the sum of its digits, 1 plus 1 plus 1, is 3. So what is 111 divided by 3? 3 goes into 11 3 times. 3 times 3 is 9. Subtract and get 2. Bring down the 1. And 3 goes into 21 7 times. 7 times 3 is 21. Subtract and get 0. So since this is 3 times 37, and I know it's negative, so let's just put -1 times 3 times 37, we can cancel with this 37 over here. So I can cancel this 37 with this 37, and essentially all I'm left with now is 1 times 1 times -1 times 3 times 3. So 3 times 3 is 9, then times -1 would be -9, so you'd have -9 here, over. In the denominators, you've got 1 times 2, that's 2, times 1, that's still 2, times 2 again, that's 4. So we'll end up with -9/4 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on multiplying fractions. All right, so we just want to solve each word problem. So Ralph invited 15 people to his party. 2/3 of the people invited attended the party. How many people came to the event? So to find out the answer to this question, we simply need to multiply 15, the number of people he invited to his party, by 2/3, and this is the fractional amount of people that were invited that actually showed up. So 15 times 2/3. Let's put this as 15 over 1. We can cross cancel here. 15 divided by 3 is 5. Right? 15 divided by 3 is 5. 3 divided by 3 is 1. So essentially I have 5 times 2, which is 10, over 1, which just equals 10. Now when we have a word problem, we want to give a nice little sentence as our answer. So how many people came to the event? 10 people. 10 people came to Ralph's party. Let's take a look at another one. Jacob has $63 in his checking account. He visits a local store and spends 1/9 of that money on food. How much is left in Jacob's checking account after his trip to the store? So the first thing we're told is that Jacob has $63 in his checking account. So let's highlight that. So this is kind of where he's going to start out at. So Jacob starts with $63. Now, we need to find out how much he spends at the store so we can subtract it away and find out how much he has in his checking account after his trip to the store. So he spends 1/9 of that money on food. So what is 1/9 of 63? We'd multiply to figure that out. So 63 times 1/9. And again, we could write this as 63 over 1. You can see that 63 divided by 9 is 7. Right? So I would cancel this with this, and I'd have 7 over 1 there. Right? 63 divided by 9 is 7. 9 divided by 9 is 1. So I'd have 7 times 1, or 7, over 1 times 1, or 1. So some of you would give the incorrect answer and say that he has $7 left. That's wrong. He spent $7 at the store. So Jacob spends $7. If we go back and reread the problem, you'll see that that's completely clear. Jacob has $63 in his checking account. He visits a local store and spends 1/9 of that money on food. So he spent $7 on food. Now, how much is left in Jacob's checking account after his trip to the store? We just need to take and subtract 7 away from 63. So 63 minus 7. We'd borrow here. 13 minus 7 is 6. Bring down the 5. He's going to have $56. So Jacob will have $56 in his checking account after his trip to the store. Hello and welcome to Pre-Algebra Practice Set number 31. In this video, we're going to look at some additional practice problems for our lesson on dividing fractions. So we're going to start out, we want to find each reciprocal. So we have 1/9. So to find the reciprocal, we just interchange the numerator and denominator. So we take the 9 that's in the denominator, bring it up to the numerator. We take the 1 in the numerator, bring it down to the denominator. And again, the way you check this, a number times its reciprocal is always 1. So if you take 1/9 and you multiply it by 9 over 1, and the result is 1, you have found the reciprocal. So we can cross cancel this 9 with this 9, and we'd have 1 over 1 times 1 over 1, which in fact would give us 1 as our answer. All right, what about 8/7? 8/7. Again, take the 7 from the denominator, bring it up to the numerator. Then take the 8 from the numerator, bring it down to the denominator. So the reciprocal of 8/7 is 7/8. What about the number 13? Well, whenever you work with a whole number or an integer, you're simply going to take that number and write it over 1. Now, once you've done that, you basically took the same number and made it into a fraction. 13 over 1 is still 13. Dividing by 1 leaves the number unchanged. But now I can take the denominator and bring it into the numerator, and I can take the numerator and bring it down to the denominator, and so the reciprocal of 13 is 1/13. What about 12/17? Again, you're just going to interchange the numerator with the denominator. So the 12 is going to come down to the denominator, and the 17 is going to go up to the numerator. So the reciprocal of 12/17 is 17/12. What about -5/3? Again, if you have a negative involved, you can just drag it down. So in this case, it's in the numerator. You can just drag it down to the denominator and then drag 3 up to the numerator. Or it's also correct if you say that the reciprocal is -3/5. It really doesn't matter because when you think about negatives, a negative divided by a positive, like in this case, is still a negative. In this case, a positive divided by a negative is also just a negative. At the end of the day, we have a -3/5 for this fraction here. That's our reciprocal. What about -2/5? Again, take this 5, bring it up to the numerator. Take this -2, and we'll bring that down to the denominator. And we'll end up with -5/2, or as I have it written here, 5 over -2. Again, when you're dividing a positive by a negative, you get a negative. So that's why I said -5/2 is your answer. Okay, then we have 11 over -12. So again, bring this up here. So I'll have -12. Bring this down here. I'll have 11. So -12 over 11, or -12/11 is your reciprocal. Okay, now we have 5. So when we have a whole number, we're just going to write it over 1. Bring this into the numerator. Bring this down to the denominator. And the reciprocal of 5 is 1/5. For the last problem, we have -1. Again, just write it over 1. Bring this into the numerator. Bring this down into the denominator. And the reciprocal of -1 is 1 over -1, which is still -1. You might say, okay, well, that's not the reciprocal of -1. Well, yes, it is. By definition, a number times its reciprocal will give you 1. So if I have -1 times -1, I do in fact get the number 1. Okay, let's practice some actual division problems. So we just want to divide. We're going to start out with 1/5 divided by 10/11. So to divide fractions, we take the first fraction, or the leftmost fraction, and we leave that guy unchanged. So we're going to have 1/5 there. Then we're going to multiply by the reciprocal of the second fraction, or the fraction on the right. So the reciprocal of 10/11 is 11/10. And when we multiply, we just look to cross cancel first. Nothing we can really cancel here, so we just do our multiplication. 1 times 11 is 11. 5 times 10 is 50. So we end up with 11 over 50 as our answer. Now, if you're unsure, remember, you can always check your division using multiplication. If you have something like 4 divided by 2 and you get 2, you can work backwards and say, okay, well, that means that 2 times 2 equals 4. So the same is true here. If we take 11 over 50 and we multiply it by the divisor, we should get 1/5, right? Our dividend back. Cross cancel the 50 and the 10. We can cross cancel this. 50 divided by 10 is 5. This would be 1. 11 cancels with 11. And so I'd end up with 1 times 1, or 1, over 5 times 1, or 5. Yeah, I do get 1/5 back. So my 11 over 50 is the correct answer. All right, what about -2/3 divided by 1/9? So we'd have -2/3. That part's going to stay unchanged. Then we're multiplying by, take the reciprocal of 1/9. That's going to be 9 over 1. Now I can do some cross canceling. I can cancel this 9 with this 3. That's going to give me a 3, right? 9 divided by 3 is 3. And then 3 divided by 3 is 1. All right, so we'd have -2 times 3, that's -6, over 1 times 1, or 1. And -6 over 1 is just -6. What about 9/13 divided by 39 over 40? So again, the leftmost fraction stays unchanged. And we multiply it by the reciprocal of 39 over 40. So that's going to be 40 over 39. And let's see, can we cross cancel anything? Well, I know I can't cancel between 13 and 40. But I can cancel between 9 and 39. 9 is 3 times 3. 39 is 13 times 3. So I can divide each of these by the greatest common divisor, which is 3. 39 divided by 3 is 13. 9 divided by 3 is 3. Now I can do my multiplication. 3 times 40 is 120. Over 13 times 13, which is 169. So we'd end up with 120 over 169 as our answer. All right, what about 6 divided by 1/2? So when we work with whole numbers or integers and fractions, we just write these whole numbers or integers over the number 1 just to make it more convenient for us. So 6 over 1 is going to stay unchanged. And I'm dividing by 1/2, so I'm going to multiply by the reciprocal of this. So I'm multiplying by 2 over 1, which is just 2. Now in this case, really I could just drop the over 1s here because we just have the multiplication problem 6 times 2. And 6 times 2 is just 12. What about -5 divided by 1/8? Well, again, I can write this as over 1. So I'd have -5 over 1 times the reciprocal of 1/8, which is 8 over 1. And again, I could drop the 1s if I want, because I know I just have negative 5 times 8, and that is negative 40. All right, let's take a look at one more problem. And you'll notice we have 3 fractions involved. When this happens, we're just going to work left to right. So in other words, we're just going to treat this as a separate problem first. Once we get this result, then we'll divide by 27 over negative 20. So again, we're going to start with 4/5 divided by 8/9. So 4/5 times reciprocal of 8/9 is 9/8. Can we cross cancel? Yes. 8 divided by 4 is 2. So this will be 2. 4 divided by 4 is 1. Can't cross cancel anymore. We basically have 1 times 9 or 9 over 5 times 2 or 10. So what we have is 9/10 divided by 27 over negative 20. So now 9/10 is going to stay unchanged, and we're going to multiply by the reciprocal of 27 over negative 20. So that's going to be negative 20 over 27. And I think about 20 and 10. I'm going to ignore this negative for right now. I think about 20 and 10. 20 divided by 10 is 2. So I'm just going to go ahead and cancel this with this. This will be 1. This will be 2. So this will be negative 2 now. And then 27 divided by 9 is 3. So this will be 3, and this will be 1. So this fraction has completely canceled itself out. It's just worth 1 now. So I'd have 1 times, I'd have negative 2/3. So the answer here is just negative 2/3. Hello and welcome to Pre-Algebra Test Section 1 on dividing fractions. So we just want to find the reciprocal. So we're going to start out with 7/4. So to find the reciprocal of a number, you interchange the numerator and the denominator. So for 7/4, I just take 4 and take it from the denominator, bring it up to the numerator. I take 7 from the numerator, bring it down to the denominator, and end up with 4/7. And again, the way you can check this, a number times its reciprocal is always 1. So 7/4 times 4/7 should be 1. And you can see that you can cancel this 7 with this 7. It would give you 1. This 4 with this 4 would give you 1. You basically have 1 times 1, which is 1. What about 2/3? Again, interchange the numerator and denominator. So the 3 is going to go up top. The 2 is going to go to the bottom. And you get 3/2. What about negative 5? Well, if you have an integer or whole number, you can just write it over 1. Remember, if I divide something by 1, it remains unchanged. Now I can take the denominator and pull it up to the numerator, and I can take the numerator and pull it down to the denominator. So my reciprocal is 1 over negative 5, or you could really think of this as just negative 1/5, right? If I have a negative down here, positive divided by negative is negative overall, so I could just say this is negative 1/5. What about 8? Well, again, write it as 8 over 1, then bring the denominator up to the numerator, and the numerator down to the denominator, and I get 1/8. What about 9/14? Take the numerator, bring it down to the denominator. Take the denominator, bring it up to the numerator. So the reciprocal here is going to be 14/9. For the final problem, we have 11/13. Again, take the denominator, bring it up to the numerator. Take the numerator, bring it down to the denominator, and we get 13/11. Hello and welcome to Pre-Algebra Test Section 2 on dividing fractions. So we just want to divide, and we're going to have 1/2 divided by 1/4 to start. So to divide fractions, I take my leftmost fraction, which in this case is 1/2, and I multiply it by the reciprocal of the rightmost fraction. In this case, that's 1/4. So the reciprocal of 1/4 is 4 over 1. Now before I multiply, I can look to cross cancel. 4 divided by 2 is 2, so this 4 would become 2, this 2 would become 1. All right, I just divided by the greatest common divisor, again, which was 2. 4 divided by 2 is 2, 2 divided by 2 is 1. So now I can multiply. 1 times 2 is 2, over 1 times 1 is 1, so we get 2 over 1, or 2, as our answer. And remember, if you want to check this, take 2 and multiply it by 1/4, and you should get 1/2. So I'll write 2 as 2 over 1 times 1/4. This 2 would cancel with this 4. I'd have a 2 down here and a 1 up here. So 1 times 1 is 1, over 1 times 2 is 2. So you do in fact get 1/2 back. What about 2/7 divided by 3? Well, for convenience, I'm going to write this as 3 over 1. And I'm going to take this first fraction, 2 over 7, and multiply it by the reciprocal of 3 over 1, which is 1/3. So now I'm just going to look to see if I can cross cancel. I I can't do anything here, and I can't do anything there, so I just multiply. 2 times 1 is 2. 7 times 3 is 21, so I end up with 2 over 21 as my answer. For the last one, we have negative 4/5 divided by 8/9. So I'm going to take negative 4/5 and multiply it by the reciprocal of 8/9, which is 9 over 8. And look to see if I can cross-cancel anything. Forget about this negative for a minute. 8 divided by 4 is 2. So if I cancel this with this, I'd have a 2 here and a 1 here. And remember, it's a negative, so that's going to be a negative 1. I can't cancel anything else, so negative 1 times 9 is negative 9. Over 5 times 2, that's 10. So I get negative 9/10 as my answer. Hello and welcome to Pre-Algebra Test Section 3 on dividing fractions. All right, so we just want to divide. We're going to start out with 9/28 divided by 12/35. So again, to divide fractions, we take the first fraction and we leave that unchanged. And when I say first fraction, I mean the leftmost fraction. So we have 9/28 there, and we're going to multiply by the reciprocal of the second fraction, meaning the fraction on the right. So the reciprocal of 12 over 35 is 35 over 12. Now I'm going to look to see if I can cross-cancel anything. I know the greatest common divisor between 9 and 12 would be 3. So if I divide each by 3, 9 divided by 3 is 3, 12 divided by 3 is 4. So basically I just removed a common factor of 3 from each. Now what about between 35 and 28? Well, the greatest common divisor is going to be 7. 28 divided by 7 would be 4. 35 divided by 7 would be 5. Nothing else I can really cancel, so now I just multiply. 3 times 5 is 15. 4 times 4 is 16. So I end up with 15 over 16 as my answer. Now remember, if you're ever unsure if you got the right answer, you can check division with multiplication. So 15 over 16 multiplied by the divisor, 12 over 35, should give me the dividend back. So it should give me 9/28 back. So between 16 and 12, the greatest common divisor is going to be a 4. So 16 divided by 4 is 4. 12 divided by 4 is 3. Between 15 and 35, the greatest common divisor is a 5. 15 divided by 5 is 3. 35 divided by 5 is 7. So if I multiply, 3 times 3 is 9. 4 times 7 is 28. And we do in fact get back to this 9 over 28. Let's look at 8/3 divided by negative 1/9. So 8/3 stays the same. And we're multiplying by the reciprocal of negative 1/9. So that's going to be 9 over negative 1. Or we could put negative 9 over 1. It doesn't really matter. So we look to cross-cancel. Cancel this 9 with this 3. 9 divided by 3 is 3. So this is going to be a 1. This is going to be a 3. All right, I just removed a factor of 3 from each of those. And then I can't cancel anything else, so I'm just going to multiply. 8 times 3 is 24. 1 times negative 1 is negative 1. So I get 24 over negative 1, or basically just negative 24. All right, for the last problem, we have 4/7 divided by 3/14. So the first fraction, the 4/7, stays unchanged. Then I'm going to change my division to multiplication, and I'm going to be multiplying by the reciprocal of 3/14. So that's going to be 14/3. Now what can I cross-cancel here? I know that 14 divided by 7 is 2. So this will be 2. 7 divided by 7 is 1. Right? I'm just removing a factor of 7. And then I can't cancel anything else, so I just multiply. 4 times 2 is 8. And then 1 times 3 is 3. So we get 8/3 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on dividing fractions. Okay, so we just want to divide. And we have 7 divided by negative 1/5. So what we're going to do is we're going to write 7 as 7 over 1. And we're going to keep that number unchanged. Now we're going to multiply by the reciprocal of this fraction here. The reciprocal of negative 1/5 is 5 over negative 1, where you really could put negative 5 over 1. And we're just going to multiply here. Nothing we can cancel. 7 times 5 is 35. 1 times negative 1 is negative 1. So in the end, we just get negative 35 as our answer. Right? 35 over negative 1 is just negative 35. What about 2/3 divided by 10? So I'm going to write this as 10 over 1. And the first number is going to stay unchanged. I'm going to multiply by the reciprocal of 10 over 1, which is 1/10. Look to cross-cancel anything. I can cancel this 10 with this 2. That will give me a 5 here and a 1 here. Right? 10 divided by 2 is 5. And so I'd have 1 times 1, or 1 in the numerator, over 3 times 5, or 15 in the denominator. And so my answer here is 1/15. For the last one, I have 5/4 divided by 20. So I'll write this as 20 over 1. I'll have 5/4. That stays unchanged. And then I'm multiplying by the reciprocal of 20 over 1, which is 1 over 20. Now I can cross cancel here. Think about 20 divided by 5 would give me 4. So 5 over 5 is 1. 20 over 5 again is 4. And now I just multiply. 1 times 1 is 1. Over 4 times 4, that's 16. Hello and welcome to Pre-Algebra Test Section 5 on dividing fractions. All right, so we just want to divide. We're looking at -1/3 divided by 1/2 divided by 2/7. Now, when we have three fractions involved, we're just going to use the order of operations. We go left to right. So we're going to tackle this part first. So -1/3 divided by 1/2. We'll get a result, and we'll divide that by 2/7. So -1/3 divided by 1/2. This fraction, -1/3, stays unchanged. We're going to multiply by the reciprocal of 1/2, which is 2 over 1. Nothing to cancel, so we'd end up with -2 over 3. So we're going to put up here that this is going to be -2/3 divided by 2/7. Now, we take this first fraction, -2/3, and we leave it alone. Then we're multiplying by the reciprocal of 2/7, which is 7 over 2. Now we can cross cancel here. Forget about this negative for a minute. 2 over 2 is 1. All right, so I'll put a 1 here and a 1 there. Remember that negative now, so that's going to be a -1. Nothing else to cancel, so we'll do -1 times 7, that's -7. Over 3 times 1, that's 3. So we get -7/3 as our answer. All right, for the last one, we have 5/9 divided by 20 over 21 divided by 3/4. So again, I'm going to do this part first, and then I'll take the result and divide by 3/4. So I'd have 5/9 times the reciprocal of 20 over 21. That's going to be 21 over 20. So the greatest common divisor of 5 and 20 is 5. So divide each of these by 5. So 5 divided by 5 is 1. 20 divided by 5 is 4. The greatest common divisor for 21 and 9 is going to be 3. So divide 21 by 3, you get 7. Divide 9 by 3, you get 3. And we're done canceling stuff. Now we can just multiply. 1 times 7 is 7. Over 3 times 4, that's 12. So we'd have 7/12 divided by 3/4. So now we're tackling 7/12 divided by 3/4. 7/12 remains unchanged. We're going to multiply by the reciprocal of 3/4, which is 4/3. And the greatest common divisor between 12 and 4 is 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. And so now we're going to do 7 times 1, that's 7. Over 3 times 3, that's 9. And we get 7/9 as our answer. Hello and welcome to Pre-Algebra Practice Set number 32. In this video, we're going to look at some additional practice problems for our lesson on finding the LCM, otherwise known as finding the least common multiple. So to start out, we want to find the LCM by listing the multiples of each number. So this is the slower, more tedious method that we started our lesson out with. Basically, when we talk about the multiples of a number, we take the number, we multiply it by each non-zero whole number. So we'd start with 1 and kind of increase in increments of 1 out indefinitely. And that would generate a list of multiples for the number. So if I take the number 3, I'd multiply 3 times 1 to start. That would give me 3. Then I would do 3 times 2, that would give me 6. Then I would do 3 times 3, that would give me 9. And what I notice is that I'm just increasing in increments of 3. So then 12, then 15, then 18, then 21, so on and so forth. I'm just going to stop and put 3 dots there to tell me that pattern where I'm increasing in increments of 3 is going to continue forever. So the next one is 6. And basically we can use the same technique as we did here. If I did 6 times 1, I'd get 6. 6 times 2 would give me 12. Basically, I'm just increasing in increments of 6. Here I was increasing in increments of 3. Here I'm increasing in increments of 6. So then 18, then 24, then 30, then 36, then 42, then 48. And we'll go ahead and stop there. And finally, we have 12. So 12 times 1 is 12. And then we just increase in increments of 12 now. So 24, 36, 48, 60, 72, 84, 96, and we'll go ahead and stop there. So if we want to find the least common multiple, we not only have to look for what's common to all the lists, but also what's the least common to all the lists. So if I look through here, I would start by looking at 12. So 12 is a multiple of 12. It's also a multiple of 6, and it's a multiple of 3. So that's going to be my least common multiple. Now, once you've found the least common multiple, you know that if you take that number and you add it to 12, so if I take 12 and I add it to 12, that gives me 24. That's going to be my next common multiple. So it occurs at 24. And then add 12 again, so it would occur at 36. So you can see 36 here and here. You don't see it here because I didn't list all the numbers out, but you'd have 24, then 27, then 30, then 33, then 36. So then after that occur at 48. Again, every 12 numbers, you would have a common multiple between 3, 6, and 12. But the least common multiple, and let me circle it because I have a lot of things highlighted here, would be 12. Right? That's the least common multiple. So this equals 12. All right, we're going to do one more using this method. So to generate a list of multiples for 10, I would just start out with the number 10 because 10 times 1 is 10. And then I just increase in increments of 10. So 20, 30, 40, 50, 60, 70, 80, 90, and let's stop at 100. Again, the 3 dots tell me that that pattern is going to continue forever. So increasing in increments of 10. Then next we have 15. So start with 15 times 1, that's 15. And then increase in increments of 15. So 30, then 45, then 60, then 75, then 90, then 105, then 120, then 135, and comma, dot, dot, dot. And lastly, we're doing 20. So start out with 20 times 1, that's 20. Then increase in increments of 20, so 40, 60, 80, 100, 120, 140, 160, 180, 200. And we will stop there. All right, so let's look for the least common multiple now. So the first number we can find is actually 60. And what you're going to find is that every 60 numbers after that, you're going to have a common multiple. So at 120, you would have a common multiple. Right, you have 120 here and here. And after 100 up here, you'd have 110, then 120. So that's a common multiple between 10, 15, and 20. Then add another 60 to that, you get to 180. That'd be your next common multiple. So every 60 numbers. But the least common multiple is going to be 60. All right, now we're going to find the LCM using the prime factorizations of the numbers. So we want to look for the LCM of 39 and 65. So in case you didn't watch the lesson, this is fairly simple. There's just one step that kind of trips people up, and when we get to it, I'll spend a lot of time on it. So the first thing you want to do is just find the prime factorization for each number. For 39, it's 13 times 3. 3 is prime and 13 is prime. For 65, it's 13 times 5. 13 is prime and so is 5. And once we have this, we build ourselves a nice little table. So I'll have 39 and 65. And what this table is going to do is it's going to help us to see what prime factors we have in common between the two prime factorizations. So I'm looking for my smallest prime factor, and that's a 3 that occurs in 39. So I'm going to put a 3 here. 65 doesn't have it, so I kind of make a notation that tells me, hey, 65 is missing a 3. Then I look for the next highest, that's a 5 that occurs in 65. So I'm going to put a 5 there, but I don't have it in 39, so I'm going to kind of X that out to say, hey, we don't have that in the prime factorization of 39. And basically the next thing we have is 13, and that is shared by both. Each has a 13 in its prime factorization. So now we're going to build our LCM. Once we have this little table set up, we can build out our LCM for 39 and 65. Basically, what we want to do is include every prime factor from each prime factorization. Now, hold on, there's a catch to that. So there's a 3 in the prime factorization of 39. That's going to go in here. There's a 5 in the prime factorization of 65. That's going to go in here. And then some of you might say, okay, there's one 13 and then a second 13 that need to go in here. But that would be wrong. Here's where students get tripped up. When you have a prime factor that is shared, meaning it's in both of your prime factorizations here, you only need to put in the largest number of repeats between the prime factorizations. In this case, I have 113 in the prime factorization. In this case, I also only have 1. So the largest number of repeats would be 1, so I just put one single 13 when I'm building my LCM. That's all I need to do. I can put another 13 in here if I want to. That would also be a common multiple, but it wouldn't be the least common multiple, and that's what we're looking for. So now what we want to do is just go through a multiply. 3 times 5 is 15. 15 times 13 is going to give us 195. So that's going to be my LCM for 39 and 65. All right, now we're looking at one with 3 numbers, and it's really not more difficult. So we have the LCM of 22, 28, and 36. So I'm just going to factor each one. So 22 is 2 times 11. Both those numbers are prime. 28, let me just fix this real quick. 28 is 4 times 7. 7 is prime, 4 is 2 times 2. 2 is prime. 36, let's do 12 times 3. 3 is prime, 12 is 4 times 3. 3 is prime, 4 is 2 times 2. So now let's build ourselves a nice little table. So we've got 22, 28, and 36. So the smallest prime factor is 2. I've got one of those for 22. I've got 2 of those for 28. And I've got 2 of those for 36. So 1 for 22, 2 for 28, and 2 for 36. So I'm just going to box this guy out here. And going back up, the next smallest prime factor would be a 3. I have 2 of those in the prime factorization of 36, not matched anywhere else. So times 3 times 3. And I'm just going to X those guys out here. And then I have a 7 in the prime factorization of 28, not matched anywhere. And an 11 in the prime factorization of 22, not matched anywhere. So for 28, I'm putting times 7. And for 22, I'm putting times 11. And I'm going to go ahead and box these out here. So it's easy for us to see what we share. And looking at it, the only thing they really have in common, everything has 1, 2. And then between 28 and 36, they have a second 2 involved. So when we build our LCM for 22, 28, and 36, again, we want to include every prime factor from each and every prime factorization. The catch is when something is shared between, in this case we have 3 numbers, between at least 2 of the prime factorizations, we're only putting the largest number of repeats that occurs between any of the prime factorizations. So with the number 2, because it's shared, okay, because it's shared, the largest number of repeats would be 2. You have 2 factors of 2 in 36, and you have 2 factors of 2 in 28. So when I build my list, I only put 2 factors of 2, and I move on. So now I see that I have 2 factors of 3 in 36, not matched anywhere, so I just throw that in there. I have 1 factor of 7 in 28, not matched, so I just throw it in there. And 1 factor of 11 in the prime factorization of 22, not matched, so I just throw it in there. Again, if they're not shared, you just throw it in. You don't have to worry about how many you're going to put in there. If they are shared, you use the largest number of repeats between any of the prime factorizations. Okay, so now we're just going to multiply. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. 36 times 7 is 252. Then times 11 is going to give us 2,772 as our answer. All right, let's take a look at one final problem. We want to find the LCM for 55, 715, and 247. So we're going to factor each number. So 55 is pretty easy. We know that's 11 times 5. Both are prime. 715, I don't know. All I can see is that it ends in a 5. So I know that I can divide it by 5. So 715 divided by 5. 5 goes into 7 once. 1 times 5 is 5. Subtract, we get 2. Bring down the 1. 5 goes into 21 4 times. 4 times 5 is 20. Subtract and get 1. Bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtract and get 0. So 143 times 5. So 143 times 5. 5 is prime. 143 is not. It's 13 times 11. But 13 and 11 are each prime numbers. And then what about 247? Well, I really don't have a clue on this one. I don't really work with this number very often. I can start making some guesses. I can say 2 plus 4 is 6. 6 plus 7 is 13. not divisible by 3. I know it's not divisible by 2, not divisible by 5. What about 7? If I take and cut the 7 off, and then I double it, I get 14. 24 minus 14 is 10, not divisible by 7. And if I take the square root of 247, I get about 15.71. So I've tested up to 7. I just need to test 11 and 13. So for 11, I would number this as 1, 2, and then 3. 2 plus 7 would give me 9. And then if I subtracted away 4, that would give me 5. So that's not divisible by 11. Let's go ahead and just divide this by 13 and see what happens. 13 will go into 24 once. 1 times 13 is 13. Subtract here. 4 minus 3 is 1. 2 minus 1 is 1. Bring down the 7. Now I have to ask, how many times will 13 go into 117? Well, 13 times 10 is 130. If I have 130 and I take 13 away, I get exactly 117. So that tells me this is 9. 9 times 13 is 117. Subtract here, we get 0. So 19 times 13. Now each number here is prime, so we're done finding the prime factorizations. All right, let's make a little table. So we want a table for 55, 715, and 247. And again, let's start out with the smallest prime factor. So when I look through it, I see that that's a 5. There's a 5 in the prime factorization of 55. There's a 5 in the prime factorization of 715. It's not in the prime factorization of 247, so we'll just kind of mark that off. We'll then look for the next prime factor. Looks like that's going to be 11. So that's in 55 and 715. So we have 11. But again, it's not matched over here. Then next we'd have a 13 in the prime factorization of 715 and also 247. So we'll have 13 here and here, but not here. And then lastly, we have a 19 in the prime factorization of 247. So we'll have times 19, but that's not matched here or here. So we'll cross these out. All right, so to build my LCM for 55, 715, and 247, again, each and every prime factor from the prime factorizations is going to go in. The only time we have to kind of change up what's going in is when we have something that's shared, in this case, since we have 3 numbers, by at least 2 of the prime factorizations. So when we look at 5, it's shared between 2 of them. So I put the largest number of repeats, and the largest number of repeats would just be 1. Right? It only occurs once here and once here, so we throw 1 5 in there. Then we look at 11. That's shared again, but the largest number of repeats, again, is just 1. So we put 1 in there. Then for 13, same situation. It's shared between 2 prime factorizations, but the largest number of repeats, again, is just 1. So we're going to put times 13, just put 1 factor in there. And then lastly, we have 19. 19 is not shared with anything else, so we just throw it in there. We don't need to worry about how many times it goes in, because it's only going in once, not shared with anything. All right, so now we just multiply. 5 times 11 is 55. 55 times 13 is 715. Then if I multiply by 19, I get 13,585. And that's going to be our answer for the LCM of 55, 715, and 247. Hello and welcome to Pre-Algebra Test Section 1 on finding the least common multiple. And I have abbreviated here the LCM. So we want to find the LCM by listing the multiples of each number. So we're going to start out by finding the LCM of 4 and 10. So this is kind of a tedious method that we first covered in the lesson. And basically to generate the multiples of a number, you take the number, so for example with 4, we're going to take that number and we're going to multiply by each non-zero whole number. So you'd start out with the number 1. 4 times 1 would be 4. Then you'd multiply by 2. 4 times 2 would be 8. Then by 3, that would be 12. And you can notice here that you're just increasing in increments of 4. So after 12 would be 16, then 20, then 24, then 28, and so on and so forth. That's why we put the 3 dots there. Obviously, I can't list every multiple of 4, but the 3 dots will tell me that after 28 comes 32 and 36. Again, just increasing in increments of 4 out indefinitely. Now for 10, again, we're going to do the same thing. We'd start by multiplying by 1. So 10 times 1 is 10. then by 2, so that would be 20. You're just increasing in increments of 10. So 30, then 40, then 50, then 60, then 70, then 80. And I'm going to put 3 dots to say, hey, we're going to increase in increments of 10 indefinitely. So now I'm looking between these two lists here, and I'm looking for common multiples, and more specifically, the least common multiple, or the multiple they have in common that has the least value. So kind of looking through here, I see that 20 appears in this list and also in this list. And that is the lowest number that I see. So that's going to be my least common multiple. Okay, so that's going to be 20 for 4 and 10. All right, let's do one more. Again, this method is very inefficient. We're just doing it so that you know both methods might come up on a test. All right, so we're going to list the multiples for 6 and 21 here. So for 6, again, start out by multiplying by 1. 6 times 1 is 6. And then just increase in increments of 6. So we'd have 12, then 18, then 24, then 30, 36, 42, 48, and I think that's enough. Now for 21, you'd start out with 21 times 1, so that's 21. Then times 2 would be 42. Then we'd have 63. 84, 105, 126, and we'll go ahead and stop there. So what is the least common multiple that we can find? Well, looking, I see that 42 occurs here, and it occurs here. So that's going to be our least common multiple. So for the LCM of 6 and 21, it's going to be 42. Hello, and welcome to Pre-Algebra Test Section 2 on finding the LCM. Again, that's the least common multiple. So for our problems, we just want to find the LCM. And we're going to start out with the LCM of 15 and 18. So basically, we just want to find the prime factorization for each number. And for 15, we basically know that that's 5 times 3. We don't really need a factor tree for that. And for 18, we know that's 9 times 2, and 9 is 3 times 3. So 2 times 3 times 3. The next thing we do is we build a table to kind of organize our numbers. So 15 and then 18. And basically what I'm going to do is I'm going to put the prime factorizations in here, but I'm going to line them up to where anything that's in common is going to be on top of each other. So I have a 2 in 18, but nothing in 15. I have a 3 in 15 and 18. And then I have a second 3 in 18, but not in 15. And then in 15 I have a 5, but it's not in 18. So I'm just going to X out all these. And we can see that basically we just have 1 3 that's common to both. Now when we build our LCM for 15 and 18, basically what we want to do is take each and every prime factor from all of these prime factorizations, we just have 2 here, and throw them in a list that we're going to make. And we're going to multiply the numbers on the list together. But there's a catch. If there's a prime factor in the prime factorizations that's shared, you only put in the largest number of repeats. So in this case, for 18, we have this prime factor of 2. It's not shared up here, so I just throw it in. For 15 and for 18, you have one prime factor of 3. For 18, you have a second prime factor of 3. So because you have something that's shared, right, that 3 is shared, you only put in the largest number of repeats for that number. So the largest number of repeats occurs in the prime factorization of 18, right? There's 2 factors of 3 there, only 1 factor of 3 in the prime factorization of 15. So I'm just going to put 2 in when I'm building my list. The common mistake would be to put 3 in there. And although that's going to give you a common multiple, it's not the least common multiple. And that's what we're looking for. Now the next number is 5. That's not matched anywhere, so we just throw that guy in there. So now we just multiply. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is going to give us 90. So the LCM for 15 and 18 is 90. All right, let's find the LCM for 14 and 63. So again, factor each number. 14 is 7 times 2. 63 is 7 times 9. And 9 is 3 times 3. So we can build a table, again, to help organize these numbers. So So I've got a 2 in the prime factorization of 14. Don't have it in 63. I've got 2 3s in the prime factorization of 63. Don't have it in the prime factorization for 14. And then I've got a 7 in the prime factorization of 14 and also in 63. So go ahead and X these out. And you can see the only thing they really share is that 7 there. That's common to both. So when we build our LCM, for 14 and 63, again, we're putting everything in from all our prime factorizations. So I'm putting in a 2. I'm putting in a 3. I'm putting in a second 3. When I get to the 7, that's where I need to stop because that's something that's common to both. When you have a prime factor that's common to both, you put the largest number of repeats from either of the prime factorizations. In the prime factorization of 14, I have one factor of 7. In the prime factorization of 63, I have one factor of 7 as well. So the largest number of repeats is 1. So we just put 1 7 in when we're building our LCM, right? We don't put 2 in. We don't need it. All right, so now let's just multiply. 2 times 3 is 6. 6 times 3 is 18. And then 18 times 7 is 126. So that's going to be our LCM for 14 and 63. Hello and welcome to Pre-Algebra Test Section 3 on finding the LCM. Again, that's the least common multiple. So we want to find the LCM, and we're just working with one problem here. We're going to look for the LCM of 24, 81, and 156. So again, we're going to start by factoring each number. So 24, I don't think we need a factor tree for that. That's just 4 times 6. We know that 4 is 2 times 2, and 6 is 2 times 3. For 81, that's 9 times 9, and I know 9 is 3 times 3. So we can just put 3 times 3 times 3 times 3. And then for 156, I know that 56 is divisible by 4. So I know that 156 would be divisible by 4. Let's do that. 156 divided by 4. 4 will go into 15 3 times. 3 times 4 is 12. Subtract and get 3. Bring down the 6. 4 goes into 36 9 times. 9 times 4 is 36. Subtract and get 0. So 39 times 4. 39 times 4. Now I know 4 is 2 times 2. And I know 39 is 13 times 3. Okay, so now that we have our prime factorizations, we're going to go through and make a nice little table for ourselves. So we have 24, we have 81, and we have 156. And this table is just going to help us organize our numbers. So what we want to do is just write out the prime factorizations for each number in a way to where we can see what's common to everything. So I'm going to start out with 2. That's the smallest prime factor from any of the factorizations. I've got 3 factors of 2 in 24. I've got no factors of 2 in 81. And I've got 2 factors of 2 in 156. So what I generally do is just kind of line everything out to show what's common and what's not. The next highest prime factor would be 3. I've got 1 in the prime factorization of 24. I've got 1 in the prime factorization of 156. And I've got 4 in the prime factorization of 81. So I'm going to go ahead and line these spaces out because it's not shared. And then lastly, I have a 13 in the prime factorization of 156. So I'll put that there. And again, that's not matched, so I'll kind of line that out. Okay, so now we can build our LCM. We're going to build it from this table here. So the LCM for 24, 81, and 156, what we want to do is we want to include each and every prime factor from all of the prime factorizations here. Now, the trick is when you have a prime factor that is common to, in this case we're working with 3 numbers, so you'd say common to at least 2 of them, you only include the largest number of repeats between any of the prime factorizations. So for example, with 24, you'll see that you have 1, 2, 3 factors of 2. No factors of 2 in 81, 2 factors of 2 in 156. Where a lot of students get confused is they'll go, okay, I have 1, 2, 3, 4, 5. So I'm going to put 5 factors of 2 in the prime factorization for the LCM. That's wrong. you use the largest number of repeats between any of the prime factorizations. So the largest number of repeats occurs here, where we have 3 factors of 2. 3 factors of 2 here, only 2 factors of 2 there. 3 factors of 2 is the largest number of repeats, so that's what we put in when we're building our LCM. Now the next number is 3, and you're going to see that that's common to everything. You have at least one 3 everywhere, but the largest number of repeats occurs in the prime factorization of 81, so you're going to put 1, 2, 3, 4 factors of 3 in here. 1, 2, 3, 4. Again, the common mistake would be to put 1, 2, 3, 4, 5, 6 of them in the prime factorization for the LCM. You don't need that many, right? That's going to give you a common multiple, but it's going to be too big. It's not going to be the least common multiple. So again, you want to use the largest number of repeats that occurs in any of the prime factorizations when you have a number that's common to at least 2 of them, right? At least 2 of them. So now the next number is 13. And I can just throw that in there because it's only common to 1 of them. I don't need to look for the large number of repeats. It just occurs once in the prime factorization of 156. So once I have this list going, I just multiply everything together and I have my LCM. 2 times 2 times 2 is 8 times, we know that 3 times 3 times 3 times 3 is 81. So 8 times 81 would be 648. And then we multiply by 13, we'd get 8,424 as our answer. Hello and welcome to Pre-Algebra Test Section 4 on finding the LCM. Again, this is the least common multiple. So we want to find the LCM, and we're just working with one problem here. We want the LCM for 121, 165, and 231. So we're going to start by factoring each number. Let's do this down here. So for 121, I happen to know that that's 11 times 11. And 11 is a prime number. So let's circle both of those. The next number is 165. So let me just write that 121 is 11 times 11. And we're going to go down there and look at 165. So that's going to be divisible by 5 since it ends in a 5. So what's 165 divided by 5? 5 goes into 16 3 times. 3 times 5 is 15. Subtracting, you get 1, bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtracting, get 0. So 5 times 33. 5 times 33. 5 is prime, and 33 is 3 times 11. 3 and 11 are both prime. So 3 times 5 times 11. And then what about 231? Well, 2 plus 3 is 5. 5 plus 1 is 6. So I know it's divisible by 3. Let's start out with that. 3 goes into 23 7 times. 7 times 3 is 21. Subtracting, you get 2. Bring down the 1. 3 goes into 21 7 times. 7 times 3 is 21. Subtracting, get 0. So 3 times 77. 3 is prime. 77 is 11 times 7. 7 and 11 are both prime. So 3 times 7 times 11. So 231, again, is 3 times 7 times 11. And now we're going to build ourselves a nice little table so we can organize our numbers. So for 121, 165, and 231. So what we do is we kind of write our prime factors in the table to where it's obvious what's common to everything. So I'm going to start with the smallest prime factor between any of the prime factorizations. That's a 3. And that's going to be in the prime factorization of 165 and 231, but not in 121. So I'm just going to kind of X that out. Next I have 5. That's in the prime factorization of 165. Not in 121, not in 231. So I'm just going to X those out. Next I have a 7 in the prime factorization of 231. And it's not common to 165 or 121. So we're just going to X those out. And lastly, we have 11. So I have 2 factors of 11 in 121. I have 1 factor of 11 in 165 and 1 factor of 11 in 231. So I'm just going to X those out here. And now we can build our LCM from the information in this table. So for the LCM of 121, 165, and 231, what we need to do is include each and every prime factor from all the prime factorizations. When you have one of your prime factors that occurs in more than one of the prime factorizations, so when you're working with three numbers, it's going to just be at least two. You're going to include the largest number of repeats from any of the prime factorizations. So for example, if we start out with the number 3, if you look in the prime factorization of 165, you have one factor of 3. If you look at the prime factorization of 231, you have one factor of 3. So because this is common to these two prime factorizations, I want to use the largest number of repeats between any of the prime factorizations. It only occurs once here and once here, so I only put 1 in when I'm building my list for the LCM. I only want 1. The common mistake is to put 2 in, but again, use the largest number of repeats between the two factorizations there, and that's just 1. Now the next number is 5. Now that's only in the prime factorization of 165, so you just throw that in there. Then there's a 7. That only occurs in the prime factorization of 231, so just throw that in there. Next we have 11. Now you'll see that everything has at least one 11, but in the prime factorization of 121 you have 2 of them. So again, if you have something that's common, you need to only include the largest number of repeats between any of the prime factorizations. That's going to occur right here. You have 2 in the prime factorization of 121, so that's all you're going to put in here. Just 2 factors of 11. Again, the common mistake would be, okay, I'm going to put all of these in here. So I put 1, 2, 3, 4 factors of 11. You don't want to do that. Again, if something's common, put the largest number of repeats between all of your prime factorizations. Again, that occurs here. So we put 2 factors of 11 when we build our LCM. All right, so now we just want to multiply. 3 times 5 is 15. 15 times 7 is 105. Times 11 is 1,155. Times 11 again is going to be 12,705. And that's going to be our LCM for 121, 165, and 231. Hello and welcome to Pre-Algebra Test Section 5 on finding the LCM. Again, that's the least common multiple. So we want to find the LCM, and we just have one problem to work on. We want to find the LCM for 550, 150, and 225. So the first thing we're going to do is factor each number. So for 550, it ends in a 0, so I know it's divisible by 10. This will be 55 times 10. 55 is 5 times 11. 10 is 5 times 2. And all of these numbers are prime. So for 550, the prime factorization we'll write as 2 times 5 times 5 times 11. For 150, it also ends in a 0, so I could do 15 times 10. 15 is 5 times 3. 10 is 5 times 2. All of these are prime. So for 150, we have 2 times 3 times 5 times 5. Then for 225, that's 15 times 15. So I don't need a factor tree for that. That's just going to be 5 times 3 times 5 times 3. And I can write that as 3 times 3 times 5 times 5. Okay, so let's make a little table to organize our numbers here. So I'm going to put 150, 225, and then 550. So I'm looking for basically the smallest prime factor, and I'm going to write that in first. So the smallest prime factor is 2. So that occurs in the prime factorization of 150 and also in 550, but not in 225, right? Because this is an odd number. So I put those in, and then basically what I do is I'm just going to X this out here to say that it doesn't have it. I'm just looking for a way to kind of show what's common to everything. Now the next largest prime factor is 3. I've got one of them in the prime factorization of 150, and I've got 2 of them in the prime factorization of 225. So what I'm going to do is I'm going to X out these positions here where it's not common. All right, next I have 5, and everything has 2 factors of 5 in it. So I'm going to put 2 factors of 5 everywhere. And then after that I have 1 factor of 11 in 550. But it's not shared anywhere else, so we'll X that guy out. Okay, so from this table, we can now build our LCM. So building the LCM for 150, 225, and 550. Now sometimes it seems a little complicated, But essentially, you just need to do this. You're including every prime factor from all the prime factorizations. It's just a matter of how many times you put it in when you build your LCM. So, for example, if any prime factor is repeated between, in this case we have 3 numbers involved, so between at least 2 of them, all you need to do is include only the largest number of repeats between any of the prime factorizations. So for example, with the factor of 2, I only have one factor of 2 in the prime factorization of 150 and one factor of 2 in the prime factorization of 550. So I just put one factor of 2 in when I build my LCM. The common mistake is to throw 2 factors of 2. They say, okay, well, I got a 2 there and a 2 there, so I put 2 factors of 2 in. That's the wrong answer. Although it would give you a common multiple, it's not the least common multiple, so it's the wrong answer. So again, the largest number of repeats between any of the prime factorizations. The largest number of repeats is that it occurs only once, so only 1 goes in when we build our LCM. The next number is 3. So that's common here to 150 and 225. The largest number of repeats occurs in the prime factorization of 225. You have 2 factors there, so I put 2 factors in when I build my LCM. Again, don't put 3 of them in there, only use the largest number of repeats. The largest number of repeats is 2, so you get 2 factors in when you build the LCM. Next we have 5. Now everything has 2 factors of 5. So you guessed it, we're going to put 2 factors of 5 in here, and only 2 factors of 5, because again, you use the largest number of repeats when something is common. The largest number of repeats is 2. Everything has only 2 factors of 5, so again, that's all we're putting in there. Don't put 6 factors of 5 in when you build your LCM. The last number 11 is not common to anything else. It just occurs in the prime factorization of 550. So we just throw this in here and we're done. All we need to do now is just multiply the numbers together and we'll have our LCM. So 2 times 3 is 6, times 3 is 18, times 5 is 90, times 5 is 450, then times 11 is 4,950, and this is going to be our LCM for 150, 225, and 550. Hello and welcome to Pre-Algebra Practice Set number 33. In this video, we're going to look at some additional practice problems for our lesson on adding and subtracting fractions. All right, so we're going to start out with 3/5 minus 1/5. So remember, when you add or subtract fractions, you have to have a common denominator. In this case, we have a common denominator of 5. So when we see that, we know that we're going to have an easy job. Basically, what we're going to do is we're going to rewrite that common denominator as the denominator for our answer. We don't need to touch the denominator again. We're done with that part. Then we're going to perform this operation using the numerators only. So I'm going to do 3 minus 1, and 3 minus 1 is 2. So I'm going to write that as my numerator. So the answer here is going to be 2/5. Now when you work with fractions, you always want to report your answer where it's simplified, or we could say reduced to its lowest terms. Now 2 and 5 are both prime numbers, so there's really nothing that we can cancel between the numerator and denominator. So this is going to be our simplified answer. Again, it's going to be 2/5. What about 7/9 plus 5/9? Again, we have a common denominator here, so we don't need to touch that. We're just going to use 9 as our denominator in the answer, and then we're just going to add the numerators, right? So we're going to do 7 plus 5, and that gives us 12. Now, if we look between 12 and 9, we should know that both are divisible by 3. So if the greatest common divisor, or again, the greatest common factor, it's the same thing, between the numerator and denominator is 3, you can divide each by 3 and get your simplified fraction. So 12 divided by 3 would give me 4. 9 divided by 3 would give me 3. So I end up with 4/3. And again, if you can't do that in your head yet, just go ahead and factor each number. So 12, you know, is 2 times 2 times 3. And 9 is 3 times 3. And then look to see what you can cancel between numerator and denominator. Well, you can only cancel one factor of 3. Again, that's the greatest common factor or the greatest common divisor. And you just go through and see what's left. I have 2 times 2 or 4 in the numerator over just a 3 in the denominator. So kind of either way you do that, you end up with 4/3 as your simplified answer. All right, let's take a look at -8/3 plus -7/3. So again, we have a common denominator of 3. So that's going to be our denominator in the answer. And then we're just going to add the numerators. What is -8 plus -7? Negative plus negative is negative, and then 8 plus 7 is 15. So we'd end up with negative 15 thirds. Now, the greatest common divisor here is going to be 3, right, between 15 and 3. Just forget about that negative for a second. So I can just divide the numerator and denominator by 3, and we'd end up with negative 5 over 1, or just negative 5. And you should know that 15 divided by 3 is 5, so if I have negative 15 divided by 3, that's going to give me negative 5. Again, another way you can think about this, if I factor negative 15, just think about it as negative 1 times 5 times 3. 3 is a prime number, so we're not going to factor that. And then just cancel this common factor of 3 between numerator and denominator. Remember, if something cancels completely, you just put a 1. And we end up with negative 1 times 5, or negative 5 over 1, which would just be negative 5. Okay, now let's look at negative 1/8 minus negative 5/8. So the first thing I want you to notice is that you have minus a negative. Remember, when you have minus a negative, it's plus a positive. So let's write this as negative 1/8 plus, again, positive 5/8. So now that we got that out of the way, we have a common denominator of 8. So we're going to write that. And then we just perform the operation with the numerators. So what is negative 1 plus 5? Well, it's the same thing as saying what is 5 minus 1? And that's 4. So looking at 4 over 8, or 4/8, most of you can tell that the greatest common divisor is going to be 4. So if you divide each by 4, 4 divided by 4 is 1, 8 divided by 4 is 2, you'll end up with a simplified answer of 1/2. Again, if you can't do that, just take 4 and factor it. 4 is 2 times 2. 8 would be 2 times 2 times 2. And you can see that you can cancel a common factor of 4 between numerator and denominator. And again, you'd end up with 1/2 as your answer. All right, what about 9 over 50 minus 14 over 50? Again, we have a common denominator. So I'm just going to write that guy there. And we're just going to do 9 minus 14. So to do 9 minus 14, again, you can think about this as 9 plus negative 14. The sign is going to be negative. And then I would do 14 minus 9, and that's going to give me 5. So I'd end up with negative 5 as my answer there. So negative 5 over 50. Now forget about the negative for a minute. If I think about 5 and 50, the greatest common divisor is going to be 5. Right? So if I divide this by 5, I'd end up with a negative 1. If I divide this by 5, I'd end up with 10. So we'd end up with negative 1/10 as our answer. And again, you could just factor. You could leave this as negative 5. And then you could take 50 and say that's 5 times 5 times 2. Again, cancel this with this. That's going to give you a 1. And just work with what's left over. You'd have negative 1 over 5 times 2, or 10. Again, negative 1/10 is your answer. Okay, now we have one with 3 fractions. But again, it's easy because we have a common denominator for each. I'm just going to rewrite that 16 there and just add straight across. So 5 plus 11 is 16. 16 plus negative 4 is the same thing as 16 minus 4. So that's 12. So the greatest common divisor between 12 and 16 would be 4. Right? You can think about 12 as 4 times 3. And I know you could break it down further and say it's 2 times 2 times 3, but just think about it as 4 times 3. And think about 16 as 4 times 4. So again, greatest common divisor is 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. So 3/4 would be your simplified answer. And again, I keep doing this. If you need to factor it further, just think about 12 as 2 times 2 times 3. Think about 16 as 2 times 2 times 2 times 2. And again, you can cancel a common factor of 4 between the numerator and denominator and be left with a 3 over a 2 times 2, or 4, which leads us to this right here, this 3/4. Again, if you notice the greatest common divisor is 4, then you can just divide each by that number and get your simplified fraction in a shorter period of time. Okay, what about negative 2/5 minus a negative 1/5 minus 7/5? So the first thing I'm going to do is rewrite this as negative 2/5. Minus a negative is plus a positive. So I'm going to put plus 1/5. And then I'm going to put minus 7/5. Now we have a common denominator of 5. So I'm going to put that as my denominator for the answer. And then I'm just going to add and subtract across. Remember, you just go left to right. So negative 2 plus 1 is negative 1. And then negative 1 minus 7 is the same thing as negative 1 plus negative 7. So that's negative 8. So we ended up with negative 8/5 as our answer. And there's nothing we can really cancel here. If you think about 8, it's 2 times 2 times 2. If you think about 5, it's a prime number. So we're going to stay with negative 8/5 as our answer. All right, let's take a look at some problems where we don't already have a common denominator. So these are more tricky, right? They require more work, and a lot of students will get a little bit confused when they're trying to find the least common denominator. So for 11/15 plus 12/40, again, the first thing we need to do is find a common denominator. Here I have 15, here I have 40. I can't just add and go, okay, 11 plus 12 is 23, over 15 plus 40, that's 55. Please don't make this mistake. This is wrong. Wrong. Okay, don't do that. The second mistake that students make is when they're finding a common denominator, they'll just multiply the two denominators together and say, okay, 15 times 40 is 600, so that's going to be my common denominator. You don't want to do that either because it's going to give you more work in the end, right, as far as simplification. So to find the least common denominator, abbreviated LCD, what we want is we want the least common multiple for 15 and 40. And again, in our previous lesson, we learned how to find the least common multiple. So I would just factor each number. 15 is 5 times 3. 40, I'm going to write as 5 times 8, or 5 times 2 times 2 times 2. When they have a factor in common, you use the largest number of repeats between any of the two factorizations. I have one factor of 5 here and one factor of 5 here, so the largest number of repeats is just 1. So I put one factor of 5 in, and then everything else goes in because it's not common to both. So I put a 3 in, and I put 3 2's in, so I basically put 8 in. So 5 times 3 is 15, and then 15 times 8 is 120. So again, the reason we use this least common denominator of 120, that's smaller than if I just multiplied 15 times 40 and got 600. So when I go to simplify, it's going to be less work. So now that we have found our least common denominator, we're going to transform each fraction into an equivalent fraction, meaning it has the same value, where 120 is the denominator. So how do we do that? So we have 11 over 15. We want to multiply the denominator by an amount that's going to change it to a denominator of 120. So 15 was 5 times 3, so to get to 120, I need to multiply by 8. Now the trick here is, if I multiply the denominator by 8, I need to also multiply the numerator by 8, because 8 over 8 is really 1, and multiplying by 1 leaves a number unchanged. Now the next thing I'm going to do is transform 12 over 40, again, into an equivalent fraction where 120 is the denominator. So 12 over 40 times, well, 40 is 5 times 8, so it's really needs to be multiplied by 3. So multiply this by 3, and then again, to make it legal, you multiply the numerator by 3. In each case, I'm basically multiplying by 1. It's a complicated form of 1, but it's really 1. So again, the LCD is 120, and I'm just going to continue this down here. Now, I got a lot of operations going on, but remember, the order of operations tells me to multiply before I add. So I'm going to figure these parts out first before I do any addition. So 11 times 8 is 88. We know that 15 times 8 is 120. 12 times 3 is 36. And again, we know 40 times 3 is 120. So now my common denominator is here, and I just write that. And I just need to perform the operation with the numerators. So what is 88 plus 36? 8 plus 6 is 14. 1 plus 8 is 9. 9 plus 3 is 12. So I'm going to get 124 over 120. Now I'm not done because each number here is divisible by 4. I know that 20 is divisible by 4, the last two digits of that number. I know 24 is divisible by 4, the last two digits of that number. So 124 divided by 4 would be 31. So this would be 31, and 120 divided by 4 is going to give me 30. Now 31 is a prime number, and 30 is 5 times 6, or you could say 5 times 2 times 3. But there's nothing else I can cancel between numerator and denominator. So again, if you know your greatest common divisor, and I spotted that it was 4 right away, you can just divide each by that number and get to your simplified fraction. Again, the slower way would be to say, okay, 124 is 31 times 2 times 2. 120 is, 30 times 4. So 2 times 2 times 2 times 3 times 5. Then again, between numerator and denominator, you can see that I'm canceling 2 factors of 2, or a factor of 4. And I end up with 31 over 2 times 3, which is 6, times 5, which is 30. I just took a little shortcut. Okay, what about negative 1/3 plus 5/9? So a lot of you can, at this point, say that I know that the LCM between 3 and 9 would be 9, right? Because 9 is 2 factors of 3. 3 is a prime number. So the LCD is going to be 9. But let's formally do this. So the LCD is the LCM for 3 and then for 9. And again, 3 is not going to factor. It's a prime number. So again, because 9 has 2 3's in it, that's what we use in our LCM. So 3 times 3 is 9. So again, that's our LCD. So negative 1/3, I need to multiply by 3 over 3. And again, that's so I have a denominator of 9. And I multiply the numerator by 3 so that we have 3 over 3, which is a complicated form of 1. Multiplying by 1 leaves the number unchanged. Then plus, I have 5/9. Now, sometimes you're going to get a denominator that's already equal to the LCD. If this is the case, I don't need to do anything, right? I can leave this fraction alone. Now what I want to do is just perform this operation. Negative 1 times 3 is negative 3. Over 3 times 3, that's 9. And then plus 5/9. So I'll just continue this down here. So negative 3 plus 5 is the same thing as 5 minus 3. That's going to give me 2. And then it's over the common denominator of 9. So we end up with 2/9 as our answer. And 2 is a prime number. 9 is 3 times 3. So there's nothing we can really do to simplify this. So 2/9 is our simplified answer. Okay, let's take a look at 5 over 20 minus 4 over 30. So again, the LCD here, we're looking for the least common multiple for the two denominators. So 20 and 30. So factor 20, I know it's 5 times 4. 4 is 2 times 2. And 30 is 6 times 5. So 5 times 2 times 3. Each has one factor of 5. So one factor of 5 and only one factor of 5 goes in when I build my LCM. Each has 2 in the prime factorization. So we use the largest number of repeats, and that occurs here. So the largest number of repeats would be 2 factors of 2. So when I build the LCM, I'm putting 2 of those guys in there. And then we have a 3 in the prime factorization of 30. That's got to go in as well. So 5 times 2 is 10. 10 times 2 is 20. 20 times 3 is 60. So that's going to be my LCM for 20 and 30, and therefore my least common denominator that I can form. All right, so now we're going to transform these two fractions into equivalent fractions where 60 is the denominator. So if I have 5 over 20, so I need to multiply 20 by 3 to get to 60. Again, to make this legal, I do the same thing for numerator and denominator so that I'm really multiplying by a complicated form of 1. Then I have 4 over 30. So to get 30 to 60, I need to multiply by 2. So I'm going to multiply by 2 over 2, again, so that it's legal. Now let me erase all this and get some room going. So again, the LCD is 60, and I'm just going to continue down here. We're going to multiply 5 times 3, that's 15. Over 20 times 3, that's 60. Then minus 4 times 2 is 8. Over 30 times 2, that's 60. So now we're just going to subtract with our numerators. 15 minus 8 is 7 over the common denominator of 60. So we end up with 7 over 60 as our answer. And we can't do anything to simplify because 7 is a prime number. And 60 we know is 2 times 2 or 4 times 3, which would be 12, times 5, again, which would get me to 60. So nothing to cancel between numerator and denominator there. So this is already simplified. Okay, let's take a look at one final problem. And it's one with 4 fractions involved, so it's a little bit tedious, but I kept the denominators relatively small so that the work would be less. So we start out by finding, again, the least common denominator. And that's always going to be the least common multiple for your denominators. So you have 12, you have 14, you have 21, and you have 15. So factor 12, you get 4 times 3. And 4 is 2 times 2. Factor 14, you're going to get 2 times 7. Factor 21, you're going to get 3 times 7. And factor 15, you're going to get 3 times 5. So just kind of starting out with the lowest prime factor from any of these, we have a 2. The largest number of repeats occurs here, where you have 2 factors of 2, so that's what's going in here. Then next we move on to 3. This has 1, 3, this has 1, 3, and this has 1, 3, so we include 1, 3, and 1, 3 only. Then we have 1, 5 here, so that goes in, and then we have 1, 7 here, and 1, 7 here, so we put 1, 7 in only. So 2 times 2 is 4, times 3 is 12, times 5 is 60, times 7 is 420. So times 7 is 420. So now we're going to write each fraction as an equivalent fraction where 420 is the denominator. So we're going to start out with 4 over 12, or 4/12, and we multiply that by what to get to 420? Well, this is what 12 is, so I need to multiply by 5 times 7, or 35 over 35. Then plus, we have 9/14, and 14 is 7 times 2, so I need to multiply by 2 times 3, or 6, times 5, or 30. So 30 over 30. Then minus, we have 6 over 21. And 21 is 7 times 3. So I'm multiplying by 5 times 2 times 2, or 5 times 2 is 10. 10 times 2 is 20. So 20 over 20. And then minus, we have 3 over 15. 15 is 5 times 3. So I need to multiply by 2 times 2, or 4, times 7, which is 28. So multiply by 28 over 28. All right, so 4 times 35 is 140. And we already know the denominator is going to be 420. Then plus 9 times 30 is 270. Again, the quick way to do that is 9 times 3 is 27. Put a 0 at the end. Over, we know that 14 times 30 is going to give us 420. Then minus 6 times 20 is 120. Again, 6 times 2 is 12. Put a 0 at the end. 21 times 20 is 420. Then minus, we have 3 times 28. That's 84. Over 15 times 28, which again we know is 420. So now we just want to perform the operations working left to right. So let's start out with 140 plus 270. So 0 plus 0 is 0. 4 plus 7 is 11. Carry the 1. 1 plus 1 is 2. 2 plus 2 is 4. So that's 410. Now I'm going to subtract away 120. So I do 410 minus 120. So 0 minus 0 is 0. You need to borrow here. 11 minus 2 is 9. 3 minus 1 is 2. So that's 290. And then lastly, I'm subtracting away 84. Borrow here. 10 minus 4 is 6. 8 minus 8 is 0. Bring down the 2. So we get 206. And then over 420. So now we need to simplify. And both numbers are even, so for sure we can divide both by 2. So let's just do that and see what we get. 206 divided by 2 is 103. 420 divided by 2 is 210. Now the question you would ask yourself at this point is 103 a prime number? If you took the square root of it, you get about 10.14. So I would test 2, which is not even, so it's not going to work there. 3, 1 plus 0 plus 3 is 4, so that's not going to work. 5 doesn't end in a 0 or 5, so that doesn't work. 7, if I cut 3 off and I double it, that would give me 6. Subtract it away from 10, that would give me 4. Not divisible by 7. And we can go ahead and test 11 too if we want. So number the digits here. This would be 1, 2, and 3. And again, it's just a coincidence that the first digit is a 1 and the third digit is a 3. But 1 plus 3 is 4. 4 minus 0 is 4. So it's not divisible by 11. So this number, 103, is a prime number. And so we have simplified this fraction as far as we can. So we end up with 103 over 210 as our final answer. Hello and welcome to Pre-Algebra Test Section 1 on adding and subtracting fractions. So for the problems we're going to look at today, we just want to find the LCD. Again, this means the least common denominator of the fractions. So we're going to start out with these two fractions here, 1/8 and 1/12. So I know a lot of you get confused when you start talking about LCD, LCM, GCF, GCD. Again, as you practice with these terms more and more, you'll not only understand what they are, but where and when to use them. So the LCD is found by finding the least common multiple, again abbreviated LCM, for the two denominators. So the least common multiple of 8 and 12 is what we're looking for here. So how do we find the least common multiple? Well, we'd factor each number. 8 is 4 times 2, 4 is 2 times 2, so we'd put 2 times 2 times 2. For 12, we'd put 4 times 3, or 2 times 2 times 3. Now, when you build your LCM, essentially what you're doing is you're looking for factors that are common to the prime factorizations of all the numbers. In this case, you can see that 2 is common to both. Now, when that occurs, you put the largest number of repeats from any of the prime factorizations. So in the prime factorization of 8, you can see you have 1, 2, 3 factors of 2. In the prime factorization of 12, you have 1, 2. So the largest number of repeats occurs here. So when I build my LCM, I'm putting 1, 2, 3 factors of 2 in there, because again, that's the largest number of repeats from any of the prime factorizations. Then the only other number we have is a 3. That's not common to both, so we just throw it in there. All right, so now we just multiply and we'll have our least common multiple and therefore have our least common denominator. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So the LCD here, the least common denominator for these two fractions, 1/8 and 1/12, is going to be equal to 24. Let's take a look at another one. Let's say we had 2/3 and 5/18. So again, the LCD, or the least common denominator, is going to be the least common multiple of the two denominators. So 3 and then 18. But again, let's go through the process. So 3 doesn't factor, and 18 is basically 3 times 6, or 3 times 3 times 2. And so when you build your LCM, it's basically going to be 2 copies of 3 and 1 factor of 2, or just the number 18. So the LCD here is going to be 18. Okay, let's take a look at one final problem. So we have 2 over 14, 3 over 50, and 5 over 64. So again, to find the LCD, we're trying to find the LCM, the least common multiple, of 14, 50, and 64. So we're going to factor each number. 14 is easy, it's 2 times 7. 50 is easy, it's 25 times 2. So I'm going to put 2 times 5 times 5. And then 64 is 6 factors of 2. So 2 times 2 times 2 times 2 times 2 times 2. Right? You just think about it as 8 times 8, right? Or 6 factors of 2. So when I build my LCM, the first factor, or the smallest prime factor in any of the prime factorizations, is 2. So 2 is common to everything. So again, I go with the largest number of repeats, and obviously that occurs here. So I'm going to put 6 factors of 2 in here, and I'm going to go ahead and just write that as 64. Just to save on space. Then the next thing I notice is I have 2 factors of 5. That's not common to anything else, so that just goes in there. And I have a factor of 7. That's not common to anything else, so that goes in there. So basically we have 64 times 25 times 25 times 7. So in the interest of time, I'm just going to do this multiplication with a calculator. 64 times 25 is 1,600. Then if we multiply by 7, we would get 11,200. So that's going to be your LCD. So your least common denominator is going to be equal to 11,200. Hello and welcome to Pre-Algebra Test Section 2 on adding and subtracting fractions. All right, so for the problems, we're just going to perform the indicated operation. We're really just going to be doing some addition and subtraction. So we're going to start out with 4/25 plus 6/25. So very important when you add or subtract fractions that you have a common denominator. In this case, we do have a common denominator to start, so it's a very simple problem. If you already have a common denominator, then your answer will have that common denominator. So in other words, I just take that 25 that's common to both and use it as the denominator for my answer. Don't make the mistake of adding 25 plus 25 and saying that, okay, this is going to be a denominator of 50. Right? The denominator is not going to change. The denominator will stay as a 25. Now I'm just going to add the numerators. So 4 plus 6 is 10, so I get 10 over 25. But we're not done. Whenever we work with fractions, we want to report our answer in simplified form, or as we'd say, reduced to its lowest terms. Now, at this point, you might be starting to get pretty good at this, and you might be able to eyeball that and say, okay, well, 10 is 5 times 2, and 25 is 5 times 5. So the greatest common divisor between the two, or the greatest common factor, it's the same thing, would be 5. So I can just divide each by 5. So divide 10 by 5, and I would get 2. Divide 25 by 5, and I would get 5. And I would have my simplified form for this fraction of 2/5. All right, let's take a look at 8/11 plus -4/11. And again, we have a scenario where we have a common denominator. So that stays unchanged. We just write the denominator as 11, and we just perform the operation with the numerators. So I'd have an 8 plus a -4. That's the same as 8 minus 4, so that's 4. So if we have 4 over 11, that's already simplified, right? 4 is 2 times 2. 11 is a prime number. So 4 over 11, or 4/11, is our answer. Okay, now we look at 6/7 minus 5/7. And again, we have a common denominator. So we're going to write that as the denominator in our answer. And then we just perform the operation with our numerators. So we do 6 minus 5, and that's 1. So we get 1/7 as our answer. So 1 can't be factored. It's not a prime number because it's excluded from that definition, but we can't really factor it. We can't do anything with it. 7 is a prime number, so we can't factor that either. We could do 7 times 1 if we want, but we really can't do anything. So 1/7 is as simple as we can make this fraction, so that's going to be our answer. Okay, for the last problem, we have 7/12 minus 4/12. And again, we have another easy one where we have a common denominator already. So that's going to be the denominator for our answer. And then we just do 7 minus 4, and that's 3. Now, eyeballing this, I know that 12 is divisible by 3, right? Meaning 3 is a factor of 12, or 3 is a divisor of 12, however you want to think about that. So if I know that right away, I can divide each by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So again, that gives me a simplified fraction of 1/4. Again, that's kind of the quick way to do it. The slower way would be to say, okay, I have a 3 up here. 12 is 4 times 3. 4 is 2 times 2. And then just look between numerator and denominator and cancel here. Again, this is fine if you want to keep doing this. And a lot of times when you first start, it's probably better to do this so that you don't miss any common factors. But once you get good at it, you're going to speed up and do it this way, because on a lot of tests, you'll be timed and you won't have extra time to go through and do this. Hello and welcome to Pre-Algebra Test Section 3 on adding and subtracting fractions. So we just want to perform the indicated operation. And again, we're just going to be adding and subtracting some fractions. So we're going to start out with 3/7 plus 1/7 plus 2/7. So again, if you've watched all the videos up to this point, you know that when you add or subtract fractions, you have to have a common denominator. In this case, we already have one, and that's a denominator of 7. So for our answer, we have a denominator of 7. We just copy that common denominator. We don't mess with anything. We're done with that part. Now what we do is we perform the operation using our numerators. So we have 3 plus 1, that's 4. Then 4 plus 2, that's 6. So we get 6/7 as our answer. Now we always want to report our answer as a fraction that is simplified or reduced to its lowest terms. Now in this case, 7 is a prime number, and 6 is 2 times 3. So there's not really anything we can do to simplify this further. So 6/7 is our answer. All right, now we're going to look at 9/2 minus 3/2 minus 11/2. So again, we have a common denominator of 2. So when we look at our answer, we'll just put a denominator of 2, and then we'll just perform the operations using the numerators. So we'd start out with 9 minus 3, that's 6. Then we'd subtract away 11. So at this point, you might already know that 6 minus 11 is -5. But again, you can convert it and say, okay, 6 minus 11 is the same thing as 6 plus -11. We use the sign from the number with the larger absolute value. So we're going to have a negative here. And then we just do 11 minus 6, and that's 5. So we get -5 as our answer there. So once we've written it up here, we've got a -5 over a 2. So that's -5/2. And again, we're looking to simplify. Well, 5 is a prime number, and so is 2. So there's nothing we can really do. This is as simple as it's going to get. So our answer here is just -5/2. All right, let's take a look at 4/5 plus 3/5 minus 8/5 minus 7/5. So again, we have a common denominator of 5. So when we write our answer, the denominator will be 5. Now we just go through and perform the operations with the numerators, and we work left to right. Remember your order of operations, we work left to right with addition and subtraction. So we do 4 plus 3, that's 7. Then 7 minus 8. 7 minus 8, you can think of as 7 plus negative 8. Of course, the answer would be negative. And you would do 8 minus 7, that's 1. So you get negative 1. Then we're subtracting away 7 from that. So you can think of that as negative 1 plus a negative 7. Negative plus negative is negative. 1 plus 7 is 8. So we get negative 8 there. And our answer would be negative 8/5. Now again, we always want to look to simplify. Forget about the negative. 8 is 2 times 2 times 2. 5 is a prime number, so nothing we can cancel between numerator and denominator. And our simplified answer is negative 8/5. Hello and welcome to Pre-Algebra Test Section 4 on adding and subtracting fractions. So we just want to perform the indicated operation, and we're just going to be adding and subtracting here. So we're going to start out with 2/18 plus 5/20. Now again, you already know, if you've watched all the videos so far, that if you add or subtract fractions, you have to have a common denominator. So here we have a denominator of 18, here we have a denominator of 20. So before we can actually add, we have to change each fraction into an equivalent fraction, meaning it has the same value, but with a common denominator. So in order to do that, we find the least common denominator for these two fractions. So the least common denominator, which we abbreviate LCD, is going to be equal to the least common multiple, which we abbreviate LCM, of 18 and 20. So how do we find the LCM of 18 and 20? Well, we start by factoring each number. So 18 is going to be what? 9 times 2, 9 is 3 times 3. So 3 times 3 times 2. For 20, think about that as 4 times 5. 4 is 2 times 2. So 2 times 2 times 5. So we build the LCM from the prime factorizations. Basically, every prime factor from every prime factorization is going to go in. It's just when you have something that's common to both, you're only going to put in the largest number of repeats between those prime factorizations. So for example, with the number 2, I have one factor here and then 2 factors here. So because it's common to both, I use the largest number of repeats between either prime factorization. So I'm going to go with 2 factors of 2 because that's the largest number of repeats. So 2 times 2 here. Then next I have 3 times 3. It's not common to both, so I just put 2 factors of 3 in. Then I have a 5. That's not common to both, so I just put 1 factor of 5 in. So now all I have to do is multiply, and I'll have my LCM. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. Then 36 times 5 is 180. So once we've found the least common denominator, what we do is we rewrite each fraction as an equivalent fraction where 180 is its denominator. So if I look at 2 over 18, I know that if I multiply 18 by 10, I would get to 180. 18 times 1 is 18, then put a 0 at the end, you get to 180. So I'd multiply this denominator by 10. But again, to make this legal, I got to multiply the numerator by 10 as well. Remember, when we multiply by 10 over 10, we're basically multiplying by a complicated form of 1. 10 over 10 is 1. Multiply by 1, you leave the number unchanged. Now I'm going to do the same thing with 5 over 20. How do I go from 20 to 180? Well, I need to multiply by 9, right? 20 times 9, 2 times 9 is 18. Put a 0 at the end. So to make it legal, I multiply the numerator by 9 and the denominator by 9. And I'm just going to continue this down here. And let me just kind of erase this, make it a little easier for us to follow. So I'm going to put the LCD as 180, and I'm going to continue this down here. So I would multiply, 2 times 10 is 20. 18 times 10, we know that's 180. Then plus, 5 times 9 is 45. Over 20 times 9, I know that's 180. So now that I have a common denominator, my operation is relatively simple. I just use the common denominator as the denominator for my answer, and I just add the numerators. So we do 20 plus 45, and that's 65. But we're not done, because whenever we work with fractions, we always want to report our answer as a simplified fraction, or a fraction that's reduced to its lowest terms. So we would think about, what is the greatest common divisor between 65 and 180? And for 65 and 180, they're kind of big enough to where I would want to factor the numbers to make sure that I got the right answer. 65 is 13 times 5. And for 180, let's just go ahead and write this as 36 times 5. And I know 36 can be further broken down, but we can see that 13 is a prime number, and 36 is not divisible by 13, so really we can stop here, right? We can only cancel out a common factor of 5, meaning the greatest common divisor, or the greatest common factor for these two numbers, would be 5. So I'm left with my simplified result, a 13 in the numerator and a 36 in the denominator. So 13 over 36 is going to be my simplified answer. Okay, next let's look at 3 over 38 minus 2 over 133. So again, if we don't have a common denominator to start, we're looking for the least common denominator, and that's the lowest common multiple, or the least common multiple, between 38 and 133. So 38 would factor into 19 times 2. 19 is prime, and so is 2. For 133, I know we don't work with that number very often, but basically it's 19 times 7. Okay, so to build our LCM, again, everything goes in there, but when you have a factor that's common to both prime factorizations, you use the largest number of repeats. So I'm going to have a 2 times a 7 times only 119. Okay, don't put both of them in there, because the largest number of repeats, in each case, we only have one factor of 19, so I'm going to put 1 when I build my LCM. So what is 2 times 7? That's 14. Then times 19, that's going to be 266. Now we'll just rewrite each fraction as an equivalent fraction, where 266 is the denominator. So we have 3 over 38. And remember, 38 is 19 times 2. So to get to 266, I just need to multiply by 7, and I'm going to do that in the numerator as well, right? So I multiply by 7 over 7 so that it's legal, right? I'm multiplying by a complicated form of 1. Then minus, I have 2 over 133, and 133 was 19 times 7. So what I need to do is multiply this by 2 over 2, right? That would give me a denominator of 266. So again, let's continue this down here. And I'm going to just kind of erase this and put 266 here. And we'll multiply. 3 times 7 is 21 over, again, a denominator of 266. Then minus 2 times 2 is 4 over a denominator of 266. So 21 minus 4 is 17. And this is over 266. So again, we always want to report our answer as simplified. We know that 17 is prime, and we know the prime factorization of 266 is 2 times 7 times 19. So we don't have a 17 in there, so there's nothing we can do to further simplify this fraction. So 17 over 266 is going to be our simplified answer. Hello and welcome to Pre-Algebra Test Section 5 on adding and subtracting fractions. So we just want to perform the indicated operation, and we just have one problem. We're going to do 5 over 12 plus 4 over 21 plus negative 6 over 24. So again, when we add or subtract fractions, we have to have a common denominator to do that. So if we start out and we don't have a common denominator, we're first going to find the least common denominator, abbreviated as LCD, and this is equal to the least common multiple, abbreviated LCM, of your denominators. So we want the least common multiple of 12, 21, and 24. So we would factor each number to start. So 12 is 4 times 3, or 2 times 2 times 3. 21 is 7 times 3. 24 is 6 times 4, or we can think of that as 2 times 2 times 3 times 2. Now when I build my LCM, I'm putting every prime factor in for the prime factorization of the LCM. The only stipulation is if I have something that's common to in this case, at least 2 of the prime factorizations, what I'm going to do is I'm only going to put the largest number of repeats from any of the prime factorizations in there. So for example, if I look at the prime factorization of 12, I see I have 2 factors of 2. If I look at the prime factorization of 24, I see I have 3 factors of 2. So I'm going to put 3 factors of 2 in when I build my LCM. Some common mistakes would be to put 5 factors of 2 in there. You don't need that many. You would only put the largest number of repeats between the prime factorizations. So since this one has 2 factors of 2 and this one has 3 factors of 2, you go with 3 factors of 2 because that's the largest number of repeats. Next we have the number 3. 3 occurs here, here, and here. Now the most times it occurs is just once. So we're just going to put 1 factor of 3 in when we build our LCM. Again, if it's common to at least 2 of them, just use the largest number of repeats. Then lastly, we have this 7. The 7 is not common to anything. It's just in the prime factorization of 21. So we would just throw that guy in there. And now we just multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 7 is going to give us 168. So now that we know that our least common denominator is 168, what we're going to do is we're going to transform each fraction into an equivalent fraction where 168 is the denominator. So the way we do this, let's say we start with 5 over 12. You would just think about, what do I need to multiply 12 by to get to 168? Well, if you look at the prime factorization for 168, and you just kind of circle, okay, this is 2 times 2 times 3, that would give me 12. So what's left in here? I'd need 7 times 2 or 14. So if I multiply 12 times 14, I'd get to 168. Now, because I do this to the denominator, I have to do it to the numerator to make it legal. 14 over 14 is 1. If I multiply by 1, the number is unchanged. Next, we're adding. We have a 4 over a 21. Again, what do I need to multiply 21 by to get to 168? So if you look at 21, it's 7 times 3. So what I'd be missing is 2 times 2 times 2, or 8. So multiply this by 8 over 8, and your denominator will be 168. Then lastly, I have a negative 6 over a 24. If you look at 24, it's basically 8 times 3. So 2 times 2 times 2 times 3. So essentially I need to multiply by 7 over 7 so that my denominator will be 168. So 5 times 14 is 70. We know that 12 times 14 is 168. Plus 4 times 8 is 32. 21 times 8, we know that's going to be 168. Plus negative 6 times 7 is negative 42. Over 24 times 7, that's 168. And now we just add. So 70 plus 32. 0 plus 2 is 2. 7 plus 3 is 10. So I'd have 102. And I'm adding to that a negative 42. So the sign's going to be positive. And we just want to subtract 102 minus 42. 2 minus 2 is 0. And basically you'd have 10 minus 4, that's 6. So you'd have a positive 60 as your numerator. And then the denominator just stays the same, right? It's the common denominator here of 168. Now we're not done because we always want to simplify our fraction. And both numbers here are even. So at minimum, they're divisible by 2. Now I happen to know that 60 is divisible by 4, right? 60 divided by 4 is 15. So let's write 60 as 5 times 3, or 15, times 2 times 2, or times 4. And this is over 168 divided by 4 is 42. And again, kind of a quick way, if you look back at your scratch paper, you can see that if you had 2 times 2 here and you kind of box that off, what would be left is 2 times 3, that's 6, times 7 is 42. So you'd basically have 2 times 2 times 2 times 3 times 7. So now you can look and see what you can cancel between numerator and denominator. You can cancel 2 factors of 2 in the numerator with 2 factors of 2 in the denominator, basically canceling out a factor of 4. And then you can cancel out this factor of 3 from the numerator and denominator. So your greatest common divisor, or the greatest common factor between these two numbers, is 4 times 3, or 12. So if you knew that, you could divide 60 by 12 and get 5. And you could divide 168 by 12 and get 14. This works too, right? We canceled everything out and figured out that we get a 5 left in the numerator over 2 times 7, or 14 in the denominator. So we have 5/14, as our simplified answer. Hello and welcome to pre-algebra practice set number 34. In this video, we're going to look at some additional practice problems for our lesson on comparing fractions. Okay, so we just want to determine the rank of each fraction. So we basically just want to figure out what's the biggest, what's the smallest, so on and so forth. So let's start out with 4/9 and 3/8. So the first thing we're going to do is cross multiply here. And what that means is that we're going to take the denominator from this fraction and multiply it by the numerator of this fraction. So 9 times 3 is 27. So I'm just going to write 27 next to this fraction here. Then I'm going to do the same thing with this fraction. I'm going to multiply 8, the denominator of this fraction, by 4, which is the numerator of this fraction. So 8 times 4 is 32. So this number right here is going to correspond to this fraction right here. So let me just highlight this. I'm going to highlight this in blue and this in blue. And then I'm going to highlight this in yellow and this in yellow. So all we're looking for is the bigger number to tell us which fraction is larger. 32 corresponds to the 4/9. That's bigger than 27, which corresponds to 3/8. So we know that 4/9 is the bigger fraction. It's really that simple. Right? So 4/9 is greater than 3/8. If you didn't watch the lesson, you might be scratching your head saying, hey, why in the world does that work? Well, let me kind of show you something real quick. If we have 4/9 and we have 3/8, kind of the slow, tedious way to do this would be to convert each fraction into an equivalent fraction where the denominator is the same. So generally, we'll transform these two fractions into equivalent fractions where the LCD is their denominator. But really, you don't even have to do that. Any common denominator you can find will work. And kind of the quickest common denominator to find is to use the product of the two denominators. So 9 times 8 is 72. That would kind of be the quickest common denominator you would find. In this case, it happens to be the least common denominator as well. So in order to get 72 as my denominator, I would multiply this fraction, top and bottom, by the denominator of the other fraction. So 8/8. I would multiply this fraction, top and bottom, by the denominator of the other fraction. So 9/9. So 4 times 8 is 32. 9 times 8 is 72. 3 times 9 is 27. 8 times 9 again is 72. So now we saw these numbers before. We saw 32 up here that corresponded to 4/9, and you can see that you have that 32 next to the 4/9. And we saw 27 next to 3/8, and you can see that still corresponds here. Basically, we got the information we needed without going through all this. By taking this denominator from the other fraction and multiplying it by the numerator, I find out what the numerator would have been if I went through this process. And same goes for here. I find out what the numerator would have been if I go through this process. So it's a shortcut to kind of say, okay, 32/72 is larger than 27/72. So the one with 32/72, or from 4/9, is going to be larger. Right? We've just shortcutted the process, and we're only looking at the numerator because we know the denominators would be the same. All right, so let's look at 15/22 and 3/4. So 15/22 and 3/4. And again, all we need to do is cross multiply. 22 times 3 is 66. 4 times 15 is 60. 66 is a bigger number, so that tells me that 3/4 is a greater fraction. So we can put that 15/22 is less than 3/4. What about 5/18 and 6/21? Again, we cross multiply. 18 times 6 is 108. 21 times 5 is 105. So 108 is the larger number. So that tells me 6/21 is the larger fraction. So 5/18 is going to be less than 6/21. What about 3/45 and 1/15? So 3/45, and we have 1/15. So 45 times 1 is 45. 15 times 3 is 45. So we've come to the scenario where we've found fractions that are equivalent, or basically they have the exact same value. If I have 3/45 and I divide the numerator and denominator by the greatest common divisor of 3, 3 divided by 3 is 1, 45 divided by 3 is 15, I see that I do in fact get 1/15. So these fractions have the same value, they just look different. So 3/45 is equal to 1/15. What about 5/6 and 14 over 24. Again, we cross multiply. 6 times 14 is 84. 24 times 5 is 120. Obviously, 120 is bigger than 84, so 5/6 is the greater fraction. 5/6 is greater than 14 over 24. All right, let's look at one final problem where three fractions are involved. So I would start by just comparing any two fractions. Doesn't really matter which ones you start with. So 5/9 and 12/17. 9 times 12 is 108. 17 times 5 is 85. So we know 12/17 is larger than 5/9. So now let's compare 5/9 and 8/15. So 9 times 8 is 72. 15 times 5 is 75. So 5/9 is greater than 8/15. So if 5/9 is smaller than 12/17, but it's larger than 8/15, then we know that 8/15 is the smallest number. So we can just go ahead and write greater than 8/15 here. Because again, if 8/15 is smaller than 5/9 and 5/9 is smaller than 12/17, it tells me that 8/15 is smaller than 12/17. So kind of looking at this, 12/17 is the largest, and it's greater than 5/9, which is smaller than 12/17 but greater than 8/15. And 8/15 again is smaller than both 5/9 and 12/17. Hello and welcome to Pre-Algebra Test Section 1 on comparing fractions. So we want to replace each question mark with the less than, greater than, or equals to. So we're going to start out with 4/5 question mark 8/10. So in the lesson, I kind of gave you a shortcut to do this. I told you that you can take the denominator of one fraction, which in this case for 4/5 is 5, and you can multiply by the numerator of the other fraction. So 5 times 8 will give me 40, and I just write that right next to that fraction. And I do it to the other one. So the denominator of this fraction is 10, multiplied by the numerator of this fraction, that's 4. 10 times 4 is 40. Now I just compare the two numbers, and basically, in this case, we have 40, and we also have 40, so we know the two fractions are equal in value. So we'd say 4/5 is equal to 8/10. You can kind of eyeball these fractions and see they're the same. If I took 4/5 and multiplied it by 2 over 2, I would end up with 8 over 10, right? So it's the exact same fraction. This one is just simplified. Now, if you don't understand why this works, I kind of, again, explained this in the lesson. What we're doing here is we're just using a little shortcut. If I had 4/5 and I had 8/10, generally the method you're going to use is you're going to rewrite the fractions as equivalent fractions where you have a common denominator, and then you're going to look to see which numerator is bigger to tell you which fraction is bigger. Now, when you do these type of problems, you don't always look for the LCD. Usually it's a little quicker if you just say, okay, I can get a common denominator by just taking the denominator of one fraction and multiplying it by the denominator of the other fraction. 5 times 10 is 50. So my common denominator, not my least common denominator, but just a common denominator, could be 50. So all I would do is multiply the numerator and denominator here by the denominator of the other fraction. So I'd multiply this by 10 over 10, and I'd multiply this by 5 over 5. And in each case, I'm going to get this common denominator of 50. So once I do 4 times 10, I'm going to get 40. That's what I did here, right? 10 times 4. I just kind of did it in a different way. Once I do 8 times 5, I'm going to get 40. That's what I did here. 5 times 8, I got 40. So essentially, I'm shortcutting this process here with this cross multiplication. I don't really need to know what the new denominator is going to be. I just know that they're going to be the same. So I can kind of skip all this and just cross multiply. I know that to get the new numerator, I'm going to be multiplying by the denominator of this fraction, right? This times this will give me the new numerator for this fraction. This times this will give me the new numerator for that fraction. So that's kind of why that shortcut works. All right, let's look at 2/3 question mark 4/7. Again, what we're doing is we're cross multiplying. So we're going to take this denominator, multiply by this numerator. 3 times 4 is 12. Then I'm going to take this denominator, which is 7, multiplied by this numerator, which is 2. 7 times 2 is 14. So 14 is larger than 12, so that tells me 2/3 is the bigger fraction. So 2/3 is greater than 4/7. And again, if I don't went through the long process of multiplying 2/3 by the denominator of the other fraction, 7 over 7, I would end up with 2 times 7, which is 14. Again, that's what I got there. And then 3 times 7 would be 21. So this would be 14 over 21. If I multiplied 4 sevenths times the denominator of this fraction, 3, so 3 over 3. 4 times 3 is 12. Again, that's what I got there. So 12 over 21. Again, the denominator is going to be the same. So I only need to think about what the numerator would be. So that's why we cross multiply and say, okay, the numerator would be 14 here, and the numerator over here would be 12. 14 is greater than 12, and so 2/3 is going to be the greater fraction. All right, what about 3/11 question mark 3/7? So again, we're just going to cross multiply. So 11 times 3 is 33, and 7 times 3 is 21. 33 is larger, so that means 3/11 is the smaller fraction. So 3/11 is less than 3/7. Again, if you went through and you multiplied 3/11 by 7 over 7, right? The denominator from the other fraction is 7. 3 times 7 will give you 21, right? So the new numerator for 3/11 would be 21. Now, the denominator would be 77. But again, because we know the denominator is the same, we don't really care what it is. We're only going to be looking at what the new numerator would be. For this one, 3 over 7, we'd be multiplying by 11 over 11. So 3 times 11 is 33. 7 times 11 again is 77. And again, if you look at these two fractions, they have the same denominator. This numerator is bigger, so it's the bigger fraction. Now another thing you could think about here, without even cross multiplying, you can look at these two fractions here. Since they have the exact same numerator, the rule is if you have the same numerator and a bigger denominator, you have a smaller fraction. So 3 divided by 11 is going to give you a smaller number than 3 divided by only 7. As we divide by larger and larger numbers, our result gets smaller and smaller. I'm taking the same amount and cutting it up into more pieces, and so I get a smaller value as a result. Hello and welcome to Pre-Algebra Test Section 2 on comparing fractions. All right, so we just want to replace each question mark with the less than, greater than, or equal to. So we start out with 31 over 50, question mark 12 over 21. So the quickest way to compare these two fractions is to cross multiply. So we're going to take the denominator from this fraction and multiply it by the numerator of this fraction. So what is 50 times 12? Well, we have a trailing 0 here, so I can do 5 times 12, that's 60, and then just put a 0 at the end of that, so that would be 600. Then next we want to do 21, the denominator of this fraction, times 31, the numerator of the other fraction. So what is 21 times 31? Let's just crank that out real quick. 1 times 31 is 31. 2 times 1 is 2. 2 times 3 is 6. Bring down the 1. 3 plus 2 is 5. Bring down the 6. So this is 651 over here. So whichever fraction has the bigger number next to it is the larger fraction. So 651 is bigger than 600. So that tells us that 31 over 50 is greater than 12 over 21. What about 9/8 question mark 14/11? So again, we're going to cross multiply. We're going to take 8 and multiply it by 14. That's going to give us 112. And then we're going to take 11 and multiply it by 9. And that's going to give us 99. So 112 is the bigger number. So 14 over 11 is the larger fraction. So we're going to say that 9/8 is less than 14 over 11, or again, 14/11. Hello and welcome to Pre-Algebra Test Section 3 on comparing fractions. So we want to replace each question mark with the less than, greater than, or equal to sign. So we start out with -4/15, question mark -2/7. So when you start comparing negative fractions, you have to think about the fractions in terms of their absolute value first. So just pretend that these numbers are positive. So let's say we had 4/15 and we had 2/7. So to find out which one is bigger, we would cross multiply. We would take the denominator of this fraction and we multiply by the numerator of this fraction. So 15 times 2 would give me 30. Then I'd multiply the denominator of this fraction, 7, times the numerator of this fraction, 4. 7 times 4 is 28. Now I know that this is the bigger fraction because 30 is a bigger number. So 2/7 is larger. So let's just go ahead and write that 4/15 is less than 2/7. Now, a lot of you might jump in and say, okay, well, -4/15 is less than -2/7. That would be wrong, right? This would be wrong. Here's why. When you work with negatives, the bigger the negative, the smaller the number. So if I had something like, let's say, 3 and 7, the relationship would start out like this. 3 is less than 7. But if I made these numbers negative, if I had -3 and -7, the reverse would be true. -3 is now a greater number, right? -3 would be greater than -7 because it's a smaller negative. Again, as we look at a number line, as we go to the left and these negatives get bigger and bigger, your values are actually becoming smaller. So for this example, since 4/15 is smaller than 2/7, when we make these numbers negative, -4/15 is going to be larger than -2/7 because this is going to be a smaller negative and therefore a larger number. All right, let's take a look at another one. We have -7/11 and -5/8. And again, what I'm going to do is pretend these numbers are positive. So we have 7/11 and 5/8. We'll cross multiply. 11 times 5 is 55. 8 times 7 is 56. So this is the bigger fraction, 7/11. So 7/11 is greater than 5/8. But again, when you start talking about them being negatives, the reverse is going to be true. So -7/11 is going to be a smaller number because, again, it's going to be a bigger negative. So this is less than -5/8. Hello and welcome to Pre-Algebra Test Section 4 on comparing fractions. All right, so we just want to arrange each group from smallest to largest using inequality symbols. So we have the fractions 4/5, 11/15, and 5/7. So we can start by just comparing any two fractions that we want. Let's start with 4/5 and 11/15. So I'm going to cross multiply. 5 times 11 is 55. 15 times 4 is 60. So that tells me that 4/5 is the larger fraction. So 4/5 is greater than 11/15. So let me then compare 11/15 and 5/7. So 11/15 and 5/7. So 15 times 5 is 75. And 7 times 11 is going to be 77. So 11/15 is going to be the bigger fraction. So 11/15 is bigger than 5/7. So if I know 11/15 is smaller than 4/5, and if I know it's bigger than 5/7, then I know 5/7 is the smallest one. I know 11/15 is the middle one, and I know 4/5 is the largest one. Now it told us in the directions that we wanted to arrange each group from smallest to largest using inequality symbols. We don't have that here. We have largest to smallest. So we just need to flip it around and say that 5/7 is less than 11/15, which is less than 4/5. Hello and welcome to Pre-Algebra Test Section 5 on comparing fractions. All right, so we want to arrange each group from smallest to largest using inequality symbols. So for the group, we have 2/3, 8/21, 4/7, and 3/5. Now, in some examples, you might see me comparing two fractions at a time until we kind of figure out the relative size of each fraction. I think when you have more than 3, it's probably quicker just to figure out what the LCD is and then change each fraction into an equivalent fraction where the LCD is its denominator. Once we have the same denominator in each case, we can just look at the numerators and see which fraction is the largest, the second largest, the third largest, and then the smallest. Let's go ahead and just get the LCD. So we have the denominators of 3, 21, 7, and 5. So the LCD, remember, is the least common multiple of the denominators. So for 3, 21, 7, and 5. So 3 doesn't factor, so we'll just put it in there. 21 is 7 times 3. I already have a 3, so I just put times 7. 7 is already in there. It doesn't factor. And then I'll just throw in a 5. So 3 times 7 is 21. 21 times 5 is 105. So for 2/3, I would multiply by 7 times 5, or 35, over 35, so that I can have a denominator of 105. But again, kind of, if you think back to the cross-multiplying shortcut, I don't need to know what the denominator is going to be, because I know in each case I'm going to get a denominator of 105. So save yourself a step and just say, okay, what is 2 times 35? That's 70. So I'm just going to write a 70 next to this fraction, because if I converted it into an equivalent fraction with 105 as denominator, 70 would be its numerator. All right, for the next one, I have 8 over 21. 8 over 21. So I would multiply that. If I had 7 times 3 is 21, I'd multiply it by 5 over 5. So again, just multiply the numerator by 5. 8 times 5 is 40. I'm going to write that next to that number right there. Then for 4/7, if the denominator is 7, I'd need to multiply by 3 times 5, or 15. So this would get multiplied by 15 over 15. Again, to save myself a step, I'm just going to multiply the numerator. 4 times 15 is 60. And then lastly, I have 3/5. 3/5. So that 5 there, I just need to multiply by 21 over 21. Again, save myself a step. 3 times 21 is 63. So now if I look at these fractions here, I can see that if I had changed them into equivalent fractions where 105 is the denominator, I'd have 70 over 105. I'd have 40 over 105. I'd have 60 over 105. And I'd have 63 over 105. And once I have the same denominator, it's very easy to see the relative size of the fractions. I know that this one is the largest. I know that this one is the smallest. I know that this one is the kind of second largest. And then this would be kind of the third largest. Or you could say the second smallest. I don't know. Third largest. So if we kind of ordered them 1 through 4, with 1 being the largest, this would be 1, this would be 2, this would be 3, and this would be 4. Now, if we look back at our instructions, it says arrange each group from smallest to largest using inequality symbols. So your smallest fraction here, again, if you look at the numbers, the 4th fraction is the smallest one. So that's 40 over 105, or the original fraction that we started with, 8 over 21. And that's going to be less than, if you look at the number 3, we have 60 over 105, which the original fraction was 4/7. That's going to be less than. Then we look at number 2, we have 63 over 105. The original fraction there was 3/5. And then kind of the largest fraction, the number 1, we have 70 over 105. And again, the original fraction was 2/3. And when you look at inequalities this way, everything has to work. So this has to be the smallest fraction because it's less than everything, right? 8 over 21 is less than 4/7, which is less than 3/5, which is less than 2/3. So this has to be the smallest. Then this 4/7 has to be greater than 8 over 21, but less than 3/5 and 2/3, and it is. 3/5 has to be greater than 4/7 and 8 over 21, but less than 2/3. That works. And then 2/3 has to be greater than 3/5, 4/7, and 8 over 21. And of course it is. So kind of our answer here, based on our instructions, is to write that 8 over 21 is less than 4/7, which is less than 3/5, which is less than 2/3. Hello and welcome to Pre-Algebra Practice Set number 35. In this video, we're going to look at some additional practice problems for our lesson on ratios and rates. So we want to start out with a simple exercise, and we're going to just write each ratio as a fraction and simplify. So our first ratio is the ratio 25 to 60. So remember, there's a few different ways we can write a ratio, and one of those ways is with a colon. So we're going to just write this using a fraction, and then we're going to simplify the fraction just like we normally would. So this leftmost number, this 25, is going to be the numerator for the fraction. The colon, we're going to put a fraction bar, and then the 60, the rightmost number, is going to be our denominator. Now, just like we always would, we would find the greatest common divisor, or the greatest common factor, between 25 and 60, and we would divide the numerator and denominator by that number. So for 25, it's going to factor to 5 times 5. And for 60, it's going to factor to, we could start with 5 times 12. And I don't really need to break it down any further, but I can just for a sense of completeness. 12 is 4 times 3. 4 is 2 times 2. So 2 times 2 times 3. But you can see that nothing in the prime factorization of 12 is going to cancel with the prime factorization of 25, right? You can't really do anything. All I can really do is cancel this 5 with this 5. That's why I was saying we can kind of stop when we get to 5 times 12. So what I'm left with is a 5 in the numerator and a 2 times 2 times 3, or a 12 in the denominator. And so our ratio is 5 to 12, right? And if you want to, you can go back. I know the instructions didn't say to, but you can go back and rewrite it using a colon, saying 5 to 12. What about the ratio 3 to 9? Again, my leftmost number is going to be in my numerator. Then my colon, I'm going to put a fraction bar, and then 9 is going to be my denominator. And if I look at 3 and 9, I know that the greatest common divisor is a 3, right? 3 divided by 3 is 1. 9 divided by 3 is 3, right? Or I can just think about it as, hey, I'm canceling a common factor of 3 between the numerator and denominator. So my simplified ratio, I'll have a 1 in the numerator, a 3 in the denominator. So we'd say it's 1 to 3, right? Or we could write it again using a colon, 1 to 3, like that. Okay, let's look at the ratio 42 to 14. Again, this 42 is going to go in the numerator. I'm going to put a fraction bar where my colon is, and then I'm going to have a 14 in the denominator. Now, the greatest common divisor between 42 and 14 is going to be 14. Because if I take 42 and divide by 14, I'm going to get 3, right? But again, if you want to kind of get a sense of completeness, you can factor 42 completely. It's 7 times 2 times 3. 14 is 7 times 2. And just cancel the common factors between numerator and denominator. Cancel this 7 with this 7, this 2 with this 2. Again, I've just removed a factor of 14 from the numerator and denominator. And I'm left with a 3 here. And remember, when something cancels completely, you put a 1 there. Now, we end up with the ratio 3 to 1. If you get something like 3 over 1 or 2 over 1, or if you have 1 as your denominator, you leave it. Okay, I know when we just work with fractions, if we have 3 over 1, we just say, okay, that's equal to 3. When you're working with ratios, you're usually describing two quantities. So you want to leave the 1. If I have the ratio 3 boys to 1 girl, I want to leave that 1 there because it's describing something, right? I want to leave it there. So again, I could write this using a colon, just 3 to 1. All right, but what about the ratio 46 to 23? So again, writing this as a fraction, 46 will be in the numerator. The colon will put our fraction bar, and then 23 will be in the denominator. And we know that 46 divided by 23 is 2, so the greatest common divisor between these two would be 23. So if I think about dividing 46 by 23, I would get 2. Divide 23 by 23 and you get 1. So you get the ratio 2 to 1. And again, I have a 1 in my denominator. I know when we work with fractions, we would just write that as 2. When you're working with ratios, leave that in the denominator. Just say, okay, the ratio is 2 to 1. Or again, with a colon, 2 to 1, like that. All right, let's take a look at a word problem. So a playset contains 5 red marbles for every 3 green marbles. If the playset contains 32 marbles, how many are red and how many are green? So the first thing you want to do when you see this type of problem is write the ratio of red marbles to green marbles. So red marbles to green marbles. And again, we have 5 red for every 3 green, so this ratio is going to be 5 to 3. Now the next thing you're going to do is just add these two numbers together. So what is 5 plus 3? That's 8. And the reason you add these two together is you basically make one group. So one group contains 8 marbles. And in this group that contains 8 marbles, you're going to have 5 red marbles, and you're going to have 3 green marbles. And again, we know that from our ratio. If you have 5 red for every 3 green, when you have 8 marbles, that means you have 5 red and 3 green. The trick to figuring out this problem is just finding out how many of these groups you can make with the total number of marbles. So coming back up here, we see that we have 32 marbles in the play set. So basically all we would do is divide 32 by 8 to figure out how many of these groups we can make. All right, 32 is your total number of marbles. We divide that by 8, which is the number of marbles in one group, and we get 4. So that tells me the number of groups we can make, right? The number of these groups that we can make. So once we know that, all we need to do is multiply our numbers by 4, and we'll have our answers. So in other words, I just take the numbers from this one group and multiply them by 4 because I'd have 4 of those groups. So 5, the number of red marbles in one group, times 4, the number of groups, would give me 20. So in 4 groups, I would have 20 red marbles. So we're going to have 20 red marbles. Next, I would take 3, the number of green marbles I have in one group, multiply it by 4, the number of groups we're going to have, and we get 12. So we're going to have 12 green marbles. And we know that 20 over 12 is an equivalent fraction to 5 over 3 because all we really did was multiply this by 4 over 4. So our answer here is that out of 32 marbles, 20 marbles will be red and 12 marbles will be green. Now we want to look at finding some unit rates. So we're going to start out with what is the unit rate in miles per gallon. So the scenario is traveling 600 miles on 50 gallons of gas. So what we do to find the unit rate here, essentially we would set up a fraction where we have 600 miles in our numerator, and we're going to put 50 gallons in our denominator. So this is our rate. But again, we want to find the unit rate. So what we do is we take our number in the numerator, which in this case is 600, and we divide it by our number in the denominator, which in this case is 50. So if I had 600 divided by 50, I've already taught you at this point that you can cancel a 0 with the 0 here when you have a fraction, right? You're basically just removing a factor of 10 between the numerator and denominator. That makes it simple because then you're looking at 60 divided by 5, and we know that's 12. So the numerator will be 12, and I'm going to put miles. The denominator, I know when we have 12 over 1, a lot of us will just write 12, but when you're working with ratios or rates, you always put your denominator even if it's 1 because we're talking about a comparison. So we would have 12 miles to 1, and instead of being plural, it's now singular, so to 1 gallon, 1 single gallon. So traveling 600 miles on 50 gallons of gas, the unit rate here in miles per gallon is 12 miles per 1 gallon of gas. This is one we should all be very familiar with. What is the unit rate in dollars per hour? So someone goes to their job and they're earning $75 in 5 hours. What do they make per hour? So we're going to set this up using a fraction. So we would have $75 in our numerator. In the denominator, we're going to have 5 hours. And all we need to do is basically divide the number in the numerator by the number in the denominator. So 75 divided by 5 is 15. So you'd have $15. And the denominator, since I divided by 5, the denominator is now 1. And instead of hours, I'm going to write hour. Right, I'm now going to have a singular form of that word. So now I find that if you're earning $75 in 5 hours, you're earning $15 per 1 hour, right? Or $15 for every 1 hour worked. All right, for the last problem, let's suppose that you visit a spa and you're given 2 different packages. So you want to find which is cheaper on a per visit basis. You have one option that says you can pay $144 for 12 sessions, and another option that says you can pay $195 for 15 sessions. So we want to find the unit rate for each so that we can compare the cost per visit. So in each case, I'm just going to set up a little fraction with the amount charged in the numerator. So in this case, it'd be $144. And the number of sessions in the denominator, so 12 sessions. Now all I need to do is divide the number in the numerator by the number in the denominator, and I'll have my unit rate. So 144 divided by 12 is 12. So this would be $12 per one session, right? One session. And I'll just write that here. This is $12 per session. All right, the next thing I'll look at is this one, $195 for 15 sessions. So $195 per 15 sessions. Now, if I divide 195 by 15, I get 13. So this would be $13 per one session. So let me write that here. So obviously, this one is going to be the better bargain. All right, $144 for 12 sessions is going to result in a cost of $12 per session. Again, that's cheaper than if you pay $195 for 15 sessions because you're paying $13 per session or $1 more per session. So we can just write that $144 for 12 sessions is the better bargain. Hello and welcome to Pre-Algebra Test Section 1 on ratios and rates. All right, so we just want to write each ratio as a fraction and simplify. So we start out with the ratio 8:4. So to write this as a fraction, we take the left part, which is 8, and we write it as the numerator. Then your colon here, we're going to write that as a fraction bar, and then the 4, the right part, is going to be in the denominator. Once you have it as a fraction, you use your normal procedure to simplify a fraction. If you look at 8 and 4, really I know that this is division. 8 divided by 4 is 2, but you can kind of just think about it as canceling a common factor of 4 between the numerator and denominator, and you'd end up with 2 over 1. Now, in a lot of cases, if you have 2 over 1, you're working with fractions, you would simplify that and write it just as 2. When you're working with ratios, you want to leave your denominator of 1 if you have that. And the reason is because you're talking about the relationship between two things. So it might be that I have 2 boys for every 1 girl. It might be that I have 2 sodas for every 1 bag of chips. You know, so on and so forth. So you want to put that 1 there and leave it there. Next, we're going to look at 16 to 24. So again, this left part here, 16 is going to go in the numerator. You'll have your fraction bar. Then the right part, 24, is going in the denominator. And the greatest common divisor between 16 and 24, if you think about 16, it's basically 2 to the 4th power. So the prime factorization contains only 2's. If you think about 24, it's 3 times 8, and no, 8 is 2 to the 3rd power. But essentially, what you're going to do is think about the greatest common divisor as 8, right? So 16 divided by 8 would be 2. 24 divided by 8 would be 3. So my simplified ratio would be 2 to 3. And again, all I did was I took 16 and I said, okay, it's 2 times 2 times 2 times 2. I took 24 and said 2 times 2 times 2 times 3. And I canceled the greatest common divisor, or again, the greatest common factor between the two numbers, right? That's going to be 8, right? 3 factors of 2. So I'm left with a 2 in the numerator and a 3 in the denominator. Again, that gives me a ratio of 2 to 3. What about 15 to 75? Well, I'm going to write this as 15 in the numerator over 75 in the denominator. And 75 is divisible by 15. So that means the greatest common divisor here is 15. So divide 15 by 15, you get 1. Divide 75 by 15 and you get 5. So this ratio is going to be 1 to 5. Next, we look at the ratio 100 to 10. So as a fraction, we'll put 100 in the numerator, 10 in the denominator. And we know that 100 is divisible by 10. 100 divided by 10 is 10. So this is going to simplify to 10 to 1. And again, when you have a 1 in the denominator and you're working with ratios, you have to leave it there because we're talking about a relationship. I might talk about the relationship of 10 red marbles to 1 blue marble. I might be talking about 10 students for every 1 teacher, so on and so forth. For the last one, I have the ratio of 12 to 3. So 12 is going to go on my numerator. 3 is going to go on my denominator. And we know that 12 is divisible by 3. 12 divided by 3 is 4. So essentially, this is just going to be 4 over 1. And again, if we're working with ratios and we have a 1 in the denominator, we just leave it there. So this is the ratio 4 to 1. Hello and welcome to Pre-Algebra Test Section 2 on ratios and rates. So a field trip contained 35 girls and 15 boys. We want to start out by asking, what is the ratio of boys to girls? So what is the ratio of boys to girls? Well, how many boys did I have? I had 15 boys. 15. And this is going to be over how many girls I had, which is 35. And when we work with a ratio, we always want to simplify. So to simplify, all we're going to do is divide the numerator and denominator by the greatest common divisor or the greatest common factor. 15 is 5 times 3. 35 is 5 times 7. So the greatest common divisor here is 5. 15 divided by 5 is 3. And 35 divided by 5 is 7. So the ratio of boys to girls would be 3 to 7. Meaning we had 3 boys for every 7 girls. Now the next question it asks is, what is the ratio of girls to boys? So if I already know what the ratio of boys to girls is, and remember we found that boys to girls was 3 to 7, all I have to do is flip that, right? Because I'm just flipping this. I'm just saying, okay, what is girls to boys? Well, I would just flip this over and say, okay, well, it's 7 to 3, right? 7 girls for every 3 boys. And I can write that in a nice little sentence. So there were 7 girls for every 3 boys. Let's take a look at another one. So a football team had a win-loss ratio of 5 to 1. If they played a total of 12 games, how many were won and how many were lost? So again, the win-loss ratio is 5 to 1, meaning they won 5 games for every 1 that they lost. Now, if you kind of think about this as 5 plus 1 equals 6, 6 would be one group. 6 is one group, okay? And in one group, we have 5 wins and we have 1 loss. Now, how many equal groups of 6 can we make out of 12? Well, we can make 2, right? 12 divided by 6 is 2. So I know that I would have 2 of these groups. So all I need to do to figure out how many wins they had is multiply 5, the number of wins they had in one group, by 2, the total number of groups I can form with their 12 games. So 5 times 2 would give me 10. This is the number of wins in 12 games. And then for the number of losses in 12 games, I would take the number of losses they have in one group, multiply it by the number of groups. So 1 times 2 would give me 2. 1 times 2 equals 2. And this is the number of losses in 12 games. So if we want, we can make a nice little sentence. Again, how many were won and how many were lost? We could just say that the team won 10 games and lost 2 games. Hello and welcome to Pre-Algebra Test Section 3 on ratios and rates. Okay, so on a church trip, there are 4 boys for every 3 girls. If there are a total of 48 boys on the trip, how many girls are there? So this problem is actually a lot simpler than it seems. The first thing you want to do is just write the ratio of boys to girls. So boys to girls. We know this is going to be equal to 4 to 3. 4 boys to every 3 girls. If we're told that there's a total of 48 boys on the trip, just think about if I said, okay, this is going to be equal to 48 over something. Now we know when we work with fractions that we can get equivalent fractions by multiplying the numerator and denominator by the same number. What do I multiply 4 by to get to 48? Well, I multiply by 12. So if I multiply 12 by the denominator, I would get an equivalent fraction. 3 times 12 would give me 36. So now I know that I had 48 boys on the trip and 36 girls. So to answer my question here, I would just say there were 36 girls on the trip. Hello and welcome to Pre-Algebra Test Section 4 on ratios and rates. So we want to find each unit rate, and we're going to start out with a meal that contains 220 calories with 22 grams of fat. So we're going to find the unit rate for calories per gram of fat. So we're going to set up a little fraction here, and we're going to put 220 calories in the numerator, and we're going to put 22 grams of fat in the denominator. And essentially when you're finding a unit rate, you take the number in the numerator, you divide it by the number in the denominator. So 220 divided by 22 is pretty easy to do. If you recognize that 22 times 10, right, you take 22, put a trailing 0 at the end, so you'd have 220. So if you just reverse that, 220 divided by 22 is going to give you 10. Then you'd have calories. The denominator is going to be a 1. And then this is just going to be a singular form of this. So instead of grams of fat, you would put gram of fat. So now our unit rate is that we have 10 calories per every 1 gram of fat for this meal that we're eating. All right, next we're looking at traveling 320 miles on 20 gallons of gas. So again, set this up as a fraction. I'm going to put 320 miles in the numerator, and I'm going to put 20 gallons of gas in the denominator. And I'm trying to find the unit rate where I know how many miles per 1 gallon of gas, or you might hear this often as your mileage per gallon, right? How many miles per gallon does your vehicle get? So divide 320 by 20. Well, there's a trailing 0 in each case, so I can just cancel that out. I'm just removing a factor of 10. And then essentially I'd have 32 divided by 2, that's 16. So this would be 16 miles per 1 gallon. 1 gallon of gas. Hello and welcome to Pre-Algebra Test Section 5 on ratios and rates. So we want to find each unit price, and I have here that's the price for 1 unit, and state the best deal. So we're going to look at each unit price again and find out what is the better cost per 1. So for example, when we look at 46 flash drives for $92, we're going to compare it to how much it is for 1 flash drive versus if we bought 12 flash drives for $36, right? In each case, I'm looking at the price per unit or the price for 1 flash drive. So essentially, I'm going to do $92 per 46 flash drives to get the price per unit there. What is 92 divided by 46? Well, that's going to give me 2. So this essentially means that I have $2 per 1 flash drive. So these are $2 each, you could say. Then the other one is we have $36 for 12 flash drives. We know that 36 divided by 12 is 3. So these are going to be $3 per 1 flash drive, or $3 each. Okay, $3 each. So what's the better deal? Well, obviously, if I buy 46 flash drives for $92, I'm paying $2 each. That's the better price per unit. It's the better deal. So we can just say that the better deal is 46 flash drives for $92. All right, the next one we're going to look at is 8 ink cartridges for $120 versus 23 ink cartridges for $368. So again, we're finding the price per unit or the price per ink cartridge. So $120 per 8 ink cartridges. So what's 120 divided by 8? Well, it's going to be 15. So this would be $15 per 1 ink cartridge. So these are $15 each. And then the other scenario would be that you pay $368 for 23 ink cartridges. So what is 368 divided by 23? We'll do that down here. 23 goes into 36 once. 1 times 23 is 23. Subtract here, you would get 13. Bring down the 8. 23 is going to go into 138 6 times. 6 times 23 is 138. Subtracting gets 0. So these are going to be $16 each, right? $16 per 1 ink cartridge. So $16 each. And we can see that 8 ink cartridges for $120 is the better deal, right? I only have to pay $15 each versus $16 each. So we would say that the better deal is 8 ink cartridges for $120. Hello and welcome to Pre-Algebra Practice Set number 36. In this video, we're going to look at some additional practice problems for a lesson on proportions. All right, so we want to use the equality test for fractions to determine if the fractions are equal. So remember, the equality test for fractions tell us that two fractions are equal if their cross products are equal. So we're going to start out with 3/15 is equal to 12 over 60. So to determine if this is true, we're going to find the cross products. So start with the denominator of this fraction times the numerator of this fraction. So what is 15 times 12? That's going to be 180. And then what is 60 times 3? Well, that's also going to be 180. So because the cross products are equal, the fractions are equal. So yes, these two fractions are equal. All right, for the next problem, we have 1/9, and we want to see if this is equal to 4 over 63. Again, we're going to find the cross products. So we're going to multiply 9 times 4, that's 36, and then 63 times 1, that's 63. So 63 and 36 are not equal, so no, these two fractions are not going to be equal. Here we have 57 over 57, and we want to see if this is equal to 319 over 319. For something simple like this, we don't need to form the cross products. We know that 57 over 57 is 1. We know that 319 over 319 is 1. So really we have the question, is 1 equal to 1? And the answer to that is yes. We know that 57 times 319 would be equal to 319 times 57. We don't need to go through and work that problem. So now we have 7 over 28, and we want to know if that's equal to 2/8. So again, form the cross products. So 28 times 2 is 56, and so is 8 times 7, that's also 56. So these two numbers are the same. So yes, these two fractions are going to be equal. So is 5/12 equal to 25 over 40? Again, find the cross products. So multiply 12 times 25, that would give us 300. Multiply 40 times 5, that would give us 200. 200 is not equal to 300, so this is a no. Okay, so we want to determine if we have a proportion here. And again, when we have a proportion, we have two ratios or two rates that are equal. So when we look at this first problem here, we see 3/7, and we want to know if that's equal to 9 over 21. Now, remember, when you work with ratios, you can write them as fractions. So really, I could just treat these as ratios. I could say, this is the ratio of 3 to 7. This is the ratio of 9 to 21. So we can see if these two ratios, or two fractions, are equal. And if they are, then we'd have a proportion. So again, we want to just find the cross products. So 7 times 9 would be 63. And 21 times 3. 21 times 3 is also 63. So yes, this is a proportion. So now in this problem, we have the ratio 500 words to 50 minutes. And then this ratio is 15 words to 3 minutes. So for this type of problem, you want to check the numerator and make sure that you have the same thing. So we have words here and words here. So that's the same. In the denominator, we have minutes and then minutes. That's the same. So once you've done that, you can just cross multiply the numbers. If the numbers are equal, then you have a proportion. So in other words, I would take 50 and multiply it by 15. 5 times 15 is 75. Put a 0 at the end, that's 750. Then 3 times 500 would be 1,500. So these two are not equal, right? We do not have a proportion. Not a proportion. And if you want to think about this, these are basically rates. So if I wanted to transform each into a unit rate, I can see that they're not a proportion because 500 words being typed in 50 minutes, 500 divided by 50 would give me 10. So this is basically a unit rate of 10 words per 1 minute, or 10 words a minute. In this case, we have 15 words being typed in 3 minutes. So if I divide 15 by 3, I get 5. This is 5 words per 1 minute. These two are not equal. This person is typing at double the speed of this person. So not equal, so we don't have a proportion. All right, so here we have 13 juniors to 11 freshmen. And we're saying, is that equal to 39 juniors to 33 freshmen? So again, we have juniors and juniors, freshmen and freshmen, so that's okay. We would just find the cross products for the numbers. So 11 times 39, that's 429. And then 33 times 13, that's also going to give us 429. So yeah, we do have a proportion here. So yes, we have a proportion. And if you just kind of simplify this right here, 39 is divisible by 3. So if I divide 39 by 3, I get 13. If I divide 33 by 3, I get 11. So you can see that those two are the same. What about 215 miles to 2 hours? We're saying, is that equal to 430 miles in 5 hours? Well, again, we have miles and miles. We have hours and hours. So we can cross multiply. 2 times 430 would be 860. And then 5 times 215 would be 1,075. These two numbers are not the same, so no, we don't have a proportion. So not a proportion. Okay, let's look at one final problem. So we have 3 defects for every 90 tires. We're saying, is this equal to 6 defects for every 130 tires? So we have defects and defects. We have tires and tires. So we want to cross multiply here. 90 times 6. 9 times 6 is 54. Put a 0 at the end, that's 540. Then we cross multiply here. 130 times 3. 13 times 3 is 39. Put a 0 at the end, it's 390. So these two are not the same, right? 390 is not the same as 540. So we do not have a proportion. So not a proportion. Hello and welcome to Pre-Algebra Test Section 1 on proportions. So we want to determine whether each is a proportion. So we're going to start out with the ratio 8 to 10. We're saying, is that equal to the ratio 2 to 5? Or again, you can kind of think about these as just fractions. 8/10, is that equal to 2/5? So again, if you want to figure this out, you'd use the equality test for fractions, right? You'd multiply the denominator of one fraction times the numerator of the other, right? You'd see if the cross products are equal, right? We're multiplying across. So 10 times 2 is 20. 5 times 8 is 40. These are not equal, so these are not going to represent a proportion. So no, not a proportion. What about 4 to 7? Is that equal to 8 to 14? Or saying 4/7, is that equal to 8/14? Again, find the cross products. So 7 times 8, that's 56. 14 times 4, that's also 56. So yeah, this is a proportion. All right, last one, we have the ratio of 2 to 3. Is that equal to the ratio of 5 to 7? Or again, is 2/3 equal to 5/7? Again, find the cross products. 3 times 5 is 15, and 7 times 2 is 14. The cross products are not equal, so therefore the fractions are not equal, or you could say the two ratios are not equal. Either way, you do not have a proportion. So not a proportion. Hello and welcome to Pre-Algebra Test Section 2 on proportions. Okay, so we want to determine whether each is a proportion. For the first problem, we have 4 yards of yarn to 3 sweaters. And we're saying, is this equal to 20 yards of yarn to 15 sweaters? So again, if you match up the numerators, and everything's the same in there, so you have yards of yarn, you match up your denominators, everything's the same, so we have sweaters and sweaters, then basically to determine if you have a proportion, you just cross multiply the numbers. So in other words, I take the denominator here, I take this 3, multiply it by the numerator here. 3 times 20 would be 60. Then I'm going to do the same thing over here. I'm going to take 15, and I'm going to multiply it by 4. That also gives me 60. So because the cross products are here, we're multiplying across, because the cross products here are equal, we have a proportion. So we just put yes here. We do have a proportion. All right, for this one we have $6 to 3 pesos. We're saying is this equal to $8 to 7 pesos. So a lot of you can eyeball that and see that that's not going to be equal. Because something with a 6 and then a 3, we know that's basically the same as 2 to 1. For this to be 2 to 1, this would have to be 14 in the numerator, right? We can't have 8 over 7. That's not going to be 2 to 1. But we check it by cross multiplying anyway. We have dollars and dollars, pesos and pesos. So we would do 3 times 8, that's 24. And we do 7 times 6, that's 42. So no, we don't have a proportion because the cross products are not equal. So we're just going to put no. All right, here we have 13 men to 26 women. We want to know if this is equal to 39 men to 52 women. So we have men and then men. We have women and then women. So once you've checked that, we just form the cross products with the numbers. So we're going to take 26 and multiply it by 39. That's 1,014. Then we're going to take 52 and multiply it by 13. That's 676. So the cross products are not equal, so we don't have a proportion. So this is a no. Hello and welcome to Pre-Algebra Test Section 3 on proportions. Okay, we want to determine whether each is a proportion. So for the first problem, we have 5 grams of salt to 20 gallons of water. We want to know, is this equal to 30 gallons of salt to 100 gallons of water? So the first thing you do is kind of check what's in the numerator. We have grams of salt and grams of salt, so that matches up. Do the same for the denominator. We have gallons of water and gallons of water. So once we've done that, we're going to see if we have a proportion by cross multiplying the number parts. So the cross products here, we'd have 20 times 30. 20 times 30. You could do 2 times 3, that's 6. Put 2 zeros at the end, so that's 600. And then we do 100 times 5, and that's 500. So your cross products are not equal. 500 is not equal to 600, so this is not a proportion. We would put no. For the next one, we have 8 defects for 120 rims. I want to know if this is equal to 48 defects for 720 rims. So again, we have defects, defects. We have rims, rims. So then we're just going to cross multiply the number parts. So 120 times 48 would be 5,760. Then 720 times 8 would be 5,760. So we do have a proportion here. When we form the cross products, we got 5,760 in each case. So this is a yes. Hello and welcome to Pre-Algebra Test Section 4 on proportions. All right, so we want to determine whether each is a proportion. So we're going to start out with 14 homes sold to 124 homes viewed. We want to know if this is equal to 7 homes sold to 62 homes viewed. So check what's in the numerator. We have homes sold and homes sold. That matches up. Do the same for the denominator. We have homes viewed and homes viewed. Then we would just find the cross products using the number parts only. So in other words, I would multiply 124 times 7. That's going to give me 868. Then I would multiply 62 times 14. That would also give me 868. So since the cross products here are equal, we know that we do have a proportion. So this is a yes. Okay, for the next one, we have 10 miles to 2 gallons of gas. I wonder if that's equal to 25 miles to 3 gallons of gas. Well, you can kind of eyeball and see that that's not going to work out. But again, you have miles and miles. That's what's in your numerator. You have gallons of gas and then gallons of gas. That's what's in your denominator. So that part checks out, right? We have the same thing in the numerator, same thing in the denominator. Then we just want to cross multiply. The number part in this denominator is 2. The number part in this numerator is 25. 2 times 25 is 50. Over here we have 3 times 10. That's going to give me 30. 30 does not equal 50, so we don't have a proportion. So we're just going to say no. Hello and welcome to Pre-Algebra Test Section 5 on proportions. So we want to determine whether each is a proportion. And we have 18 to 10. And we want to know if that's equal to 36 to 40. So we just cross multiply here. 10 times 36 is 360. 40 times 18, you could do 4 times 18. That's 72. Put a 0 at the end, it's 720. So 720 is not equal to 360. So no, this is not a proportion. What about 4 turtles to 7 dogs? Is this equal to 8 turtles to 14 dogs? So we have turtles and turtles in the numerator. We have dogs and dogs in the denominator. So again, we just find the cross products for the number parts. So we take 7 and multiply it by 8. That's 56. And then 14, we'd multiply that by 4. That's also 56. So yeah, we do have a proportion here. All right, for the last one, we have 3 women to 5 boys. We want to know if that's equal to 27 women to 40 boys. So we have women and then women. We have boys and then boys. So we just want to cross multiply the number parts. So 5 times 27 is 135. 40 times 3 is 120. So 120 is not the same as 135. So no, this is not a proportion. Hello and welcome to Pre-Algebra Practice Set number 37. In this video, we're going to look at some additional practice problems for our lesson on operations with mixed numbers. All right, so we just want to perform each indicated operation. And we're going to start out with some addition of mixed numbers. So when we add or subtract mixed numbers, typically what they're going to tell you to do is to add or subtract the fraction parts first, then follow that up by adding or subtracting your whole number parts. So for example, if we have 13 and 4/7 plus 16 and 2/7, let me just write this in a different way so that you completely understand what's going on. This is written this way for convenience. Really, 13 and 4/7 is 13 plus 4/7. And same goes with 16 and 2/7, right? It's 16 plus 2/7. So to make this convenient for me, I'm going to reorder this. I'm going to write the fraction parts next to each other. I'm going to write the whole number parts next to each other. So I'm going to write 13 plus 16 plus 4/7 plus 2/7. Now, if I do the fraction parts first, basically I'm adding 4/7 and 2/7. We already have a common denominator. So to do that, basically I'm just going to add the numerators. 4 plus 2 is 6. Put that over the common denominator of 7. Once I have that result, let me just stick that over here. All I'm going to do after that is add 13 and 16. That result's going to be 29. So I'd stick that next to 6/7, and I'd get my answer of 29 and 6/7. And alternatively, if you wanted to, you could convert each number into an improper fraction and find the sum that way. But a lot of times that's going to be more of a hassle, right? This should be the easiest way in the majority of the cases you're going to see. Let's take a look at another one. We have 1 2/3 plus 6 5/18. So kind of the long way, again, I can rewrite this as 1 plus 2/3 plus 6 plus 5/18. I can reorder it to where the whole numbers are next to each other. So 1 plus 6 plus, I'll put the fractions next to each other, 2/3 plus 5/18. And I'm just going to add my fraction parts first. So to add 2/3 and 5/18, looking for the LCD there, I know it's going to be 18, right? 18 is 3 times 3 times 2, or 9 times 2. And we have a 3 here, so basically I'd multiply this top and bottom by 6 so that we'd have a common denominator of 18. So 6 times 2 would give me 12 over the common denominator of 18 plus 5 over 18. Now we just add the numerators. 12 plus 5 is 17, so this would be 17 over 18. So my fraction part is done. It'd be 17 over 18. Now I just add the whole numbers. 1 plus 6 would give me 7, and I have my answer. 7 and 17/18. All right, let's take a look at another one. We have 4 9/10 plus 11 3/5. So I'm going to add the fraction parts first, and I'm going to not write this whole thing out like I normally do. I'm just going to kind of eyeball these and bring them down. So 9/10 plus 3/5. Now, to get a common denominator here, the LCD is 10, right? Because 5 is not going to factor 10 factors of 5 times 2, so the LCD is going to be 10. So I just need to multiply this by 2 over 2, and let's do that. So I'm going to have 9/10 plus 3 times 2 is 6, over 5 times 2, that's 10. So 9 plus 6 is 15, so I'd have 15 over 10. Now, I can simplify this, but there's another problem. If I have an improper fraction here as my result, I have to rewrite it as a mixed number. And let me explain why. We're adding the fraction parts for these two mixed numbers here. So what we want is a proper fraction, because when we have a mixed number, we have a whole number part and we have a proper fraction. If I just throw 15 over 10 up here, or the simplified version, which would be 3/2, that's not going to be a proper fraction, and I'm not going to have a true mixed number. So let me go down here real quick. First, we'll simplify by just dividing the numerator and denominator by 5, the greatest common factor. 15 divided by 5 is 3. 10 divided by 5 is 2. So this will be 3/2. And to write this as a mixed number, remember, we just do 3 divided by 2. 2 goes into 3 once. 1 times 2 is 2. Subtracting, you get 1. So this would be 1 and 1/2. 1 and 1/2. So let me erase this. We're going to go back up to the top, and I'll show you what to do with it. So at this stage, we normally write our fraction part here, and we start adding the whole numbers. So I'm going to do the fraction part of that mixed number we came up with. It was 1 and 1/2, so I'm just going to put 1/2. Now, when I add my whole numbers, 4 plus 11, I'm going to throw a 1 in there, because that's what came off of that mixed number. So now I have 4 plus 11, that's 15, plus another 1, that's going to give me 16. So I have 16 and 1/2 as my answer. All right, let's look at some subtraction problems now. And we're basically going to do the same thing. We're going to subtract the fraction parts first, and then we're going to subtract the whole number parts last. So if I start off on this problem, I'm going to do 2/7 minus 1/7 to start. Now remember, with subtraction, it's not commutative, so the order is going to matter. The fraction part from the mixed number on the left is what's going to go on the left over here, and then we're subtracting away the fraction part from the mixed number on the right. So we have 2/7 minus 1/7. We already have a common denominator, so we just do 2 minus 1, that's 1, over the common denominator 7. So the fraction part for this will be 1/7. Now all we need to do is subtract the whole number parts. So we would do 9 minus 8. 9 minus 8 is 1. So our result here would be 1 and 1/7. All right, next we have 4 and 1/15 minus 2 and 3/5. So we're going to run into a little problem here. And when we get to it, I'm going to show you how to get around it. So we have 1/15. We're going to subtract away 3/5. So the first thing I need to do is figure out what the LCD is going to be. Well, it looks like I can use 15, right? Because 15 is 5 times 3. 5 doesn't factor, so yeah, the LCD here is going to be 15. So I can multiply this by 3 over 3. So I'd have 1 over 15, or 1/15, minus 3 times 3, that's 9, over 5 times 3, that's 15. If I wanted to do 1 minus 9, I'm going to end up with a negative number. That's going to make this super complicated. So to make it easy for us, let's just erase this real quick and rethink this problem. So if I have 4 plus 1/15, again, that's what 4 and 1/15 is, I can rewrite this as 3 plus 1 plus 1/15, right? Mathematically, this is the same. Now, in fractional form, I can write 1 as any number, as long as it's not 0, divided by itself. So because this has a denominator of 15, I'm going to write this as 15 over 15. And what happens is I can write this as 3 plus 16 over 15. Now, typically, we're not going to write a mixed number like this, but for the purposes of performing this operation, we're temporarily going to do that. So let's just erase this real quick, and we're going to temporarily just rewrite this 4 and 1/15 as 3 and 16/15. And again, you're not going to typically see a mixed number written like this. We're just doing it for the purposes of performing the subtraction with the fractions. So then minus 2 and 3/5. And again, I'm going to do 16/15 now, minus 3/5. The LCD is still going to be 15, so I'd still multiply this by 3 over 3. And so what we'd end up with we would have 16/15 minus 3 times 3 is 9 over 5 times 3, that's 15. 16 minus 9 is 7, so you'd end up with 7/15 here. So 7/15. So I'm going to put this as equal to, and I'm going to put 7/15 out here. And now we just need to subtract the whole number parts. So I have a 3 minus a 2, that's going to give me a 1. So 4 and 1/15 minus 2 and 3/5. Again, we temporarily wrote that as 3 and 16/15 minus 2 and 3/5. Either way, we end up with a result of 1 and 7/15. All right, now let's look at some problems with multiplication and division. Now, unlike with addition and subtraction, when we multiply or divide mixed numbers, we're going to convert them into improper fractions first. So 8/5, I can just leave that alone. That's already a fraction. I'm going to multiply this by, we have 3 and 3/14. 14 times 3 is 42. 42 plus 3 is 45. And then over 14. Now before we multiply, we always want to look to cross cancel. 45 divided by 5 is 9. So I can cancel this with this, and I'll get a 9. And I'll put a 1 here. If I look between 8 and 14, the greatest common divisor there will be 2. So divide this by 2, I get 7. Divide this by 2, I get 4. So what we're left with is 4 times 9, or 36 for our numerator, 1 times 7, or 7 for our denominator. So we get 36/7. Now, depending on who your teacher is or what textbook you're using, they might tell you that they want you to convert it back into a mixed number when you're done, or they might say, hey, 36/7, that's fine. So just to do one where we convert it back, you take 36 and you divide it by 7. 7 is going to go into 36 5 times. 5 times 7 is 35. Subtracting, you get 1. So remember, to write this as a mixed number, the quotient, which is 5, becomes the whole number part. The remainder becomes the numerator for your fraction part. And then your divisor is your denominator for the fraction part. So 36/7 is going to be equal to 5 and 1/7 as a mixed number. All right, let's take a look at 5 and 1/7 times 3 and 1/9. So I'm going to convert each into an improper fraction. 7 times 5 is 35, plus 1 is 36. So this is 36/7. And we're multiplying by 9 times 3 is 27, plus 1 is 28 over 9. Now when we look to cross cancel, 36 is divisible by 9. 36 divided by 9 is 4. So cancel this with this. I'll put a 1 here and a 4 here. 28 is divisible by 7. 28 divided by 7 is also 4. Cancel this with this. I'll put a 1 here and a 4 here. And we basically end up with 4 times 4, or 16, over 1 times 1, or 1. You can write 16 over 1, but basically it's just 16. All right, let's look at -2 times 12 and 4/5. So -2, I can write that as -2 over 1, just to make it convenient because we're working with fractions. And then times, we'll have 5 times 12, that's 60, plus 4, that's 64, over, and then we have 5 as our denominator. So nothing to cross cancel here. -2 times 64 is going to be -128, and then 1 times 5 is 5, so we just end up with -128 over 5. All right, let's look at some with division. We have 13 and 1/2 divided by 5 and 5/6. So 13 and 1/2, we have 2 times 13, that's 26, plus 1 is 27, over 2. And divided by, for 5 and 5/6, 6 times 5 is 30. 30 plus 5 is 35, over 6. And again, when you're dividing fractions, you're going to take this left fraction and leave it unchanged. So 27 over 2, or 27/2, you don't really touch that. Then you're going to multiply by the reciprocal of 35 over 6, which is going to be 6 over 35. Now, looking between these fractions, what can we cross cancel here? I know 6 is divisible by 2. 6 divided by 2 is 3. So cancel this with this. Put a 1 here and a 3 here. Between 27 and 35, there's nothing I can really do. 27 is 3 factors of 3, right? 3 times 3 is 9. 9 times 3 is 27. And 35 is 5 times 7. So nothing else I can cancel. So I basically do 27 times 3. That's going to give me 81. And this is over 1 times 35, or 35. So we get 81 over 35 as our answer. All right, for the last problem, we have 2 and 3/4 divided by 1 and 7/10. So again, I'm going to convert each of these into an improper fraction and then do my division. So 4 times 2 is 8. 8 plus 3 is 11. So you'd have 11 over 4. And we're dividing by 10 times 1, that's 10, plus 7 is 17 over 10. So to divide the fractions, again, 11/4 stays unchanged. And we multiply by the reciprocal of 17/10, which is 10/17. So looking here to cross cancel, I know that the greatest common divisor, or the greatest common factor between 10 and 4 would be 2. So if I divide this by 2, I get 5. If I divide this by 2, I get 2. So then I do 11 times 5, that's 55. Over 2 times 17, that's 34. So we end up with 55 over 34 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on operations with mixed numbers. All right, so we want to perform each indicated operation. We're going to start out with 6 1/5 plus 3 2/5. So like I told you in the lesson, if you're adding or you're subtracting mixed numbers, kind of the easiest way to do it is going to be to add or subtract your fraction parts first, and then follow that up by adding or subtracting your whole number parts. So just to let you see what we're actually doing, let's rewrite this. So instead of 6 1/5, I'm going to write 6 plus 1/5. Remember, 6 1/5 written this way is for convenience, right? We don't put this plus in here, but we should know that it's actually there, right? 6 1/5 is really 6 plus 1/5. Then we have plus. Next we have 3 2/5. So I'm going to write 3 plus 2/5. And then because addition is commutative, I can reorder it. So let's put our whole numbers next to each other. So 6 plus 3. Let's put our fraction parts next to each other. So 1/5 plus 2/5. And now let's add the fraction parts first. So if I have a common denominator of 5 already, really I just need to add the numerators. So 1 plus 2 is 3. So really this would just be 3/5. And 6 plus 3, the whole number parts, add that next. 6 plus 3 is 9. So we get 9 plus 3/5. And if we write this as a typical mixed number, we don't put the plus sign in, right? For convenience, we just write 9 3/5, right? Like this. All right, let's take a look at another one. We have 3 1/3 plus 2 2/7 plus 1 1/4. Now, for convenience, I'm just going to write 1/3 plus 2/7 plus 1/4 down here. So I'm just going to take care of the fraction part first. And then once I have my answer, I'm just going to go back and add the whole numbers. So if I have 1/3 plus 2/7 plus 1/4, the LCD, the least common denominator, is going to be 3 times 7 times 4. And that's because 3 is prime, 7 is prime, and 4 is 2 times 2. So really the best I can do for the LCD is the product of the denominators. So 3 times 7 is 21, and 21 times 4 is 84. So I'm going to have to multiply 1/3 by 28 over 28. I'm going to multiply 2/7 by 12 over 12. And I'm not going to fit this on my screen, so I'm just going to write this down here. I'm going to have to multiply 1/4 by 21 over 21. So 1 times 28 is 28. And we know that 3 times 28 is going to give us 84. Then plus, next we have 2 times 12, that's 24. Over 7 times 12, again, we know that's 84. Then plus, we have 1 times 21, that's 21. Over 4 times 21, that's, again, 84. So now that we have this set up with a common denominator, we just need to add the numerators. So let me erase this real quick. And I'm going to do that vertically. So we have 28, 24, and 21. So if we sum this here, 8 plus 4 is 12, 12 plus 1 is 13. Carry the 1, 1 plus 2 is 3, plus 2 is 5, plus 2 is 7. So this would give me 73 over 84 as my fraction part. So let's erase everything, and we come back up here, and again, the fraction part is 73 over 84. So now the hard work is behind us, and I just need to add the whole numbers. So I have 3, 2, and 1. So 3 plus 2 is 5, 5 plus 1 is 6. So we get 6 and 73 over 84 as our answer. Hello and welcome to Pre-Algebra Test Section 2 on operations with mixed numbers. So for our problems today, we just want to perform each indicated operation. And what we're going to be doing, we're going to be adding and subtracting some mixed numbers. So hopefully you've already seen the lesson, but just in case you haven't, when we perform addition or subtraction with mixed numbers, the preferred method is to add or subtract the fraction parts first. So with this problem, here's your fraction parts, and we're doing addition, so we would add the fraction parts first, and then we would follow that up by adding the whole number parts. So here's your whole number parts. Now I'm going to start this problem out 5 3/7 plus 7 9/11 by just rewriting it. Now most of you will know at this point that 5 3/7 mathematically is really 5 plus 3/7. We just write it like this for convenience, right? But really it's 5 plus 3/7. Now I'm going to write plus. I'm going to do the same thing to 7 9/11. So 7 plus 9/11. Okay. Now because addition is commutative, I'm allowed to reorder it. So what that means is I can write the whole numbers next to each other. So 5 plus 7, and then I can write the fractions next to each other. So 3/7 plus 9/11. So the first thing I'm going to do is I'm going to add the fraction parts together. And some of you have emailed me and asked, why do we do the fraction parts first? Well, this is the perfect example to show you why. So if we add 3/7 and 9/11, you're going to see that we're going to have an additional step when we get the answer. So the first thing I want to do is get my LCD. So my LCD here, if I look, I have a 7 for a denominator and I have an 11. Those are each prime numbers, so my LCD is going to be the product of the denominators, which is 7 times 11 or 77. So I'm going to multiply this fraction by the other fraction's denominator, top and bottom. So 11 over 11. And I'm going to do the same thing over here. 9 over 11, I'm going to multiply that by 7 over 7. So in each case, I'm now going to have a denominator of 77. So 11 times 3 is 33. Let me just scroll down a little bit, get a little room going. So 33, and that's of course over 77. And then plus 9 times 7, that's 63. And again, of course, that's over 77. Now, when we add the numerators here, we have 33 plus 63. The best way to do that mentally is to just say, okay, just kind of cut this 3 off and cut this 3 off. If you think about having 30 plus 60, that's 90. So I know that part's going to be a 9. And then just do 3 plus 3. 3 plus 3 is 6. So this would be 96. Okay, and this, of course, is going to be over the common denominator of 77. So this is why we add the fractions together first, because stuff like this happens. So what happens is I have an improper fraction. So let's say I go back up 96 over 77, and I continue with my problem. I say, okay, 5 plus 7 is 12, so I get 12, and 96 over 77. Well, that's not technically a mixed number because a mixed number is a whole number part, and then a proper fraction part. This is not a proper fraction. This is an improper fraction. So when you find that you get this result where you have an improper fraction, you have to go through and do one additional step. What we're going to do, let's scroll back down. Where we find we get an improper fraction here, we're going to convert it to a mixed number. So 96 divided by 77. 77 will go into 96 only once. 1 times 77 is 77. If we subtract here, we would borrow. This will become 8, and this will become 16. 16 minus 7 is 9. 8 minus 7 is 1. So what this is going to be is 1 and 19 over 77. Okay, so let me erase this. We're going to go back up to the top. So I'm just going to write this here as 5 plus 7 plus, remember I had 1 and 19 over 77. So I'm going to write that as 1 plus 19 over 77. And once I write it like that, it's pretty obvious what we're going to do now. We're just going to add the whole numbers together. 5 plus 7 is 12. 12 plus 1 is 13. And then we would have plus 19 over 77. Well, we can just write this as a mixed number as 13 and 19 over 77. All right, for the next one, we have 8 and 5/7 minus 3 and 2/3. Now, with subtraction, it's basically the same thing. We want to subtract the fractions first, and then once we're done with that operation, we want to subtract the whole numbers. Now, in this particular case, we have 5/7, and we're going to subtract away 2/3. It has to go in that order because, remember, subtraction is not commutative like addition. So if I think about 5/7 minus 2/3, the first thing I want to think about is 5/7 bigger than 2/3? Because if it's not, it's going to produce a negative result. And for that situation, we have to use a little trick. So 7 times 2 is 14. 3 times 5 is 15. So 5/7 is the bigger fraction, so we don't have to worry about that in this case. So let's go through and just do our subtraction. First, we need to find the LCD. So the LCD for these fractions, 7 is a prime number, so is 3. So the best we can do is 7 times 3, or 21. So I'll multiply this fraction by 3 over 3. I'll multiply this fraction by 7 over 7. So 3 times 5 is 15, over 3 times 7, that's 21. Subtract away, 2 times 7 is 14, over 3 times 7, that's also 21. 15 minus 14 is 1, over the common denominator of 21. So the fraction part for this mixed number is going to be 1 over 21. Now we're done with that part, and we just need to talk about subtracting 8 minus 3. Right? 8 minus 3 is simply 5. And just like that, we have our answer. It's 5 and 1 over 21. Hello and welcome to Pre-Algebra Test Section 3 on operations with mixed numbers. So we just want to perform each indicated operation. And we're going to look at 13 and 4/9 minus 9 and 6/7. So as I told you in the lesson, when you're adding or you're subtracting mixed numbers, you want to add or subtract the fraction parts first, and then follow that up by adding or subtracting the whole number parts. So with this problem, I'm going to just subtract 4/9 minus 6/7 first. That will give me the fraction part for the mixed number that I'm forming. So 4/9 minus 6/7. So 9 is 3 times 3. 7 does not factor. So my LCD here would be 9 times 7, or 63. So I can multiply this by 9 over 9, and this by 7 over 7. And we would have 7 times 4, that's 28. Over 9 times 7, or 7 times 9, that's 63. Minus 6 times 9, that's 54. Over 7 times 9, that's 63. So we have a bit of a problem here. And we see that 28 is actually less than 54. So if we do this subtraction, we're going to end up with a negative result. So we don't typically perform the operation this way. What we would do, let's just erase this real quick. We would kind of rewrite our mixed number temporarily. So instead of 13 and 4/9, I want you to think about this as 12 plus 1 plus 4/9. Remember, 13 and 4/9 is really 13 plus 4/9. So if I write it this way, these two are equal, right? They are the exact same thing. I just wrote it differently. Now, in order to kind of match this up, instead of writing this as 1, I'm going to write it as 9/9. Okay, 9/9. Remember, 9/9 is really 1. So what that allows me to do is add this and this together. 9/9 plus 4/9 would give me 13/9. So what I've done is I've temporarily rewritten this mixed number as 12 plus 13/9. And now, when I perform the operation with the fractions, I will have a result that is not negative. So I'll write this as 12 and 13/9 minus 9 and 6/7. And I know this is not technically correct because this is not how you write a mixed number, right? A mixed number is always a whole number part and then a proper fraction. But again, we're just temporarily doing it this way so that we can do our operation and not have it all messy. So we would do 13/9. We would do 13/9 minus 6/7 now. And it's the same LCD. So I'm going to multiply this by 7 over 7. I'm going to multiply this by 9 over 9. And let's scroll down and see what this gives us. So 7 times 13 is 91. And we know that 7 times 9 is 63. And then we're subtracting away 6 times 9, that's 54. Over 7 times 9, again, that's 63. And so 91 minus 54 is 37. So we'd have 37 over 63. And let's erase everything and just go back up to the top. So for my fraction part, I'm going to put 37 over 63. Now I just need my whole number part. So I'm only going to be subtracting with 12 here. Remember, I changed the way this mixed number was so that I could perform the operations with the fractions. So instead of having 13, I now only have 12. Make sure you remember that. So I'd have 12 minus 9, and that's going to give me 3. So the whole number part for this mixed number is going to be 3. And then we already have the fraction part. So our answer is 3 and 37 over 63. All right, let's take a look at another one. We have 15 and 2/13 minus 6 and 4/5. So again, we want to subtract the fraction parts first. So I would think about 2/13 minus 4/5. And you can kind of eyeball those two fractions at this point and see that you would get a negative result, right? 2/13 is smaller than 4/5, and if you kind of suspect that's the case, and you don't want to go through and actually do the subtraction, again, we know how to compare fractions. 13 times 4 is 52, and 5 times 2 is 10. So this is the bigger fraction, so if I subtract it away, I will in fact get a negative. So let me erase all this real quick, and we're going to use our little trick again. So instead of having 15, I'm going to rewrite this as 14, then plus, where I took 1 away, I'm now going to add 1 to this fraction. So I'm going to temporarily rewrite 1 as 13 over 13. And that's just so I can have a common denominator with 2/13. And so 13 plus 2 would give me 15. So really what I'm doing is I'm going to temporarily write this as 14 and 15/13. So let's erase this. And then we still have minus 6 and 4/5. So now when we work with our fractions, we're going to have 15/13, and we're going to subtract away 4/5. Now, the LCD here, 13 is prime, so is 5, so the best we can do is just multiply 13 times 5 and get 65 for our LCD. So I'm going to multiply this fraction by 5 over 5. I'm going to multiply this fraction by 13 over 13. And so what we're going to get, 15 times 5 is 75. Again, 13 times 5 is 65. And we're subtracting away. 4 times 13, we did that earlier. We know that's 52. And then 5 times 13 again is 65. So now we just need to subtract 75 minus 52. That's going to give us 23. So we would have 23 over 65 for the fraction part of this mixed number that we're building. So 23 over 65. So equals, I'm going to put 23 over 65 here. And what's my whole number part? Well, remember, if you didn't write it this way, you have to remember that you have 14 now, right? You don't have 15 anymore because you lent 1 to your fraction part so you could do that operation. So having 1 less, we start with 14, we subtract away 6, we would get 8. So I put that here as my whole number part for that mixed number, and we get our answer, which is 8 and 23 over 65. Hello and welcome to Pre-Algebra Test Section 4 on operations with mixed numbers. All right, so we want to perform each indicated operation, and we have 4 2/3 times 6 3/5. Now in the previous test sections, we worked with adding and subtracting mixed numbers. Now when we start multiplying and dividing mixed numbers, the way we do it changes a little bit. So instead of working with kind of the mixed numbers in this form, we're going to convert them into improper fractions first, then do our multiplication. Now if your teacher asks you for it, go ahead and convert them back into a mixed number. So to convert this one 4 2/3, I'd multiply 3 times 4 and get 12, then add 2 and I'd have 14/3. And I'm multiplying by, for 6 3/5, I'd multiply 5 times 6, that's 30. Then add 3, I'd have 33 over 5. So we're multiplying these two together, and we can see that we can cross cancel here. 33 and 3 basically share a factor of 3. So I can divide this by 3 and get 11, divide this by 3 and get 1. Nothing else I can really do to cross cancel, so I would just multiply 14 times 11, and I'd get 154. And this is over 1 times 5, or 5. So we'll end up with 154/5. And again, if it's required, you can change this back into a mixed number. Again, just divide. You take 154 and divide it by 5. 5 goes into 15 3 times. 3 times 5 is 15. Subtract, you'd get 0. Bring down the 4. 5 is not going to go into 4, so I'm going to put a 0 here. 0 times 5 is 0. Subtracting, you'd have 4. So essentially, this is 30 with a remainder of 4. So to write our mixed number, the 30, your quotient, is the whole number part. 4, your remainder, is the numerator for the fraction part. And then 5, your divisor, is the denominator for the fraction part. So this 154/5 is really the same thing as 30 and 4/5 when you write it as a mixed number. Okay, next we have 2 4/5 times 1 5/6. Again, I'm going to convert each into an improper fraction to start. 5 times 2 is 10, plus 4 is 14. So you'd have 14/5 times 6 times 1 is 6, plus 5 is 11 over 6. And so now we're going to look to cross cancel. Nothing between 11 and 5, but between 14 and 6 I have a common factor of 2. So divide this by 2, I get 7. Divide this by 2, I get 3. So then 7 times 11 is 77. Over 5 times 3, that's 15. So you get 77/15 as your answer. And again, your teacher might require you to write this as a mixed number. If they do the division and set yourself up a mixed number. All right, we got one final problem here. We have -3 times 4 and 1/15. So for convenience, because we're working with kind of mixed numbers and fractions, I'm going to write -3 as just -3 over 1. And then we're going to convert 4 and 1/15 into an improper fraction. 15 times 4 is 60, plus 1 is 61, and then over 15. Now between -3 and 15, I have a common factor of 3. If I divide this by 3, I'd end up with -1. If I divide this by 3, I'd end up with 5. So really I have -1 times 61, which is -61, over 1 times 5, or 5. So we get -61/5 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on operations with mixed numbers. All right, so we want to perform each indicated operation. We're going to start out with 12 and 1/2 divided by 5 and 2/3. So again, if you're working with multiplication and division for mixed numbers, the easiest way to do it is to convert each into an improper fraction, perform your operation, and then if you need to, take your result, change it back into a mixed number. So I'm going to take 12 and 1/2, and I'm going to rewrite it as 2 times 12 is 24, plus 1 is 25, so 25 halves. And then I'm dividing by, I have 5 and 2/3. I'm going to rewrite this as 3 times 5, that's 15, plus 2 is 17, so 17/3. All right, so to divide two fractions, I take the first fraction, or the leftmost fraction, 25 halves, leave it unchanged, multiply by the reciprocal of the second fraction, so 17/3. If I flip that, I'm going to have 3/17. And I look to see what I can cross cancel, and there's nothing I can really do here, so I just multiply. 25 times 3 is 75, and 2 times 17 is 34. So we'll end up with 75 over 34 as our answer. All right, next we're going to look at 7 and 1/2 times 8 and 4/5. So again, what I want to do is change each into an improper fraction. So 2 times 7 is 14, plus 1 is 15, so I'd have 15 halves. And I'm multiplying by 5 times 8 is 40, 40 plus 4 is 44, so 44/5. So I can do some cross canceling here. 15 divided by 5 is 3, so I can cancel this with this. I'll put a 1 here and a 3 here. I can cancel a common factor of 2 between 44 and 2. So cancel this with this. This will be 1, and this will be 22. So now I'll just multiply 3 times 22, that's 66. And that'll be over 1 times 1, or 1. So really I don't have to write that as 66 over 1. I can just write 66. All right, for the next one I have -3 divided by 2 and 1/5. So -3. And for convenience, I'm going to write that as -3 over 1. Then divided by 2 and 1/5, I'm going to convert that to an improper fraction. 5 times 2 is 10, plus 1 is 11. So we'd have 11/5 there. So now to divide, I'd have -3 over 1 times the reciprocal of this fraction, which would be 5/11. Nothing to cross cancel. So I do -3 times 5, that's -15. Over 1 times 11, that's 11. So I get -15/11 as my answer. All right, let's look at one final problem. We have -6 times 11 and 1/3. So I'm going to write this as -6 over 1, and then times, change this to an improper fraction. 3 times 11 is 33, plus 1 is 34, so 34/3. So before I multiply, I want to look to see if I can cross cancel. I have a -6 and I have a 3. Forget about the negative for a minute. If I just think about the relationship between 6 and 3, 6 divided by 3 is 2. So I can cancel this 6 with this 3. I'll get a 2 here. I'll put a 1 there. So now this is a -2. And -2 times 34 is going to give me -68. And this is over 1 times 1, or 1. And I could put -68 over 1, but really that's just -68. So that's going to be my answer. Hello and welcome to Pre-Algebra Practice Set number 38. In this video, we're going to look at some additional practice problems for our lesson on complex fractions. All right, so to start, we just want to simplify each complex fraction. And in the lesson, I taught you kind of two ways to do it. The first way you would do it is just to simplify the numerator and denominator separately, and then kind of to perform the main division. The other way to do it is to multiply the numerator and the denominator of the complex fraction by the LCD, the least common denominator of all fractions involved. Now I'm going to start out by just simplifying the numerator and denominator separately, and then kind of in the last few problems, we'll do it the other way. So we're going to start out with 1/8 plus 4 over 7 plus 5/3. So I'm going to start out by just simplifying the numerator. So we'd have 1/8 plus, I could write 4 as 4 over 1, but really I've got to get a common denominator here to add. So the LCD I'm going to be able to have is an 8, right? Because I could write this as 4 over 1. Between 8 and 1, the least common denominator is going to be an 8. So I can just multiply 4 by 8, that's going to give me 32. And multiply 1 by 8, that's going to give me 8. And we know that 32 over 8 is the same thing as 4. Now I can add. 1 plus 32 is 33. So this is going to end up being 33 over 8. So I'm just going to erase this and put that this is 33 over 8. Next we have 7 plus 5/3. Again, I'm going to write this over 1. And I can see that my LCD between 1 and 3 is going to be 3. So just multiply this by 3 over 3. 7 times 3 is 21. Over 1 times 3, that's 3. And then we're adding to that 5 over 3. 21 plus 5 is 26. So we're going to end up with 26/3 here. And so now we just perform a division, right? We have 33 over 8 divided by 26 over 3. So 33 over 8 times the reciprocal of 26 over 3 would be times 3 over 26. And there's nothing really we can cross cancel here. 33 is 3 times 11. 3 is prime. 8 is 3 factors of 2. And 26 is 13 times 2. So I'm just going to multiply. 33 times 3 is 99. And 8 times 26 is 208. So when we simplify our complex fraction, we end up with 99 over 208. All right, now we're going to look at 3/4 plus 1/7 over 5/6 plus 7/8. So again, we're going to simplify the numerator and denominator separately, then do the main division. So if I think about 3/4 plus 1/7, the LCD here, if you look at 4 and you look at 7, 4 is 2 times 2, 7 is prime. So really the LCD is going to be 4 times 7 or 28. So I'm going to multiply this fraction by 7 over 7 and this fraction by 4 over 4. So what I'm going to get is 3 times 7 or 21 over 28 plus 1 times 4 or 4 over 28. So 21 plus 4 is going to give me 25, and this is over the common denominator of 28. So 25 over 28 is going to be my simplified numerator. Now what about my denominator? I have 5 over 6 plus 7 over 8. So if I think about the LCD here, the LCD, for the LCM between 6 and 8, 6 is 2 times 3, and 8 is 3 factors of 2. So really it would be 3 factors of 2 and 1 factor of 3. So it would be 8 times 3 or 24. So I would need to multiply this by 4 over 4, and I would need to multiply this by 3 over 3. So 5 times 4 is 20. Over 6 times 4, that's 24. Plus 7 times 3, that's 21. Over 8 times 3, again, that's 24. Add the numerators. 20 plus 21 is 41 over the common denominator of 24. So my simplified denominator is going to be 41 over 24. So now we just perform the division. We have 25 over 28 divided by 41 over 24. So this fraction here stays the same, 25 over 28. And we're going to multiply by the reciprocal of this fraction, which is 24 over 41. And it looks like I can cross cancel here. 28 is divisible by 4, and so is 24. So if I divide 28 by 4, I'd get 7. If I divide 24 by 4, I'd get 6. So now I'd end up with a problem 25 times 6, which is 150, over 7 times 41, which is 287. So my result is 150 over 287. Okay, now we want to simplify each complex fraction using the LCD method. So we're going to look at 1/8 plus 5/12 over 3/5 plus 2/15. Now, I don't know if this method is faster or slower for you, but you need to know both because your teacher might ask you to do the problem a specific way on a test. So to use the LCD method, find the LCD for all the fractions involved. So the LCD is going to be the LCM of 8, 12, 5, and 15. So if we look at these numbers here, 8 is 3 factors of 2. So 2 times 2 times 2. 12 is 2 factors of 2, which we've already covered, and 1 factor of 3. So throw in a factor of 3. 5 is prime. It doesn't factor. Throw that in. And then 15 is 5 times 3. We already have that in there. And so we multiply. 3 factors of 2 is 8. Times 3 is 24. Times 5 is going to give us 120. So the LCD here is 120. So now what we're going to do is multiply the numerator of the complex fraction by 120. And you can put times 120 over 1 if that makes you feel more comfortable. And we're also going to multiply the denominator of the complex fraction by 120. And again, I'm going to put 120 over 1 as well. So to do this, we use the distributive property. So 120 over 1 times 1/8. 120 over 1 times 1/8. And I'm going to do that down here. So 120 divided by 8 is 15. So essentially, we cancel this with this and we get 15. So you'd have 15 times 1 over 1 times 1, or just 15. Right? You could write 15 over 1 if you want, but you really don't need to. So we just write this as 15. So then plus. Next, I do 120 over 1 times 5/12. So 120 over 1 times 5/12. You can cancel this with this and get 10. All right, 120 divided by 12 is 10. So then you'd have 10 times 5, that's 50. And this is over 1 times 1. 50 over 1 is the same thing as 50. So we'll just write 50. Now we're going to work on the denominator. So again, I'm doing the same thing. I'm going to have 120 over 1 times 3/5. So 120 over 1 times 3/5. So 120 over 5 is going to be 24. All right, this will cancel with this and give me 24. Then 24 times 3 is 72. So this would be 72 over 1, or just 72. Then plus. Next, we're going to have 120 over 1 times 2/15. 120 divided by 15 would give me 8. So this would cancel with this and give me 8. 8 times 2 is 16. And of course, it's over 1 times 1, or just 1. So 16 over 1 is the same thing as 16. I'll scroll back up here. 15 plus 50 is 65. 72 plus 16 is 88. So there will not be any factors in common between 65 and 88. So that's going to be your final answer. 65 over 88. So let's look at one final problem. We have 3/7 plus 2/13 plus 1/14. And this is over 3/13 minus 4/7. So what's our LCD? Again, that's going to be the LCM of all the denominators involved. So 7, 13, 14, and then we have 13 and 7. That's just a repeat here. So we would have 7 times, 13 is also prime, times, 14 is 7 times 2, so just times 2. So 7 times 13 is 91, then times 2 is 182. So what I'm going to do is multiply the numerator and denominator of the complex fraction by 182. So I'm going to be multiplying the numerator and the denominator, again, by 182. And again, to do this, we use the distributive property. So what's 182 times 3/7? 182 times 3/7. Well, 182 divided by 7 is 26. So this would cancel with this and give you 26. And then 26 times 3 would give you 78. So this would be 78. Then plus. Next, I do 182 times 2/13. So 182 times 2/13. So 182 divided by 13 is going to give me 14. So we'd have 14 times 2, that's 28. Then plus. Next, we're going to have 182 times 1/14. And 182 divided by 14 is 13. So you just have 13 times 1, or 13. And then this is over. We're going to do the same thing down here. We're going to multiply 182 times 3 over 13. Again, 182 divided by 13 is going to give me 14. So then 14 times 3 is 42. So this is going to be 42 minus. Then the last thing we're going to do is multiply 182 times 4/7. So 182 times 4/7. 182 divided by 7 is going to give me 26. And then 26 times 4 is 104. So this is going to be minus 104. All right, so now let's continue this down here. We have 78, 28, and 13. So we're adding these numbers in the numerator. Let's just do that with a vertical addition real quick. 8 plus 8 is 16. 16 plus 3 is 19. Put a 9 down, carry the 1. 1 plus 7 is 8. 8 plus 2 is 10. 10 plus 1 is 11. So the numerator is going to be 119. Numerator is going to be 119. Let me just write that right here. Okay, so that part's taken care of. Next, we have 42 minus 104. So we can really think about this as 42 plus a negative 104. We know the sign is going to be negative. And then we're just going to do 104 minus 42. So 104 minus 42. 4 minus 2 is 2. Borrow here. That becomes 0. This becomes 10. 10 minus 4 is 6. So you get 62 there. And of course, this is negative. So you get 119 over negative 62. Or again, when you have a fraction and the numerator is positive and the denominator is negative, really the whole thing was just negative. So you can just stick the negative out in front and say you have negative 119 over 62 like that. Nothing we can simplify between the numerator and denominator. So this is going to be our final answer. Hello and welcome to Pre-Algebra Test Section 1 on complex fractions. So we want to simplify each complex fraction, and we just have one problem to work on. So we're going to start out with 2/9 minus 1/27, and this is over 4/5 minus 3/10. So there's two ways I taught you to do this in the lesson. The first method is to simplify the numerator and denominator separately, then perform the main division. Kind of the second way is to multiply the numerator and denominator of the complex fraction by the least common denominator of all the denominators involved. So we're going to use the first method for this problem here, and then when we get to our fourth and fifth section of the test, we'll use the other method. So I'm going to simplify again in the numerator and denominator separately. So for the numerator of the complex fraction, I have 2/9 minus 1/27. So I need a common denominator, and the LCD would be 27, right? I have 9 and I have 27. And 27 you can just think of as 3 times 3, which is 9, times 3 again. So the LCD would be 27. So I can just multiply this by 3 over 3. 2 times 3 would be 6. 9 times 3 would be 27. So I'd have 6 over 27 minus 1 over 27. And then we would do 6 minus 1, that's 5, over the common denominator of 27. Now in the denominator, we have 4/5 minus 3/10. So the LCD here would be 10, right? 10 is 5 times 2. This denominator is just 5. So I can multiply this by 2 over 2. 4 times 2 would give me 8. And then over 5 times 2, which is 10. And then we're subtracting away 3/10 here. So I'd do 8 minus 3, that's 5, over the common denominator of 10. So let me erase this just so we have some room. And I'm just going to write that we have 5 over 27. And this is divided by, or you could say over 5/10. So basically now we just have a division problem. We have 5/27 divided by 5/10. So 5/27 would stay the same. And we'd multiply by the reciprocal of 5/10, which would be 10 over 5. You can see you can cancel this 5 with this 5. And essentially you're just left with 10 over 27. 27 is 3 factors of 3. And 10 is 5 times 2. Nothing you can really do to cancel there. So your answer again would just be 10 over 27. Hello and welcome to Pre-Algebra Test Section 2 on complex fractions. So we want to simplify each complex fraction. And again, I taught you in the lesson 2 different methods to do this. We're going to use the first method where we simplify the numerator and denominator separately, then perform the main division. So we have 5 over 6 plus 1/2 over 5 over 8 plus 3/4. So we'll simplify again the numerator and denominator separately. If I look at the numerator of the complex fraction, I have 5, 6 plus 1/2. The LCD for these two fractions would be 6. So I would multiply 1/2 by 3 over 3 so that I can have a denominator of 6. So this would end up being 5 over 6 plus 1 times 3 is 3 over 2 times 3, which is 6. So we get 5, 6 plus 3, 6. And of course, 5 plus 3 is 8 over the common denominator of 6. Now, in the denominator of the complex fraction, we have 5/8 plus 3/4. The LCD here would be 8, so I can multiply this fraction by 2 over 2. And so I'd have 5/8 plus 3 times 2 is 6 over 4 times 2, that's 8. So 5 plus 6 would be 11 over the common denominator of 8. So we have 8/6 over 11/8, or 8/6 divided by 11/8, however you want to think about that. Let's just erase this and get a little room going. So again, 8/6 divided by 11/8. So all we need to do now is divide two fractions. 8/6 is going to stay the same. And we're going to multiply by the reciprocal of 11/8. So that would be 8/11. And if we look to cross cancel here, I know I can cancel a factor of 2 between 8 and 6. Right? 6 divided by 2 would be 3. 8 divided by 2 would be 4. That's all I can really cancel. So now we would just multiply. 8 times 4 is 32. And 3 times 11 is 33. So we'll end up with 32 over 33 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on complex fractions. So we want to simplify each complex fraction. And we're just going to be looking at one problem for this video. So our problem is 5/6 minus 3 over 2/5 plus 9 minus 1/3. So I'm going to start out in the numerator here. And I'm just going to work on it down here. So I'd have 5/6 minus 3. And because I'm working with fractions here, I'm going to write 3 as 3 over 1. Just make everything nice and convenient. Now I can just think of everything as a fraction. Now, in order to do subtraction with fractions, I have to have a common denominator. Because this is a 1 here, I can simply multiply by 6 to get a common denominator with 5/6. Now, because I multiply by 6 in my denominator, I need to also do the same thing with the numerator. So essentially, I'm going to multiply 3 over 1 by 6 over 6 so that we can have a common denominator. So we're going to end up with 5/6 minus 3 times 6 is 18 over 1 times 6, which is 6. So now that we have that common denominator, I can just write that in my answer. And I'm just going to perform the operation using the numerators now. What is 5 minus 18? Well, we can think about this using addition with integers, right? If I had 5 plus negative 18, we all know how to do this operation at this point. We would use the sign of the number with the larger absolute value. So in this case, that's negative 18. So the answer is going to be negative. And then we would subtract the larger absolute value minus the smaller. So I would do 18 minus 5, that's 13. So we'd end up with a negative 13 as our answer. So I'm just going to throw a negative 13 in there. And so now we have simplified the numerator of our complex fraction. So let's go back up to the top. And we're going to write negative 13 over 6 up here. And now I'm going to focus on the denominator of the complex fraction. So we have 2/5 plus 9, and I'm going to write that as 9 over 1, minus 1/3. So we need to get a common denominator going, and the best we can do for the LCD here is going to be 15. All right, I have a 5, that's a prime number. I have a 1, and then I have a 3. 3 is a prime number. Really, the best I can do is 5 times 3 or 15. So I'm going to take 2/5 and multiply that by 3 over 3. And then I'm adding, I have 9 over 1. I'm going to multiply that by 15 over 15. And then I'm subtracting, I have 1/3. I'm going to multiply that by 5 over 5. Let's scroll down, get a little room going. So 2 times 3 is 6. And that's going to be over 5 times 3, that's 15. And plus 9 times 15. Really kind of a mental way to do this is 9 times 10, that's 90, plus 9 times 5, that's 45. So that's going to give you 135. And all I did, not to kind of get off topic, but all I did was really just take 15 and make it into 10 plus 5. And then I just used my distributive property in my head. 9 times 10 is 90, plus 9 times 5, that's 45. And those are easy to add in your head, right? If I had 100 plus 45, that'd be 145. Take 10 away from that because I only had 90, that's 135. Okay, of course, after that, we have 1 times 15, and that's 15. And then minus, we have 1 times 5, that's 5, over 3 times 5, that's 15. We're going to work left to right because we have addition and we have subtraction. Order of operations tells us to work left to right. So I'm going to do 6 plus 135 first. That's going to give me 141. And then I'm going to subtract away 5, and that's going to give me 136. So this is going to be 136 over 15. So let's erase everything, and we're going to go back and put this as our simplified denominator. Okay, so again, 136 over 15. So now all we need to do is perform the main division. So we have negative 13 over 6, and we're multiplying this by the reciprocal of 136 over 15. So that would be 15 over 136. Now, what can we cancel here? As I see that we have a common factor of 3 between 15 and 6. So 15 divided by 3 would be 5. 6 divided by 3 would be 2. Now, what about between negative 13 and 136? Well, forget about the fact that this is negative for a minute. Is 136 divisible by 13? Because 13 is a prime number. So let's try that real quick. 136 divided by 13. 13 goes into 13 once. 1 times 13 is 13. And at this point, you can stop and say, no, it's not. Right? You can already see that you're going to have a remainder. But just for the sake of completeness, we can continue. Subtract here and get 0. Bring down the 6. 13 does not go into 6, so I'd put a 0. 0 times 13 is 0. Subtract and get 6. So really the answer here is 10 with a remainder of 6. And so we know that we can't do anything else with this fraction because 136 is not divisible by 13, and 13 is a prime number. So we can just go ahead and say that the answer here is going to be negative 13 times 5, which is negative 65, over, and then we have 2 times 136, which is 272. So our final answer here is going to be negative 65 over 272. Hello and welcome to Pre-Algebra Test Section 4 on complex fractions. So we want to simplify each complex fraction using the LCD method. So if we look at this complex fraction, we have 1/2 plus 3/8 over 3/4 plus 1/3. So for the LCD, remember this is the least common multiple, or the LCM, of all the denominators. So you have 2, you have 8, you have 4, and you have 3. So when we think about 2, that's prime, we just put it in. 8 is 3 factors of 2. So I would put another 2 factors of 2 in here. 4 is 2 factors of 2. We got that covered. And then 3 is prime, so we can throw that in there. So we would basically have 8 times 3, or 24, as our least common denominator here. So basically what I'm going to do is I'm going to multiply the numerator of the complex fraction by 24. And I'm going to also multiply the denominator of the complex fraction by 24. Now if I'm multiplying by 24 over 24, I'm essentially multiplying by 1, and I'm not changing the value of the fraction. So let's erase this real quick. So to multiply, we use the distributive property. 24 times 1/2, that's the same thing as saying, what is 24 divided by 2? That's going to be 12. Then plus, you'd have 24 times 3/8. So 24 times 3/8. 24 divided by 8 is 3. Then 3 times 3 is 9. Then this is over. We're doing the same thing down here. We'll have 24 times 3/4. So 24 times 3/4. 24 divided by 4 is 6. 6 times 3 is 18. So this will be 18. And then plus. Next you'll have 24 times 1/3. That's the same thing as saying, what is 24 divided by 3? And that's 8. So you'll have 12 plus 9, that's 21. Over 18 plus 8, that's 26. So is there anything we can do to simplify this fraction? 21 is 7 times 3, and 26 is 13 times 2. No factors in common, so 21 over 26 is our final answer. Hello and welcome to Pre-Algebra Test Section 5 on complex fractions. So we want to simplify each complex fraction using the LCD method. And we have 3/5 minus 1/3 plus 5/6 over 4/5 plus 1/5 plus 2/3. So to use this method, essentially all we need to do is find the LCD for all the denominators involved. So the LCD is going to be the least common multiple of 5, 3, and 6, right? Because that's all we have. We have a 5, these are 5s, a 3, that's a 3, and then a 6. So 5 is prime, 3 is prime, and 6 is 2 times 3. So I just need to put a 2 in there. 5 times 3 is 15. 15 times 2 is 30. So once we have this, basically all we're going to do is multiply the numerator of the complex fraction by 30 and the denominator of the complex fraction by 30. And you can think about why this is legal. I'm multiplying by 30 over 30, which is essentially 1. So let's see what we're going to get here. If I multiply 30 times 3/5, 30 times 3/5, 30 divided by 5 is 6, 6 times 3 is 18. Then minus, next you're going to have 30 times 1/3. That's the same thing as saying what is 30 divided by 3, that's 10. Then plus, next we have 30 times 5 over 6. 30 times 5 over 6. 30 divided by 6 is 5. 5 times 5 is 25. In the denominator, I'm basically doing the same thing. I'm going to have 30 times 4/5. So I'd have 30 times 4/5. 30 divided by 5 is 6. 6 times 4 is 24. Then plus, next we're going to have 30 times 1/5. And that's the same thing as dividing 30 by 5. That's going to be 6. And then plus, next we have 30 times 2/3. So 30 times 2/3. 30 divided by 3 is 10. 10 times 2 is 20. And I'll continue down here. 18 minus 10 is 8. Then 8 plus 25 is 33. And this is over. 24 plus 6 is 30. Plus 20 is 50. So we get 33 over 50 as our answer. 33 is 3 times 11. 50 is 5 times 2 times 5. Not really anything I can simplify between the numerator and denominator. So this is my final answer. Again, 33 over 50.